notably as the sound designer for the award-winning Marina Bay Sands installation in Singapore, which I have personally visited, and it was an amazing experience. Yeah. So thanks for being here, David. Up to you. Yeah.
Thanks very much. It's great to be with you all, even though it's virtual. And I hope you're having a great conference so far. Today I was going to share some things that we're doing at Dolby in the way that we're thinking about immersive media and thinking about this from a multimodal perspective and how this can be implemented so that we can all experience amazing experiences, but in a scalable way that everyone else can also experience as well. So, thanks for the introduction. Just a little bit about Dolby. Dolby is really about enhancing the power of sight and sound so that we can have these great experiences and we can connect with each other with these experiences. The research that's done in Dolby is kind of across the globe, including in India as well. And I'm based in Sydney, Australia, so with our headquarters also in the US. Generally, the way that Dolby likes to do things is by having essentially an end-to-end ecosystem approach where we work with creatives to be able to create great, amazing content. And at that point, we also think about how it could be encoded, the type of production that goes on, and how we can translate that vision not only through the distribution phase, but also right at the experience phase. And you know, whether you're experiencing it on a TV or in a cinema, on a computer, on your phone, all of those, you know, experiences are as true as they can be to the creator's original intent. And a lot of work goes in to try to make that happen, obviously. As you can see with a number of our partners there, that's just a small sampling of the number of partners that we work with. Some of the key products that we have, Dolby Atmos, a way of experiencing spatial sound in different environments. Dolby Vision, a way of experiencing high dynamic range video content. And now with Dolby Vision 2, some other enhancements that mean that a lot more of the creator's intent can be actually actualized at the endpoint. And those two things come together to form Dolby Cinema, which is kind of the ultimate experience of both sight and sound in that regard. So I'm for the Multimodal Experiences Lab, and in this lab, we've been exploring a number of things. We've been exploring various forms of analysis from audio, speech, music, text, video. We've been looking at classification and segmentation and various algorithms. We've been looking also at generative AI for audio text, image video, video text, text to music, and so on. And we've also been looking at methods for enhancement, like source separation, speech enhancement, audio spatialization, and summarization of highlights. And then we've been thinking also about different multimodal representations. So how do we actually store a lot of this? And traditionally, I guess we had codecs, and you know, we're doing things in primarily the codec domain with their own representations. But more and more, we've been thinking more holistically about what those representations could be to connect the audio, the video, and any other modalities so that we have a better representation that can be scaled. The way that we apply this, we have human-computer interfaces and human sensing, whether it's cameras, microphones, sensing engagement and emotion and gesture and all these sorts of things. There's also a neuroscience and perception lab where we try and understand that perception, you know, in a way that we can quantify through EEG and other sort of sensors. And then we've also been thinking about what that means for wearables and more generally physiologically sensing. So today I thought I'd share just about 3 projects, just really quickly, that I've personally been sort of actively involved in, and we can see how we think about things at scale, and we think about how we think about things multimodally as well. So the first one I want to talk about is Dolby Atmos Flex Connect. Dolby Atmos Flex Connect is just something that we recently launched, and you know, for many people, the dream is to be able to have, maybe a cinema environment in the home, something that you can get that cinematic experience. But in order to do that, you have to have sort of ideal room design and speaker placement and high-end equipment. And in order to get that high-end home theater experience. And what we thought about was kind of, well, what's the reality of most people's homes? In reality, everyone has a different home, different spaces. We're using these spaces for more than just watching a movie. We're using it to live in. And so you can't really superimpose, specific speaker locations and all these sorts of things in order to get that experience. And so I guess as Dolby, we decided, okay, well, how can we help bring that to reality? And this is just a brief video on what Dolby Atmos Flex Connect is.
Immersive multi-dimensional sound with Dolby Atmos is even more accessible and cost-effective than a wide variety of supported devices. From Dolby Atmos-enabled TVs and soundbars to high-end home theater systems, but not all rooms are ideal for a traditional speaker or soundbar setup. Whether it's shape, size, furniture arrangements, or even something as simple as the location of power outlets, Dolby Atmos Flex Connect unlocks the freedom to place one or more wireless speakers anywhere in a room without having to worry about perfect placement. By combining additional accessory devices with your TV speakers, Dolby Atmos Flex Connect unlocks the best sound performance, delivering a Dolby Atmos sound experience tailored to your home. Whether you're adding a single speaker for some extra punch, or multiple speakers to create a fully immersive experience, setup is simple and fast, requiring no additional equipment or cables. Microphones in your TV locate each wireless speaker in the room and adjust the system automatically to ensure optimal audio performance. And best of all, you're never locked into a single configuration. Start with just 1 or 2 speakers and expand over time until you find the perfect combination for you. With Dolby Atmos Flex Connect, it's easier than ever to experience immersive Dolby Atmos sound, tailored just for your home.
So that tells you a little bit about what we were trying. You'd be able to add a number of speakers in a flexible way around your home, because you might have a power outlet in certain spaces. And really, what we were trying to do was make setup really easy, make it really flexible, so you could add or move your speakers at any point in time, and then to have it tuned for your system as you go. And so for the setup, we did a lot of sort of experiments with people to see, oh, well, how easy is this to set up? How easy is it to calibrate? And we offered kind of 2 different mapping solutions. So the technology is essentially that these speakers will find themselves in the room itself and map them so that we can render with our renderer the optimal sound for those locations based on your seating position. So we have an acoustic mapping, which basically uses microarrays on the TV to try and locate where these sound devices are, or phone mapping, using your phone, you can also locate those wireless speakers. The flexible aspect of this means that you can start with just your TV and maybe 1 other speaker or 2 speakers, or in the case of the first image, 4 speakers, and you can flexibly move this around. Hence the name. And you can always the acoustic mapping and the phone mapping, and then also the rendered experience. Changing gears a little bit, we also did another project recently, which is, some parts are still ongoing as well, which involves automotive experiences. And here, what we're trying to do is bring Atmos, so spatial sound, vision with our video technology, as well as something new, which we call lightscapes. And lightscapes are really a way of activating LEDs, but in a way where the content creator can actually specify what they want out of the lighting experience. And so this lightscape concept is about being able to maintain the same color consistency that you would expect from Dolby Vision. Also, spatial audio congruence with different things happening in 3D space. If you have a helicopter flying overhead and you've got lights overhead, then maybe the lights go on and follow that helicopter as a searchlight or something. And then, importantly, being able to have the synchronization between audio, video, and lights all at the same time. So, with Lightscapes, we really set out to extend creative color because, for the longest time, people have been creating audio with audio recordings and sound design. People have been making videos. Now we asked ourselves, well, what would we need to do for lights that actually extend the creative color in a scalable way? And so there are three things that we set out to do. One, which is spatial light authoring. So right now, if you want to create a light experience in a concert, for example, or in an architectural, say a building of sorts, then those creations are very bespoke. You have to have exactly those fixtures, you have to be able to dress them in a particular way, and you cannot bring that light creation to another location. And so we set out to try and understand how we could create a new ecosystem to get light experiences from creator to endpoint. And the way that we did that was we thought about using scalable light rendering. And so every room has lights in a different place. And if we could somehow map where those lights are, then we can use a renderer similar to how we do this with Dolby Atmos to be able to render that intent. And then finally, we had to solve the AV and light congruence issue as well. So what is spatial light authoring? Well, we created an abstraction, which is just basically an object in the same way that we created sort of audio objects for Atmos. And as you can see here, there's this blue sphere that's moving around. In this case, we're just looking at the top view. So this is in 3D. And the idea is that you can take these light objects and move them around the room, and our renderer will then figure out which lights and LEDs to actuate at any given time. And this way, when a light creator is making the content, they're not telling a particular bulb to turn on, they're not telling a particular LED strip to turn on, they're actually saying my intent is to have a sphere in the front or in the back. And that abstraction allows us to then scale that across multiple rooms. So in this particular case, we would have a light object, let's just say this blue sphere, and it would have coordinates in X, Y, Z. We would have color and size and effects, and there will be layers and blending and various things that we can do with each of those light objects. We can move them and animate them, and the result is that you can create it once and you can scale it and deliver it anywhere, whether you're in a room or in a car or a venue of sorts, or even AR and VR. What we've done here is we've kind of mapped the fixtures, and you can do this, say, with ARKit and the phone to know where the lights are, or you can just manually place it in a configuration. And if you know each of those lights capabilities, then like Flex Connect, we can now render lights anywhere based on any place video sort of describing aspects of that.
This video practically take your brain on virtual and physical dimensions. Authors place on a series of components of the identity configuration, which have widely
but we're thinking about how people can get what they want in a way that really speaks to them. So what we've been looking at is, okay, well, what happens if you join the game? is if we can understand how these personalized engagement metrics actually look, then we can also design a personalized experience with AI storytellers and AI recommenders that allow us to pull from a content pool of historical. So here's a video, just again, that explains how we're thinking about understanding engagement and understanding our users, putting those two things together and providing options for the users.
During the broadcast, we derived the levels from our data. This metric will be powered for exciting parts of the game and drop when there is downtime. With this knowledge, we enable the experience manager to intervene when engagement is low. Intervention involves surfacing supplementary content in a separate feed on the
I didn't understand that. That is number one. And number two is, how do people monetize this feature, which is so important? So should we call it as a TV feature or a Dolby feature?
Right, and there have been different approaches. So there will be some things that broadcasters might provide as additional feeds, and there might be some things that are offered as cloud analysis solutions, and then some things that are also made available on the actual devices themselves.
I have one question. I'm Shubhajit Rajoudhuri from the School of Computing and Electrical Engineering at IIT Mandi. So my question is that I was actually looking at the immersive experience with your audio, that Atmos Flexi thing. I was just wondering that how is it possible without considering the geometry of the room, without considering the dimension of the room, you are creating a cinema hall-like, theater-like experience with the same kind of reverberation, whatever, inside the room, irrespective of geometry, dimensions, whatever?
Yeah, great question. There are some things that we are learning from the way that we are doing. Making sure that dialogue is clear, and also that the preservation of things moving around you is as true as possible to the creator.
Do we have any other questions?
Yeah, so I have a. Can we mute this? Okay. So yeah, great talk. I have a similar question to what Shubhajit asked just a while back. While a lot of experimentation about the Dolby Atmos, optimization happens in your lab, but when we go to a real world, the room dimensions can change, and more than the dimensions, the organization of the room with the furniture and everything else changes. So I was just wondering, at the deployment time, is it a good idea to just do a quick 3D scan of the room and then kind of use your optimization on top of it? So do you do that, like, for at least for commercial setups and so on? May not be possible in homes, but for some setups it may be possible, because not all the optimization that you do in your lab may sort of may suffice for all kinds of configurations that we come across in the real world.
Yeah, that's right. And the way that we set up and configure a system for a cinema is very different to the way we do it in the home. And as I said, kind of when I was describing Flex Connect, the goal here is to make setup really simple. So that means that anything more than a single button press to get the whole thing going, or needing to use your camera, there probably are options that could help to make that better. But at the present moment, this one-touch thing allows us to use a lot of the acoustic measurements that we're getting between the speaker and the microphones to optimize as much as possible. And you know, for the most part, in the living room space, it's sufficient. If you want to go to higher levels of tuning, you know, we have more in-depth mechanisms that we use for cinemas and other things like that. But I don't know that they're going to bring that into the home environment.
Sure.
We'll see.
Right. Thank you. Yeah, I think that's a very simple answer.
Thanks very much for the question.
Okay. Thank you so much, David, for your wonderful, insightful talk, and we look forward to having you here at campus sometime in future. Thank you very much again for connecting.
Yes, thanks. I love that. I'll be there
Yeah.
at some point.
Yeah, thank you.
Bye.
We will now move to the second part of today's sessions, which is human-robot interaction. And the session chair for the same is Professor Subir Kumar Saha. Dr. Subir Kumar Saha is a professor in the Department of Mechanical Engineering at the Indian Institute of Technology, Delhi, and the project director of iHUB Foundation for Cobotics, IHFC. His primary research expertise spans multi-body dynamics, robotics, mechatronics, evidenced by his establishment of the Mechatronics Laboratory at IIT Delhi in 2001. He's a passionate educator. He authored the widely acclaimed textbook, Introduction to Robotics, and spearheaded the development of robo-analyzer software to make learning robot kinematics accessible and engaging. As a prominent leader in the Indian robotics community, he actively bridges the gap between deep tech academia, industrial automation, and rural development. A huge round of applause for Professor Subir Kumar Saha. I welcome you here, sir. Over to you.
Thank you, Olga, and nice to be on the stage here. Thanks to Laxinder Behera, the director here. And it's always a pleasure to come to this campus with the warm hospitality by his colleagues here. So my job is to introduce the two speakers. So instead of three, we have two, as have been told. So the first speaker is Professor Dr. Engineer Walter Wilhelm Regensburg. Did I pronounce correctly? Yeah. So please come here, and I think our volunteers will connect with your laptop. Walter Wilhelm is a full professor of technical mechanics at OTH Regensburg. He earned his diploma engineer MSc in mechanical engineering from BME Budapest, Hungary. Following research stays at the Universities of Technology in Karlsruhe and Limmenau, Germany, he received both his PhD 2005, focusing on bio-inspired monolithic structures, and his habilitation 2016, specializing in the mechanics of tensor grid structures from Limmenau University of Technology, with extensive experience as a postdoctoral associate and lecturer across several German universities. He has also served as the guest lecturer at Chongqing University, China. His research focused on the mechanical aspects of tensor grid structures, soft robotics, and the integration of smart materials into robotic systems. So thank you. We'll be looking forward to your lectures. I think you have about 30 minutes to speak, Professor.
So thank you, Professor Saha, for your kind introduction. I am very happy. I am very happy to be here and to be part of HiVe 3.0. Maybe you are interested. I come from Regensburg. This is a city in the heart of and maybe you can yeah, maybe you are interested in Regensburg is a city in the heart of Bavaria, Germany, and this is our campus, and this city is a very pleasant, vibrant city. Today, I want to focus on a key aspect in human-robot interactions, namely on safety. We want to preserve human injuries caused by robotic systems, and therefore one possibility is to use appropriate control architectures in conventional robotic systems, but the other robotic systems with inherent mechanical sorry for this, with inherent mechanical compliance. And we are now in the field of soft robotics. Soft robotics is a subfield of robotics with a focus on designing and constructing robots from highly compliant materials. Similar to those found in living organisms. Unlike the traditional robots made of rigid materials, soft robots are built to safely interact with humans and unstructured environments. Here, three core principles: bio-inspiration, drawing design cues from, for example, octopuses, elephant trunks, and muscle fibers. We have to deal here with continuum mechanics. We are moving away from discrete joints to continuous deformations, and we deal here with morphological computation. Just a sentence: intelligence by design, where the physical shape and elasticity of the robot automatically handle environment stabilization without active sensor feedback. The key application areas in soft robotics in human-robot interactions are wearable robotics, for example, exosuits, where soft textile-based suits that assist mobility without the bulk and the misalignment issues of rigid frames, or other applications fields are prosthetics, medical robotics, and of course collaborative robotics. We focus our research on non-conventional compliance structures and mechanism for soft robotics. Here you can see selected examples for these systems, and in the following I want to explain some of our structures and systems. I come to the first examples. We can realize compliant robotic systems by using just monolithic elastomeric structures. For example, in a simple case, you have just a curved, hollow elastomeric structure, and if we pressurize the hole, then we can generate complex, large movements. We can use these structures, for example, as a gripping fingers in a soft robotic gripper. The second example is shown here. This is a small mobile robot. We have here a Stylarc compliant structure made of an elastomeric material with high permeability, and in the body of the robot there are 6 electromagnets, micromagnets embedded, and these micromagnets generate an electromagnetic field, and therefore then forces, and if we use a dynamic actuation, then this vibration can be used to generate locomotion of the system. These two examples are examples for embodied intelligence with predefined properties. We have just two design parameters by these systems. First, the geometry, and second, the material. The influence of both parameters are, of course, essential, and just slightly modifications in the geometry, as shown here, causes the change of the overall behavior of the system. As you can see in the right case, the direction of movement of the finger changes during their movement. These influencing factors are essential by these monolithic systems. "15 years ago, we considered the locomotion, the movement of single-celled organisms like amoebas, and this is fascinating how this simple living organism can generate movement by an internal fluid flow and by changing the compliance of their body locally. And this movement we wanted to use in mobile robotics to generate mobile robots. They are able to move in complex unstructured environments. And if we take a look into the cellular structure of this organism, then we can see that they correspond to a specific kind of pre-stressed structure, the so-called tensegrity structure. Tensegrity structures are pre-stressed structures consisting exclusively members subjected to tension and compression, and the compressed members are connected indirectly only by tensioned members. These structures have specific properties. Their shape is given only by the pre-stress. They are freestanding, no bearings are required. They are filigree due to the only uniaxial load of the members, and external loads are distributed over the entire structure. And we can design these structures with high stiffness, and then they will have a large load bearing capacity, and therefore these structures are also interesting candidates structures for applications, for example, in architecture. But if we replace some elements with high elasticity, with high mechanical compliance, then we can come to structures with very large shape variability. And these structures are very interesting structures for robotic applications. They are foldable. We have here also redundancy if some sensors or actuators in the structure fail, then others can take over their task. And from the mechanical point of view, there are also interesting properties. The change mechanical properties of the system can be realized without changing its shape. Local mechanical load is distributed over the entire system, and a local influence on the system leads to its global shape change. And we have here a key influencing factor in addition to geometry and material, and this is this pre-stress. And if we compare these structures with the structures mentioned above, these monolithic structures, then we can see here an embodied intelligence with actively or passively adaptable properties. And as design parameters, we have here the topology, I mean the amount, the properties of the member and the connectivity. And from the we have here linear material properties, or that we can have linear material properties, and this is the key influencing parameter. This is the pre-stress. In the following, I want to show you some of our systems. This is a preliminary work. This was the first robot that we have realized. This robot had a shape, and the shape can be changed from a cube to a tetrahedron and to a star-like structure, and by relative movement of the compressed members to each other, we can generate tilting movement sequences, and these tilting movement sequences can then cause the movement of the robot. Here is a second example. He asked us how is it possible to realize a mobile robot in the simplest way, and therefore we use here a tetrahedron-like structure built by just two angled compressed members, and these compressed members are interconnected just by eight tangent members. And in the corners of the compressed members there are electromagnets embedded, and if we actuate these electromagnets in a mechanical way, then we can cause vibration of the structure, and this vibration can be then used to generate locomotion. Here you can see the movement rolling locomotion with a mobile robot based on a tensor-grid structure, and therefore we used a simple system built by two angled compressed members, curved compressed members, and on the curved members, as you can see, there will be internal masses moved, and this internal mass movement caused then a global mass shifting of the system, and this global mass displacement leads then to globally uniaxial locomotion, uniaxial movement of the robot. With the help of tilting movement sequences, also movement in the plane is possible. The last example for a mobile robot based on a tensor-grid structure is shown here. This is a worm-like locomotion system with the help of a cascaded structure. Each module is actuated by only one actuator, and if this actuation is done dynamically, we can then generate movement of the system, and we can use such systems, for example, for inspection purposes in pipes. One specific kind of these structures, of these compliant tensor grid structures, are multi-stable structures. Structures they have more than one equilibrium configuration. For example, for this structure, there exists 2 equilibrium configurations. And interestingly, of course, we have different mechanical properties, for example, shape, stiffness, eigenfrequencies, in these various equilibrium configurations, and we have therefore the possibility to a discrete adjustment of the statics and dynamics of a structure by changing between the stable equilibrium configurations. So, how we can find such structures? We have first the topology with as members with a given connectivity and member parameters, and we have this to realize such a tensor grid structures, but the resulting shape is actually unknown. And what we have to do is the so-called form finding process, and at the end of the form finding process we come then to the equilibrium configuration. For form finding we use a finite element method-based approach. We start from an arbitrary initial configuration, and at the end of the form finding process we landed by the equilibrium configuration. And if we vary these initial configurations, then maybe we have the possibility to find more than one equilibrium configuration. As our considerations show, structures with simple topologies can show these desired properties. For example, a structure with 2 equilibrium configuration, this is a 2-dimensional structure, and now we will come also to a structure with 3 equilibrium configurations, and we can change reversibly between these equilibrium configurations, and we can use these equilibrium configurations to have different mechanical properties, a different stiffness, shape, and so on. Here and the following potential application fields are of these structures of will be present. Here first just the idea. We switch between these equilibrium configurations. Global mass shifting will be a result, and this can be used to generate locomotion. The control can be kept simple. We have to just skip between these equilibrium configurations, and then we come to a mobile robot here, a real world application, a multimodal locomotion system. First, vibration driven locomotion, vibration around one equilibrium configuration, and then we come to a tilting movement, and to overcome obstacles, also a jumping sequence is involved. Further application for the structures with multiple states of equilibrium are compliant soft grippers. The one equilibrium state correspond to to the opened state, and the second equilibrium configuration corresponds to the closed state of the grip pair. Actuation is only needed to change between opened and closed state of the grip pair, and the gripping force results just from the pre-stress of the system. By using of these structures with, for example, 2 equilibrium configurations, we can also design and realize robotic end effectors with the discrete variable mechanical compliance. Here a stiffness change can be realized by internal reconfiguration of the end effector. For example, in this state of the end effector, we have for a given force just a small displacement. This corresponds to a high stiffness, but if we change the equilibrium configuration from this equilibrium configuration to this equilibrium configuration, we can see the mechanical compliance of the structure in this configuration is much more higher. We have a larger displacement, and therefore we can set the stiffness of the end effector. This is not just based on this structure. Also several other structures can have this property. For example, tensegrity structure based on 2 equilateral triangles. D can have also 3 equilibrium configurations with different mechanical properties in these configurations. Actually, we want to make these structures very, very compliant, and therefore not only the tangent members are compliant, but also the compressed members. Here you can see an example. Therefore, again, the blue members are the tangent members, and the yellow members are the compressed members. And by proper design, we can have a very large shape variability, but the form remains still stable. This is also a periodic structure consisting of 3 modules, and in the following I will show you some examples for manipulators. This is the first one, the manipulator of the first generation. Here the compressed members are these X-shaped structures, and they are interconnected only by tangent members. These tangent members are highly compliant members, and also members with a low elasticity. Inside the body, the actuation is there with 2 units, and with these units we can change the length of selected tangent members, and this length change can be then lead to a global deflection of the manipulator. As we can see, the relative displacement between 2 of these compressed members can be also very complex. We have good possibility to have large diffractions, and this is a movie of the real prototype. At the first, just simple moving sequences, but at the end, I hope we will see also the movement of the wall system. This is, I think, a good example for a very compliant manipulator, and we can use these systems also, of course, in human-robot interaction. And very important thing is this inherent mechanical compliance. In the following, I show you also the second generation of this manipulator. The topology is nearly the same, but in this case the actuation is an external actuation. We change here also the lengths of wires, and with this length change, the movement of the manipulator can be induced. And maybe I show you just the results of the experiments. These are all real-time movies, and in this upward position of the manipulator, also self-white effects have to be handled. Here we can see also the length change of the system. This is a real-time movie of the movement of the system. Yes, and then in this suspended position, it's much more easier. So further focus of our work lies on compliant tensegrity grids like metamaterials. We have the hope that with the help of these structures we can generate structures with a very large shape variability. And these grids can be used also as a basis for manipulators. And I want to show you a manipulator based on an auxetic tensegrity structure with a biological inspiration. Here is the form finding process for such a grid. And then we will see the properties, these auxetic properties, and then we come to a cylindrical structure, and due to the specific properties of this grid, we can induce control local buckling of the system, and it results in a larger workspace. Here a simulation of this controlled local buckling, and maybe I can show you then the results for the entire system. Here we can see spatial movements, and with this local buckling, a very high deformation amplitudes are also possible. And maybe the last example for such a material, for such a manipulator is shown here in this example. We use here also a cascaded system based on just an X and plus shaped element, and we realized this system, and you can see then the movement in a side view, and then also in a front view. very compliant, very adaptable structures. I come to the last example. We have the idea to use compliant strain-segregated structures also in medical applications. Here an example from us is shown. This is a dynamic hand orthesis, and you can ask me why you make such structures. We know there are many dynamic hand orthesis on the market. Yes, but the problem is that most of them are based on classical pin jointed structures, and during movement the axis of rotation of the wrist changes, and by using of conventional orthesis, there are then additional forces on the wrist, and we want to replace this classical pin jointed connections by a compliant, I see, virtual tensegrity joint, and we can see and we have this shown with the help of theoretical investigations, that the load on the wrist by using of this dynamic hand orthesis can be massively reduced. I come to the end of my presentations. I hope we have seen this inherent safety of these systems, and our vision is to integrate tensegrity architectures into soft robotic systems to enable adaptable and structural compliant platforms that ensure safe and robust human-robot interactions. Of course, this is not just a work of mine. This is our working group, and I am very happy to have also a collaboration with colleagues from IIT Mandi, Professor Sen, Professor Kumar Dar. Thank you for your attention.
Okay. Thank you, Professor Rohel, for your very interesting lectures and the applications in the practical field. Maybe we can take one or two questions.
Walter, very interesting work. So these materials, what kind of material are they, and what is the weight of these compliant systems?
For the tension members, we use elastomeric materials. These are silicon on a silicon basis, and for the compliant compressed members, we use TPU segment, thermoplastic polyurethane materials.
And you have put some small motors inside, how they're moving?
In the last cases, we move our system with the help of ropes, of wires.
Okay.
With the help of inextensible wires, yes. But the idea is also to use shape memory alloys and so on.
Yeah. So, and what is the normal weight of these systems?
For example, these manipulators are the dimension of, I would say, 1 meter, and the overall weight of the manipulator of the second generation is about 1 kilograms.
1 kilogram. Very nice work.
It's a very lightweight structure.
Very nice work. Very nice presentation.
Thank you.
Thank you.
Thank you. Any more question? Yeah. Please take the mic. Okay. Go ahead, Amit.
Yes, so I have a question. You have seen lot of this actuation because nodes are there. So what is the actuating material? Are you doing it passively, or you have active small motors or something which generates the torque, which creates the vibration and the catapulting of the objects?
You mean this mobile robot with this multiple stable
Yes,
equilibrium
yes.
configurations?
Yes.
Yes, we have an overall compliance structures, but
Yes.
also in that case, we have inextensible wires, and with the help of these inextensible wires, we changes relative distances between selected nodes, and this causes then this sudden spring of
So
the structure.
they can also be used for longer motion, trajectory. How do you generate that? You require some active element, na?
Yes, maybe your question corresponds to control issues.
Yes.
Okay, all of these systems are controlled open loop. Okay, these are not closed loop controlled systems. We are not experts for controls, but I hope the colleagues in Mandi are can help us with this respect.
Do you face any actuator uncertainties in these kind of actuators like backlash, dead zone, or hysteresis?
No.
No actuator uncertainties are encountered in this?
Actually, no.
Okay.
Actually, no.
One last question in the back.
But this is a very important point. This is a very important point.
Hey, hi, Professor Walter.
Yep.
My question is kind of related to controls. I don't know if you'll be able to answer, but in normal robotic manipulation, we use impedance control for making our robots compliant. In your case, we saw multiple tendons attached to the structures, right? The tangents that you were saying. So how do you really control the stiffness of each and every tendon to make it compliant? Like, you'll have to control each and every spring, right? The stiffness of each and every spring.
Yes. You mean the manipulator of the first generator with these integrated actuators. And in that manipulator, we have inextensible tangent members. These are the actuated members, but the modules are connected also by compliant tangent members. The overall structure remains still compliant, also in that case.
Thank you.
Thank you. I think a lot of interested questions might come in also, Professor Bohan. Thank you very much. To have a one more round of clap for him. Okay, so we move on to the next speaker, Professor Devashish Ghosh from IIT Bangalore. And his title is Human-Robot Teaming in Air Defense Scenarios. We have been knowing each other. The community is very small in India, so we know for a long time. Professor Ghosh is an honorary professor in the Department of Aerospace Engineering at the Indian Institute of Science, Bangalore. He holds an impeccable academic record, earning his BSc Engineering in Electrical Engineering from REC Durgapur, now NIT. In 1982, followed his master's and PhD, 84 and 89 successfully in Electrical Engineering from ISC. As a pioneer of autonomous systems in India, he founded the Mobile Robotics Laboratory at ISC in 2002. His research portfolio is heavily concentrated on the guidance and control of autonomous vehicles, swarm intelligence, distributed computing, and machine learning for aerial robotics. He is globally renowned for co-developing the glowworm swarm optimization algorithm and popularizing the collision code approach for dynamic obstacle avoidance. He is a prolific author with hundreds of highly cited publications, including foundational texts on divisible load theory in distributed systems. His leadership includes serving as a chair of the Aerospace Department at ISC and convener of the ISRO ISC Space Technology Cell. Professor Ghosh is a fellow of the Indian National Academy of Engineering, the National Academy of Sciences in India, the Indian National Science Academy, and AAAI, reflecting his profound impact on the nation's defense and aerospace computing capabilities. So, Professor Ghosh, we are looking forward to your lecture, the contribution. Thank you. So you got 30 minutes. Yeah. Ready?
Am I audible? Yeah. Thank you, Professor Saha, for that very elaborate introduction, which was most probably not needed. But thank you. It's a pleasure to be in IIT Mandi. I have so many old friends here that it's difficult to go around without meeting people that I have known for years. So it's a pleasure to be here once again. And today I'm going to talk about some human-robot teaming in specifically for air defense scenarios, because I am an aerospace engineer, although I also work on robotics, but most of my work is related to aerospace in some way or other. And I hope I'll be able to convey to you some of the excitement of the research that I do in my lab. Just for a general understanding of what we are going to talk about is, we want to talk about autonomous systems. So we all know what general autonomous systems are, systems that can react to the environment on their own based on intelligence that is inherent in them. We also have an autonomous network of systems, so where we have a network of systems which are in themselves autonomous, or we can have a network of autonomous systems where there would be many autonomous systems working in the network. So these are two different things. The second one is a generalization of the first one. And then when we talk about autonomy, there are lots of things that people understand by autonomy. So there are levels of autonomy that are of interest to us. And as I said, since I am an aerospace engineer, I like to look at autonomy from the point of view of a aerospace system. So in my next slide, I'll show you a general configuration of an unmanned aerial, surface, or underwater vehicle, which essentially consists of 5 main components: the structure of the system, the sensors that it carries, the communication electronics, the computing resources, and finally, of course, the business end of the whole thing, that is the payloads there. So collaborative autonomy is where you have a network of systems which collaborate with each other. So in this picture, you have a cartoon of a group of flying vehicles, a group of vehicles on the surface of the ocean, and there are humans also who are a part of the whole system. So this whole thing consists of a robot and human teams, where the robots are essentially autonomous vehicles. So I mentioned about the levels of autonomy. So let's look at what are the different levels of autonomy that we see, especially when we talk about aerospace systems. So if you look at the bottom part, so there are about 11 levels of autonomy that has been defined by researchers who work on autonomous systems, especially in aerospace engineering. The first 5 levels are autonomy. So essentially they talk about autonomy of a single vehicle in different ways. So we have this remotely piloted systems, then remotely guided systems. So remotely piloted, when the pilot does everything, it gives commands to the system, for example, a drone pilot. Remotely guided is when it gives destinations to this system and it goes from one destination to another. The second level, next level, is the real-time health diagnostics, adaptation to flight and failure conditions, then onboard route replan. So this is as far as the solo autonomy is concerned. After that, we have group autonomy, where there is a group of autonomous systems which can coordinate with each other, and as we go up in the autonomy level, we have capabilities of tactical replan, tactical goals, distributed control, strategic goals, and then a fully autonomous system. These are standard levels of autonomy that people know of. However, it may give the impression that after you leave the level 0 and 1 and go higher up, you do not have a human anywhere in the system. This is simply not true, because we haven't yet created autonomous systems that do not have a human supervisor. One of the reasons is not that we cannot do so. We can, in a small way, we can do so. But when we have systems which are autonomous and we want it to work in a larger environment with people who can be at risk, then we always want that there should be some human control. So till now, there are no operational autonomous system without some human control when it comes to aerospace systems like drones or other things. So we'll discuss this a little more, a little bit later. Here is an interesting document that came out as a US government Department of Defense UAV roadmap. It came out in 2017, which is about 8 years behind us now. And it was a document that covered 25 years of development in unmanned systems or autonomous systems that was put together by some of the best minds in the US defense system in 2017. This is a 25 years vision document. Let's see what happened to this vision document. So this was actually done to create a overarching strategic guidance, and some data is given as to the market size of unmanned systems and so on. These are interesting things, but not quite interesting for us. So let us look at two tables that appeared in this document. The first is on perspectives on autonomy in 2017. That is, what will happen to the concept of autonomy when it comes to actual systems over the next 25 years. So there are three things here. You can see artificial intelligence, machine learning is one, increased efficiency and effectiveness, trust, and weaponization. And there are three stages in time which is given here. That is the 2017 to 2029. That is about 12 years down the line. It's called near term. The mid-term is around 2029, and the far term is 2042. So in 2017, the best minds in the US defense thought that this is how the things will go. That is, in the near term, we will have private sector collaboration, cloud technologies, increased safety and efficiency, DoD strategy consensus, laws assessment, and so on. Then around 2029, you would expect augmented reality, virtual reality, unmanned tasks, leader-follower structures, and so on. Far term, 2042, 25 years from 2017, will be persistent sensing, highly autonomous systems, swarming, armed wingman, teammate, that is when human and machines work together. What happened in reality is this table has become obsolete. Why? Because in 2022, 23, 24, there was such an advancement in artificial intelligence that we all know of. It disrupted many things. It disrupted this table also. Whatever we were thinking of happening in the midterm is actually happened now. And whatever we are thinking of happening in 2042, persistent sensing, highly autonomous system, is almost round the corner. So what we thought of in 2017, there was a disruption in technology that happened in the last 3 or 4 years, and everything changed. The pace of advancement became so fast that it actually covered all of it. In fact, what is predicted in 2042 will most probably be done by 2030. Since this conference or this session is about human-machine collaboration, let's see what this document predicted in terms of human-machine collaboration. It predicted these kind of things: control of multiple systems, human-machine roles and queues, human-machine dialogue, what-if scenarios, and then infer human intent, deep learning machines. So you can see all this, again, near term, mid-term, and far term. And you can see that many of these things have actually been done or are being done. We are in a very advanced stage. So what will actually happen in 2042, most probably even we will be scared to predict. The interesting part is this middle row, which talks about human-machine teaming. So here you talk about fully integrated robot teammates, reduced warfighter cognitive load, and so on. All the work is going on here. The idea of taking the human out of the loop is still not something that is acceptable by one because of the risks that are involved. So I believe that the report, what it predicted about human-machine teaming, is most probably still correct up to a certain point, where the human aspect of teaming will still remain important. So when we talk about human-machine teaming, actually there are two concepts. One is the human in the loop and human on the loop. Human in the loop is when the human becomes a part of the loop where decisions are being taken and human is directly involved in it, whereas human on the loop is where the humans supervise an autonomous AI. They are in a supervisory capacity, and this is what we are interested in. So remember that supervision is not easy when the speed of the autonomous system is very high, and the human supervision will only slow down the process. So what is the way to handle this is that if we can trust what the autonomous system is doing, can we increase the probability of, or can we decrease the probability of errors that can happen in a system like this? And that is the guiding philosophy of the research that we do. That is, how can we improve the capability and the trustability of autonomous systems. So since I'm an aerospace engineer, I use drones extensively for various kind of application, and in this we talk about payload delivery, surveillance, exploration, and there are different missions that are carried out in swarms. In this, the precision is very important. The path decided by the system for multiple drones to fly must be adhered to. Even when the paths are adaptable, they change dynamically, they have to be precisely followed. When it comes to drones, the notion of safety is twofold. One is being safe, the drone has to be safe, it has to impart safety to the environment, which means that when you fly a drone, it must fly in the path that you have designated for it. And that is the idea that we are going to work on. Because if you have that confidence in the drone system, then the human can actually reduce its load. So just a example of what we do. So there is a surveillance or exploration application where drones are used to explore or survey a building or a ship which is moving. So in one case it is stationary, and in the other case it is moving. So I'll just see you a couple of very simple simulations where we have buildings of 3 different cross sections where the drones go fly around, but we use the concept of Lissajous curves to define these trajectories, but they have to be accurate, so the accuracy is ensured by a mechanism that we are going to talk about later. So in this you can see there are single drones, multiple different shapes, buildings, and so on. This is where we have a ship which is moving, and the drone is exploring or surveilling the ship. So when we talk about this movement of drone in the class G airspace, it is typically in the airspace very near to the ground. So less than 1200 feet, it can change depending on the place where it is being defined. And we want to define corridors for these drones so that we can be confident about their safety. So we are talking about this corridors or corridors for drones in the sky. And in a cityscape, you can see that there would be virtual corridors. These are not actual corridors. You cannot see them. They are virtual corridors which are a part of a smart city where the drones can fly. They can also be used in various other applications. We will see them later. How do you define that? How do you decide, or how do you ensure that the drone will fly inside the corridor? So what we do is that we define a cylinder like this, which is kind of a cylinder which is moving in the corridor like this, and the drone tries to stay inside this. This is what even aircraft do. They actually fly in a matchbox shaped cube of air. So it is like this. We define it as a cylinder with a drone inside, and this flies through this. So how do we actually define this cylindrical object? We do that by using what are known as geofences. So geofencing is done to tell the drone where it can go and where it cannot go. For example, we have this stay out geofence here, where the drone cannot enter. The stay in geofence where the drone should stay within this. Similarly, I can have a geofence around an obstacle or a geofence around a drone itself. So by defining these geofences, we can actually increase the safety of operation of a drone. So here are some technicalities here. So you can see that when a drone is flying through a cylindrical geofence, we have the outer fencing, then we have the inner lane fencing, and then we have a core fencing which is around this. So there are 3 layers of geofences we use, and the dimensions of the geofence actually depends on the speed at which the drone is flying. So if it is hovering, then that cubic geofence is very small. If it is low speed, it expands. If it is high speed, it expands even more. So it can go through straight lines, it can go through curvilinear paths, and so on. So we can define these geofences to increase the safety of flight of these drones. So here you can see that we have a much larger system where we have the corridor system, and there is a human operator which operates the ground control system here. Similarly, we have a geofence where there is a UTM, unmanned traffic management system, which is a part of which is integrated into the corridor, and there is a corridor interface through which the human operator works. The video you see here is something that shows in a simulation how the drone can stay inside the geofence, and is always, it is pushed into the geofenced corridor whenever the drone comes close to the boundary. You may now say that this is all simulations. Everything works in simulation. So what's new in this? Are we actually doing anything useful here, or just simulations? So here are some experiments that we have done using the same geofence. There is a 2-lane corridor that we have created inside the lab with a motion planning system. And those who work on robotics would know that with a motion planning system, again, you can do many things that you most probably cannot do in the field. So we have these virtual corridors here through which the drones fly, and you can see that these drones can fly very close without colliding with each other. So that increases the safety of the system. Well, this is inside the lab. Can we do somewhere else? So here we are. So now we are out in the field. There is no motion capture system. So the geofence software is now residing inside the drone, and now you can see that it flies over this corridor like this, and you can see that the moment the drone comes close to the point where it is trying to breach the geofence, it is pushed back. So with this, now we have a mechanism by which we can ensure that this drone will not cause any kind of risk to any other drone or any other structure. So that was in a limited place. Now we have done it for a much longer space where the drones fly through this. This is a slightly older experiment that you are saying, but now we have done multiple drones with much closer geofences or cylinders. We have built a complete system called Concord. So this Concord system is a conflict detection and resolution system using a concept of correlated equilibrium in game theory. So this has been used to define the motion of drones, of multiple drones in an aerial space which do not collide with each other. So it contains the idea of a geofenced corridors as well as conflict-free flights. This Concord system has been integrated into the UTM, that is the Unmanned Traffic Management System. This is the whole, it's a cartoon of the thing, and you will always see that there is human operator, that is the traffic manager and the pilots here, and there are human operators here, which talks about the way the system is working, that the task scheduling, UAV, TMS, operators and service providers and all that. So this is a system that has both human as well as the UTM as the corridor architecture built into it. We have carried out our experiments in our airfields here. So this is where all the systems have been tested. These are the schematics of what we did. So this is our building and this is the second ISC campus in Chalikari where we carried out these experiments here. Now you may say that this looks very nice, or, well you may say, I may say that it looks very nice on paper, but how about using it for actual commercial exploitation? Can we do that? Because ultimately engineering has to be used somewhere. So all this technology has now been transferred to a company called Algobotics, who has actually created this UTM system using this, whatever you have seen till now. It's called Ubix Automatica. So the Ubix Automatica has this whole drone corridor architecture in it, plus several other aspects of using drones in any place where there could be buildings, there could be other flying objects and so on. It can be used for drone delivery, asset monitoring, remote sensing, disaster, law enforcement, environmental monitoring, and so on. So this is what this company is now has designed, and I will show you one of the products of this company, again based on whatever development you have seen. So this is called the Ubix Ground Control Station, and if you look at this picture here, this is not a cartoon, this is an actual system. So you have, this is a 4-drone system where we have the 4 drones here, and there are screens here which can actually track the flight of the drones through this, and it can be controlled through this console. So when we first designed this and we showed it to people, the Indian Army actually came to us saying that this we don't want. We need something that can control 10, 50, even 100 drones. The technology was right here. We were demonstrating with 4 drones, but it could very well be used for much higher number of drones. So the current design that we have, which for proprietary reasons I'm not showing here, is something which is actually smaller than what you see here, because it doesn't have the drones in it. The console is only this part, so it is just like a slightly bigger laptop. And with that, we can control. Right now, we have done up to 10 drones, and we are now testing for higher numbers. But this is what now we are working with the Indian Army to produce this. Some of this, we have already got some procurement orders for this kind of thing. I'll show you some of the stuff that has been done. So this is a place where there is a lot of autonomy into the system, but there is a human control also. So this is for the communication. We developed our own communication stack through 5G and 6G, 5G and 4G. So this is our own product. And let me see. So this is the drone console that you saw right now. As I said, right now this also contains the drone themselves, but the current console is half its size, which can control many other drones. So right now we have the facility to control 4 drones. When we have larger number of drones, the drones have to be carried in a separate vehicle, but it can be placed anywhere and then controlled from the system. So we define the area which the drones have to do a surveillance of. So you see there are 2 drones which are flying here. They fly through the corridor architecture so that they do not dash against each other. They can do surveillance in the sky in a limited area. And then they can actually come back and land. So whatever you have seen till now is something that has actually been gone into production. There are several versions of these drones, for example, voice-activated consoles and so on that we are producing right now. And this is a successful product that we have. The next part that we are trying to do, which I am doing with collaboration with Professor Pradipto Biswas in IISc, is about VLA-based multiple robot teaming project. So essentially the idea behind that is that LLMs have been recently used to bridge the gap between natural language commands and robot actions. For example, I have a drone here and I ask it to turn left. I can just say turn left, but it has to be converted into a robotic command. So this is something that people are working on, but there is still a gap that exists between integrating human awareness into the robotic task planning. For example, I can just give a command saying that turn left, but I do that by also looking at what is around me. So how can we transfer that also into the robotic system? And so we are trying to explore that particular idea here by leveraging the LLM capabilities. So we use a visual language action model system for this teaming project, and we focus on collaborative task distribution among multiple agents, enabling robots to perform complex tasks in dynamic settings. Let me give you an example. Suppose you have 3 robots and you ask them to turn left. 2 of them can do so safely, the third one cannot because of the environment. So can we impart that concept or that idea into the robot through this simple command and the awareness of the environment too? So this is what we work on here. This is work in progress, so not a lot of things have been done, but we have an idea about how to do this. So we build a task scheduler, a map generator, a path planner, and a manipulator module. So this task scheduler and the map generator is the one that actually creates the safety aspects of this whole operation. So once the robot starts moving, then there is a computer vision module and a local planner will guide it through obstacles through a 3D reconstructed map. So this is the overall workflow. I will not go through the details, but this is how it works, and the human feedback comes from here. This is the swarm motion planning. When there is multiple robots, how do we control them? We actually want to do all this for the drone system that we have. That is a network of drones. We want to control all of them through this. These are just some of the prior experiments that have been carried out in Professor Biswas' lab, which will go into what we are going to do here. Before I end, I want to talk about something that is very close to my heart, not maybe related to what we are talking about. These are the ethical questions of using very intelligent robots with humans in the environment. So long time back, when Isaac Asimov wrote his science fiction stories, he talked about the 3 laws of robotics, which nowadays people usually don't take it seriously. They talk about it as if it's something to be discussed in a humorous way. But the way the robots are becoming intelligent, these are also becoming very important. So the Faustian dilemma of how much can you barter with the devil is very real now. Let me show you one last picture before I end. So these are the 3 laws of robotics that Isaac Asimov has. So this is a cartoon of why Asimov put these laws in this sequence that it did. The first set is the one that leads to a balanced world. But when it goes to the second, third, fourth, where you juggle with the sequence, you get very, very dangerous situations. And since there is nothing that tells us how to put these laws in order, we can easily land into one of these very dangerous situations. This is a cartoon. People laugh when they see this, but it's something that is very, very serious when we deal with intelligent robots. So we must have a design of ethical swarm. So there's a wonderful paper that has come out very recently in the Philosophical Transactions of the Royal Society. I urge you to read it, about ethics of swarm robotics. And with this, I end this talk, and thank you very much for your patience.
Thank you, Professor Ghosh, for a wonderful lecture, particularly. Now, we would like to buy one of those your sets for our drone technology park in Sonipat, which we have been trying to build over several years. Anyway, so floor is open for questions. Couple of questions. Anyone? Yeah, there is a hand.
A very nice talk. So I always love to hear. Every time it's new talk, so I always enjoy it. So the tubes that we create and the controls. What is the control? Is the feedback as a function of those tubes that allow the drones to remain inside? Does it not saturate the control efforts?
So each of those, the geofence, the corridor software resides in the drone itself. So right now it uses GPS information to keep within a certain area. So depending on how accurate your GPS information is, how compliant your drone is, we have to define the size of the corridor, right? And with the inaccuracies of the GPS and the lower compliance level of the drone, this area can expand. But if GPS is accurate and your drone is compliant, then it can be a very narrow area also.
So there's a control which keeps it towards the center of the tube?
Is inside the inside the drone itself.
And it's a function of those tubes?
Yes, yes.
Thanks.
Okay, one more here.
So again, nice talk.
Thank you.
So you talked about human in the loop systems and human on the loop system. So how do you figure out through an AI system when does it need the human interruption? Like how do you measure or signify or find it out that the human intervention is right?
If you're talking about the human on the loop, which means that the human must have is monitoring the operation of the system, right? And it must have a way to elicit information about the performance of the system itself. So if it deviates from the expected performance, then the human can step it.
Yeah, thank you.
Sir, Vinita this side. Sir, actually I'm also working on drone. So basically, my problem statement is to make a drone autonomous. So like I have one doubt, like let's suppose we have given a geotagging path to drone. So drone is following that like geotag location. So can we say that the drone is like autonomous or something? So what is the level, like how can we define and when can we define the drone is autonomous?
Right. So that depends on the kind of mission that you carried out. So there are different, as I said, there are different levels of autonomy. For example, if you ask a drone for go from point A to B, or go in a circle, or go in a path that is predefined, then that much is the external input. But after that, the drone can do so on its own. So that part of it is autonomous. But suppose there is a problem with one of the propellers. The drone may not be able to handle it. So there, its autonomy gives up. It doesn't have. But there are also algorithms by which even slight imbalance in the propellers, the drone can deal with it. Right? Even one of the propellers breaks, it can still fly with 3 propellers. So if the drone has that kind of capability, then its autonomy level is even higher. So depending on how it handles any unplanned events, defines its autonomy.
Okay, sir. Thank you, sir.
Yeah.
Shantanu, yes.
So, thank you for the talk. I think it's a beautiful talk.
Thank you.
I just have a question, but which is in a different domain slightly. So you're using these very large action models.
Yes.
So but the problem with very large action model is in many cases it may generate an action sequence which may not be a valid action sequence.
Correct.
So how are you dealing with that?
Yeah. So this is a very important question in all these action models that we have. It is especially very important for a case where we are using a swarm of drones, because if the action sequence that is generated is not as per what we want it to do, it can create a lot of harm. So I think we must have a monitoring system that tells us that it is not behaving the way it is and you have to kill it. So that is what we do for human on the loop kind of thing. But at the same time, we are also careful to see that these kind of action sequences are not generated, because if we try to evaluate every sequence of action that is done, then it will delay the whole thing a lot. So I think this is a dilemma that we still need to solve.
Okay, last but one there, last would be mine.
Yeah. So this was an engaging talk.
Thank you.
So it's actually contrary to your last slide. I'm assuming a drone warfare scenario. Now in the warfare scenario, we cannot always define the tube that you're talking about. So in that case, exploration is needed. I mean, based on the current scenario, the drones need to change their path. So how do you deal with this scenario?
Yeah. So that's right. But at the same time, this corridor scenario still applies there, because I haven't talked about it, but we also have dynamic corridors. For example, I mean, it's very natural to have them, because if you're flying a drone from one point to another and there is a wind gust, let us say, and you know that there is a turbulence in the air in that area, so you actually change the path. So exploration also, you actually change the corridors to do this. So the corridors are still applicable there. Yeah.
Sir, I
Okay. So maybe later on, last is mine. Okay.
Sir,
we can do it afterwards, because I think next session is waiting. Sorry about it. My last question is very simple. If GPS denied scenarios, how will you get the signals?
Yes. So we are actually working with a sister company in Art Garage, that is a TIH in Bangalore, so who are developing this GPS denied navigation system using visual odometry. So we are also working with them to incorporate it.
Okay, so big hands to Professor Ghosh.
Thank you.
So with this session, I hand over to the organizers.
Thank you, sir. Thank you very much for sitting here for 2 wonderful talks. And I also thank our session chair for being here. So now we would like to felicitate our speakers as well as the session chair For this, I call Professor Dipankar Dev, our own care professor as well as director of Catalyst, Incubation Catalyst here. So, so can you come here, please? We can have a photograph as well. Professor Walter Bohm has left for some important meeting maybe. So I will call upon our session chair, Professor Subir Saha from IIT Delhi. And thank you, sir. Thank you for being our session chair here. Thank you, everyone. Thank you for being here. So we'll have 15 minutes break, tea break, and we'll assemble back here for our next session. For our next session, so we have again a list of speakers who are distinguished enough in their fields and have a lot of expertise, and we are going to hear from them. So first of those speakers is Professor Abdurrahman Keddar. So he is from CNRS, Paris. I will read a little brief bio before he starts his lecture. So Professor Keddar received his BS in Computer Science from AC Algiers in 1990 and MSc and PhD in Robotics from Paris Sorbonne University in 1993 and 1997 respectively. He is Director of Research at the CNRS. He founded and directed the CNRS AIST Joint Robotics Laboratory in Tsukuba, Japan from 2008 to 2021 in France. He created and led the Interactive Digital Humans team at LIRMM, University of Montpellier. Since 2020, he leads the Bionics platform at Cartigan at the University Hospital of Montpellier. His research spans from humanoid robotics, multi-contact motion and interaction, haptics, brain-machine interfaces, and human-robot collaboration. He is an IEEE fellow of the Asia Pacific Artificial Intelligence Association, vice chairman of the International Artificial Intelligent Industry Alliance, and there are a lot more. So, and he has been the editor for lots of leading journals like IEEE Transaction and Robotics, IEEE Robotics and Automation Letters, and so on. In the interest of time, I will stop here and will welcome Professor Keddar for his talk.
Okay, thank you very much. Is it working?
No, it's not working.
So thank you very much. So in waiting for this to work, I would like to deeply thank Professor Behara for the invitation and Dr. Amit Kondi for pushing me to come here, and also for Narendra and for Amit, okay, to organize my stay here so smoothly. Thank you very much. And I listened to your talk yesterday, and I was wondering whether I am here by chance or whether your consciousness theory works. And in fact, together, we are first visited the US on the same year, on 1997. For our first trip, you came from India, I was coming from France, and we visited the USA for the first time the same year. And in fact, we attended the same conference, yes, by Usama Khatib. And since the history turned to repeat itself, so at that time I was doing telerobotics, he was doing humanoids, and now I'm doing humanoids, he's doing telerobotics. And that is another point. We first organized Roman for the first time in our respective countries. I was co-chairing, general co-chair of Roman in 2001 in Paris and Bordeaux, and you did also though. So we have a lot of commonalities, yeah. So I'm not sure whether this is by chance or your theory has maybe explained how this coincidence come. Anyway, thank you very much again for the invitation. And I will be speaking about enabling physically intelligent humanoids for human mobility. So I have so far led 2 labs until last year. So since 2004 until like last year, I was in Japan, where I settled a joint CNRS-IST lab working on robotics and more specifically on humanoids. And I also settled the lab in Montpellier around the same thematics in 2012, because I was supposed to come back to France, but because of what happens in Japan, I extended my stay at that time. So I used to have a slide in which I show the progress of humanoids, but then I stopped doing it because since around the 20s, okay, the humanoids has boomed, okay, extraordinary, and now we have more and more systems that are not prototypes, that are really robotic systems that are ready to be deployed. And there is 3 categories of companies that do, okay, these humanoids. So there are humanoids that are made inside companies like Xpeng, Honda, Kawasaki, so they build their own technology. There is also the companies who build humanoids and then pair with giants, like for instance, you see Aptronic with Mercedes, Figure has paired with BMW, and Digit, the American one, has first like paired with Ford and then Amazon. And yes, and there are some companies that are building humanoids that didn't find any market yet, of course. So, short, what is these robots used for? In my opinion, there will be 3 major applications where these humanoid technologies can be deployed, or this type of robots are deployed. The first one is manufacturing, but not what you see on YouTube. There are some manufacturers that are really in need of such technologies. I can expand them later, okay, but most of them are large-scale manufacturing. And I will explain through examples, okay, some of these applications. The second one is for human assistance, but in my opinion, this would come probably later. And the third one is, of course, the defense and the military. So I have worked on the 2 first sectors so far, and I didn't work on the third one. So because the talk is more focused on human assistance, so I will still show you, okay, some of the things that I did with my team. So we were the first in February 2019 to show that humanoid robots can be used in manufacturing. It was a joint project with Airbus, and it was the first time that a humanoid have ever entered the company, okay? And it was in Airbus, Saint-Nazaire, and the reason for Airbus to consider this is that I was surprised to see that inside the Airbus airplane manufacturing, there is no robot. Most of the things are done by human workers, and in fact, the reason there is no robot is that contrary to car manufacturing, the car, you have like a chain, and then you have the car is moving, and some robots are fixed, and then they do the tasks. Okay, but you cannot do this with an airplane, because you have to put the robot inside the product to do the automation. And they need to be mobile, because they cannot be fixed, okay, on the product. And this is the reason why Airbus was trying to figure out what are the best technologies, okay, in robotics to automate some of the tasks that are made inside the product. And in fact, you will see this problem occurring also in large-scale product manufacturing, like shipyards, building, in any place where you cannot put, the product cannot move, and the automation should be inside, made inside that product, then the only possible solution is to have like a robot that is moving inside. And in most of the cases, this robot takes the form of the human, because everything has been taught for human workers. So the first video there is showing really the demo we did, like it was at that time a prototype, and then we entered. This is a real aircraft, okay, it's 1:1 scale, okay, and in fact in the aircraft there is about 10-digit thousands, I'm not allowed to disclose the number, of brackets that are the pinky one you see, to place, because this bracket will hold the cables. And in fact, what they needed, I can give you, of course, numbers. It takes 12 minutes, okay, for a worker to do, because he has to take measurement, and they wanted to reduce this, okay, and you have, this bracket has to be placed basically everywhere in the airplane, in the cargo, the aisle, the cockpit, okay, and they wanted this to be automated. The rifting is also an important problem. The reason is that they have a huge stress to hire people to do this task, because they are not really rewarding in terms of cognitive capabilities. And then, of course, if you do this, the robot has to evolve. And the reason we did this is because we were working, I was the first to propose this concept of multi-contact planning and multi-contact for robotics when I went to Japan, because I was surprised that most of the people were working on walking or manipulation, but never on both, okay, and never like, for us human, if you want to take something down, we naturally, intuitively take additional support, okay, to increase our balance or to increase our strengths, and these behaviors were not implemented. But Airbus at that time was very interested in this idea that the robot can take support, okay, to do the task, and they can be balanced and safe. So then the follow-up, this picture down showing also the robot entering, okay, inside because the shop floor in Airbus is something that is moving, it's not something static, so you can find sometimes the robot has to enter the shop floor to do some task, like here. Okay, they enter down, and then they have to take the tool and then to do the things again. And the upper right part with is a project with Michelin, okay, the tire company in France. But most of these tasks, in fact, they have a common denominator, which is that they are non-added value tasks that need to be automated. Okay, and it was complex because in Michelin you have to carry all these tires from one spot and then to put them in this unwinding machine so that the gum which is inside is implemented inside this automation, and this was done by the human, and it's not a rewarding task as well. As for the last one, it's something that we started with Van der Lende, which is a logistic company, okay, one of like the major logistic company, which is from the Netherlands, and they wanted to automate also the logistics, like grabbing boxes, putting them from one conveyor to the other, and then go to another conveyor to do the task. And they needed something which resembles human because of the cumbers, because the space, okay, where this is done is narrow, and they wanted something to be mobile, and it's the same, okay, problematic. So basically, if you want to use humanoids, it's always about how to, I'm not sure whether this is not working. Okay, I will just go back and then do it again. Okay. Here you can see that the robot has to enter, and the idea here is that you see by the right arm is grabbing, okay, to hold its balance, and then you have 4 contacts, okay, and then going into the task and screwing the things. This is also from Airbus, because the shop floor is a dynamic shop floor inside the airplane. You have to remove it to enter. I do have plenty of pictures, of course, for that, but it's not the purpose of the talk today, so I just wanted to give you a hint. And the other applications I spoke about is for assisting people in need. So many people, when we speak about assistive technologies for people, they think about, of course, aging person or frail people. But in fact, you can be very healthy, and sometimes you get an accident and you are just stuck at home for like 2-3 weeks, and you would love to have something to take care of some business you have in homes. So there are plenty of applications, okay, where this robot could be, of course, very useful for assisting people. Of course, aging is one of the issue here, because in Europe there is a strong policy in trying to sustain elderly people as much as possible at houses before going to the elderly houses. So then the more they sustain at home and stay at home, the better it is, even for the people. And the idea is not to remove a nurse or to remove relatives to come. But you know, a nurse in France will come maybe, even if she comes once a day, she comes for 1 hour, okay, to check and everything. But then the whole remaining time, okay, the person is alone, okay, and he might need an assistance for a robot that's not necessarily being very intelligent, but at least that can handle the situation of some daily, really simple tasks, going to the bed, going to the toilet, stuff like this, and how we can make this happen. So we started, so this is also same thing, non-added value task for the nurse. So we started this with like a very theoretical thing, okay, that we are doing just for research purpose, how to make this robot collaborate with human, holding like a table together, holding a table while keeping a ball. So what is the advantage of having a humanoid robot to use both vision and force? And then we had a project, a huge project with Honda, because when I did the demo with Airbus, so I invited Honda and Kawasaki to come to Saint-Nazaire in France to see, because when we finished the project in Airbus in 2019, Airbus said to us, okay, we want to buy this, but who is providing this robot? And at that time, no company exists, okay, to provide a robot with the norm of manufacturing robotics. So then Honda told me that they have no interest in doing business-to-business product, but they are interested. Honda is, of course, the father of Asimo, to pursue research and R&D for business-to-consumer humanoid. So they wanted such kind of application for elderly people, help, houses, etc. So we started with them a project, and then we were thinking about what are the bricks that are necessary to make such robot one day useful and deployable at houses to help, like to assist elderly people and to assist in the mobility. So then, if we have such a robot, okay, so on the left you have what a nurse would do, okay, to help a person to stand out of the bed, etc. And on the right is what could be the projection of that. So the first thing nurse does when she goes into someone's house is to speak, of course, to exchange, hello, how are you? Are we going to do this? Are you feeling hurt? I'm going to place my hand there. And this problem, I suggested to Honda to not tackle it, okay? Because the advances in LLMs, okay, such as ChatGPT and also Claude, and there are many, many others, okay, would solve basically this problem of communication between the human and the robot. And if it is on the case of a robot that is going daily to the same person, so I think he would probably learn how to talk and how to say hello and how also to exchange about the condition of a person. So in my opinion, roboticists shouldn't really focus, or companies like Honda, I told them not to focus on that because others are doing it, basically, and they are doing it better than you. Don't spend your money for that. The second technological brick for the robot is, of course, a robot needs to be aware of the state of a person, okay, and then it comes into a tracking. Okay, so the robot needs to know where is your arm, where is your back, where is this, because he needs to touch you and he needs to assist you in physical interaction. Then we need this information, and this information, unfortunately, okay, there is advancement a lot in AI community, but many of the tools that are developed do not apply, okay, directly to humanoid robots, and they are not, or in robotics in general, because they are not robust, okay, and you cannot rely a lot on them, okay, to make closed loop control, for instance. So this is one of the things that need more research, and more importantly, the robot needs to know what are the contacts that a person is having with the environments, okay, and if possible, what are the estimation of the forces, okay, that contact induces, because it's important for it after to be included in the control. So we have worked on a very challenging topic, okay, which is still an open area of research, is how we can determine the contact between a person and its environment and an estimation of contact forces, okay, at the contact spot by using vision alone, okay, without using force sensing, for instance. That is really an important thing. We started to work on this, and we have published an interesting paper on how you can get contacts and force estimation directly from vision. I will not show the video of this one because I think it will take time. But if you are interested, I can show it to you later on how we did, okay, and we used AI basically to estimate all this, and maybe just a few, not all of it, but maybe just if I can have the mouse, okay, just having, the idea was basically if we can track the motion and we know the inertia parameters of the object, then we will be able, by using AI, to guess what are the contact forces and to guess, of course, where are the contacts. And we have tried this with having an object that is manipulated, okay, and then basically we manipulate an object that we know the inertial properties, and then we will be able to infer to the contact by using AI techniques. And the idea is extremely simple. So you have force equal mass dot acceleration. If you know the acceleration, you know the mass, then you know the forces. The acceleration is the motion, basically, and then you have the contacts, and the whole thing is to find the distribution of the forces properly. So we have tested it by using ground truths, which are contact sensors, force sensors that we embed a person with motion tracking and also force tracking together, okay, and we were able to guess what are the contact forces, okay, in many different postures. So the third brick, which is important, is multi-contact planning. It means, okay, if I want to assist a person to do some motion, where do I place my hands, and to help the person to, for instance, for sit to stand or stand to sit, and then rotate on the bed and stuff like this. But this, I don't think we need to do a lot of research on it, because there has been many books, and the caregivers are really instructed very well to, for each situation, what is the best posture you have to adopt, okay, to help for a specific motion. So if the robot can learn simply from the caregiver handbooks, okay, then it would be able to know exactly what to do in which situation, and you have very instructed procedures on where to place your contact, for instance, to help a person to stand. If you see the picture here, for instance, okay, the nurse, so in the book, you say if you want to help a person to stand, you have to put one hand here on the torso, the other arm, you don't see it on the back, okay, but more importantly, to put your feet, okay, in front of a person. I don't have the things here, but it's okay. You put it in front of the person so that he doesn't slip, okay, and then you can put this. If you don't have this, you can still teach the robot, as you can see here in the video, to say, okay, I will teach my robot how to do this, and then he will be programmed to do it. And then he said, okay, if a person is sitting, the way you have to help him to stand is to put your hand here to get this posture, and then to help him to stand. Obviously, vision alone is not necessary, is not enough in this case. You need to have some additional sensors like tactile sensing, okay, on the whole body of the human robot, exactly as the nurse has it, or even before contact sensing, and they have developed with Fogal technology that is able to sense contact before it happens. Okay, it is using capacitive sensing, and you can use this technology, of course, for the robot to be aware. And if you have capacitive sensing and vision, you can have a very reliable construction of the state of the person. Okay, I mean the model of the person. Where is the model? Where is the person? So that for the robot to be aware, okay, of the state of the person, and then it can position itself in the proper posture to help in the assistance. So we are developing also many other technologies by considering the very specific problem of humanoids. And for this is the comparison between, on the left, what is the distribution of the tactile sensing in the human, and that we found in the robot. They are basically only on the fingertips. Okay, and we want to cover this gap, okay, by building very cheap, okay, sensing that we can deploy on the whole body of the robot. So another important aspect is also the cover. There is no reason why the cover of such robots are rigid. Okay, this is a heritage of the industrial manufacturing robots. Okay, someone has decided that the cover is rigid, but there is no reason for that. And it's good to have softness in the cover because it helps also, it can convey safety, it can convey features for the person to be trustable. And we have started to try to develop soft skins, okay, not only for sensing, but also for displaying heat, for displaying many things, okay, that we think it's important to make this robot safe and to make them also trustworthy. Now, one of the big problem also in the brick is, okay, now I have in a person, I am there, I put my arm, so question is, what is the force that I need to apply, okay, to assist the person to stand? And this is a very important question, and it is a very open problem. And I can explain it with a very simple example, okay? I want to move this particle of mass m from position xi to position xs. The governing equation is very known, very simple. Sum of force equal m dot acceleration, okay, for the robot to stand. So what are the forces? There are two forces. There is the inner force. It means the force that the person can deploy by his or her own muscle. And you have, of course, the force that the robot has to add to do the motion. Okay? So if the person is weak, he cannot develop, the F inner is not enough to do the motion. If the person is, as I said, weak, the F inner is not enough to do this motion, to do this trajectory, then the robot has to add assistance. The problem is that the robot does have no access to F inner. He doesn't know what is the force that the person can deploy. So if he put a lot of force, then it's perturbing the motion, okay? So then the person will feel it like not good. If he doesn't put enough, then he will not do the motion. Then the robot has to define exactly what is the force assistive that it has to deploy so that the motion is done. Okay, for the human, it's kind of intuitive, okay? The nurse knows because she feels it, she knows what's happening, and then she feels, so people will do adaptive control, some people will do learning, but this is a very deep problem, okay? I don't know how many force you can apply, and I need to assist you. If I put too much, then the person will feel it like a perturbation. It can even stabilize the person. If it's not enough, then you are not assisting. The way we address this problem is very simple. In fact, I didn't put the equations here because it will take a lot of time, but we find that there is a link between the dynamic balance, okay, in terms when it is described in terms of geometry, and contact forces keep the robot always dynamically balanced. So in fact, what we did is simply to map all the knowledge, okay, in terms of closed form models from dynamic balance of humanoids, and we map it on the human. So we just simply say that if a person has to be dynamically balanced, then this is the tool, how he has to do the things. And we have a representation, a geometrical representation for that, okay, and by doing so, we have a point which is the center of mass, or to be more precise, it's not the center of mass, okay, it's in fact another term, but it is called the DCM, okay, and this DCM, once he is inside the geometry zone, okay, defined by the contacts, then the person is dynamically balanced, but if it is outside, then the person would fall, okay? And then we monitor this point theoretically, and we apply a force to always keep it inside. And in fact, we find the relationship between the force that you apply and the dynamic balance of a person, and then we are using exactly this relationship to generate, okay, the assistive force. So this concept, okay, is also, how to say, was here's just showcasing, okay, that we can make such robots always dynamically balanced, okay, by using our concept. And you see here, as a person applying external forces, the robot is always trying to keep balance with the contacts that they have, okay, just to showcase, in fact, how the dynamic balance is important, because it's exactly the same behavior that we would have for a person, okay, if he wants to keep balance and you are touching this balance, okay, so he's, by comparing, we found that in fact it's the same structure of equations that are used here and there. And then we basically map the human model, okay, to get these dynamic balance criteria. And then we, like for the external forces, is when the person would apply the forces, we would just monitor this point. And if this point is inside the balance zone, then we don't need to do anything. There is no assistive forces. But if the balance is not correct, okay, so the robot will use the exact amount of force to keep this person always dynamically balanced. So if you are interested in this problem, I can of course detail it later, but now I don't have time for it. All this demo that you have seen with our humanoid robots are made by a software that we sustain, okay, and it is open source that you can use, okay, for, and it's not proper to a particular humanoid robot. We are controlling all our knowledge is basically on this website, okay, and you can use it in simulation. You can use it to also do pattern walking generation. So Amit was talking this morning about that, their try, so you can have a software that is readily available with all the knowledge that we have developed there. So the idea of having, okay, the control that we did, we are doing it also in closed loop. Okay, this is really important. So the force that we are applying, the assistive force, is in closed loop, not in open loop. Okay, and for that we had to integrate the human model, okay, inside the controller, okay, of the robot, which is a task-based controller. And then we have built a model for the human. We know from the human an estimate, okay, because there has been a lot of research that tell us what is the estimate of the mass distribution and the dynamic parameters of the human, okay, when the human is there. So we know how to distribute. So we have a dynamic model of a person. We have then the context, and then we have the dynamic balance region, and we can integrate the dynamic model of the human as part of the controller, and we can do everything in closed loop. So this being said, I will show you, so we did, of course, the first trials, not with a human, because it's, of course, dangerous, okay, to do it directly on the human. So at first we did some emulation. Okay, I'm not sure what's not working. Okay, an emulation of like a human torso, okay, and it was controlled by a panda. And then the panda was trying to do the motion of a person that is standing, and then the humanoid robot was doing the task. This is the first on the left. And then progressively we went to the human. We didn't do it with Honda as a robot. Okay, this work is the work with Honda, because the company didn't allow Honda to do it with their own robot. They thought they are not safe. But since we are a research lab, so we took the risk to do it without ethical approval. Because it would have been impossible to obtain. And we started by some prototype, okay, doing this. And this is also, it's the first time in the world that you see a humanoid robot helping a person, okay, physically and in a closed loop. Okay, this is also was a world first. Okay, and of course it is, what you see on the right is the model that is included in the robot. In the controller, of a person. We are just visualizing the model of a person. And then all these criteria, the DCM, etc., are what we are using to quantify the dynamic stability and the dynamic balance of both the humanoid robot and the person. And then you will see, we'll just skip quickly here. Okay, once the robot positions itself. So when this green zone will become red, it means that the person is outside the balance. And you will see the assistive forces at the beginning, they are not acting. And then the person here, if the robot is not helping, the person would fall. Okay, and then here the person is in a safe dynamic balance region. Okay, and the reason you saw the demo that we use with this robot helping to control is that we want to do it in 3D inside the bed and in other aspects. So here what you see is that when a person is going up, okay, outside this dynamic balance, the robot is applying the right force to bring it back, okay, to a safe zone. Then we worked a lot also on telerobotics, okay, because it was important to design some technology to transfer the knowledge, okay, and teleoperating humanoid robot is a hard problem also, okay, to be done. And in fact, we did it to attend the ANA X Prize. And later on, okay, we use this technology for something else. So the something else can be also like deploying a humanoid for autistic children, okay, in need. And here the issue is that you know, we have a lot of work where humanoid robots are deployed to interact, okay, with autistic children. But here what you see in the thing is that humanoid is still operated, okay, by the caregiver. So everything is not programmed, because most of these humanoids that are used for autistic children, they are pre-programmed. There is a code, and then the robot interact, and it doesn't have a lot of things. But here, it's not interacting by a program, it is interacted by teleoperation. It means there is a person who is controlling in another room this robot, okay, and then she is speaking, and the robot is just replicating her voice and her speech. Whatever the kid says, she's hearing it because she is in a fully immersed environment. But the most important part of it, you don't see it, is the AI. There is an AI that is recording basically everything. And the AI say, okay, at the end of the session, how much time this robot, the child has looked and gazed on the robot, how much time he did this, how good it was in grasping the ball, how good it was in this. And the AI is recording this, and then the nurse can, in the next session, says, okay, oh, I remember this guy. This guy, in fact, he liked these games, and he did this. And the AI can even monitor the program, which is extremely hard to do for the nurse. So the nurses are extremely happy, the caregivers, because they find a tool, not to replace them, but to assist them and to increase their quality of. She told me, now I can concentrate really on the care, because I don't need to mark how much time the person has gazed, how much time he was successful. Sometimes I forget for each kid what did he like, what he didn't like. So now we are merging AI and physical embodiment, okay, in the service of this. But the idea on the long term is that if the robot will become clearly autonomous in the way he plays with the kid, so the parents can take this robot at home, okay, and they can do the program of educating their kids for that. So we do have some side research that is connected to humanoid. I will not speak about them a lot. So we are developing some orthosis to distract the knee, because to allow the meniscus implant, okay, to solder. So there is all this knowledge is of course done because we have it is connected somehow to humanoid robots. So if you are interested on this, I can speak more about it. Okay, we have here, for instance, we want to make sure, okay, that the prosthesis is distracting the knee, so that when we implant artificial tissue, it will not have a large stress on the knee. This was a demand on the hospital of Montpellier, okay, to tell us, okay, can you do an orthosis that distract the knee, okay, so that the stress on the knee is not important when we implant an artificial cartilage. And obviously the knowledge of humanoid robots has helped a lot on designing these systems. Now, I want to speak politics a little bit. Okay, but you will understand it very quickly. So how are we going to do, what do I, because I am sometimes advising Chinese institutions, European and French institutions, and also Japanese one, by reminding the world of this curve, okay, that I will not comment. I think now it's becoming a general problem, okay, of aging and the decrease of the population worldwide. This is to show to the French and EU for people who claim about we don't need immigrants, okay, and in fact, there is here some scenarios, okay, that industries understands very well, okay, about if we keep zero net immigration, this is the population, how it will decrease, like in the Europe, okay, how it will, grow. And if you have half statu quo immigration, if you have statu quo net migration, and in fact, if you want really to keep the things growing, you need to have twice immigrants, and if you want to have it growing fast, then you need 4 times, okay, immigrants. The problem is that now all the countries are looking for task force, okay, that you cannot take them from like the North African countries anymore because they are developing and then they would need their own resources also. So this is important. The second one is how, if I don't have a lot of money, where do I need to put it? So this advice I give to France, if you don't have a lot of money and you want to develop this technology and not depend on US, on China, then what you need to do is to put it in manufacturing. Okay, because manufacturing will mature this technology, mature the components of this technology to make it robust. Then it will cost much less to deploy it after in service that are paid by taxes of people. If you want to build like a service robot, this is also what I showed to Honda, then if you have to invest on this, it will cost you a lot of money, okay, and even for the defense part. Because this gives you basically what is the percentage of the PIB, I don't know how to say in French, in English, for that you need, okay, from the taxes of the people to develop these technologies, basically. And with this, I will end, and thank you very much for your attention. This is just my sponsors, so the grant that I gathered, the percentage of the grant, okay, and also the people who are funding my research, and this is the true heroes who are behind, of course, this work. Most of them are my postdocs and students. So those who are circled in red, they are in academia, the other they are in industry. Thank you very much.
Thank you, sir. Thank you for such a wonderful talk, and we'll learn so much from you about the humanoid robots. So we'll have some questions now. Anyone who has question?
Thank you, sir. Okay, so you have told that there is one part is like obviously human is there in the loop. So the autistic child is very much getting engaged and feeling. So now the thing is also you have mentioned that if the robot becomes completely autonomous, human may or people may try to keep the robot at home. So the question comes is, are you thinking of robot as an intervention part, therapeutic intervention part, or is it just for engagement? So why I'm asking this question is that if it is about therapeutic intervention parts, so there are many things we need to take into considerations because the behavior of the child is very different from the normal child. So how you are taking care of these things?
Okay, so that's a very good question, okay, because it was at the heart of the discussion I was with Honda. So I told them, okay, you want to do, let's forget about autistic children, just like elderly assistive robot. So I said, okay, if you build this product, and if this product is ready to be deployed, your robot can be bought on Amazon or whatsoever, or like in a shop, like your car, you take it home. It is deployed and it's working perfectly well. You cannot do it, okay, because you have to prepare the legislation, the insurance, many other things that is beyond your reach. So it's like driving autonomous car. Okay, we have no driving autonomous car in France. The legislation is not ready, the infrastructure is not ready. This is problems, okay, if you go into the assist. That's why I'm asking the governments, don't put the money for assistive. It takes a lot of time, it takes a lot of money to have to make this robot safe. They need first to prove they are robust in industry. And industry can put the necessary money, but more importantly, even in the hospital, to take this robot, it wasn't difficult because you have an ethical approval, you have rules, but at domestic, personal usage, these rules has to be prepared by the legislation, by the politics, by the insurance, by what happens is this robot do something bad, what happens is this robot can be hacked. So all this preparatory condition for deployment takes a lot of time. Okay, for the autistic children, for instance, taking this robot home is not necessarily like a vision of tomorrow, okay, but if the AI can learn from the caregivers, there is some small exercises. For instance, when we used Pepper, one of the caregivers, she's psychomotrician, okay, she teach the kids to do like this balance. So she said Pepper is useless. it cannot grasp the ball, it cannot play with the toys, it can do nothing. They say this robot is useless for us. Okay, we see the interest, but these robots are not ready. And in fact, I had one sentence said innocently by a person. She was asking, even in the manufacturing, can your robot do that? Can your robot do that? Can your robot do this and that? I said, no, this one we cannot do, but this one is good. So she told me one sentence, why do you call it humanoid? He cannot do all the things we do it the way we do it. Yes. Okay, so it's just a robot, she said. This sentence is very deep because I put it in my papers now. She said, it's just a robot, it's not a humanoid robot. In fact, when people, even in manufacturing, you tell them I am preparing a humanoid robot to do the things, they expect the things to be done exactly the way they are done by the humans. So the expectation is higher when you are talking about humanoids than when you are talking about regular robot. Sometimes even in with Michelin, rolling the bobbin, entering, and there is the whole thing I didn't show you because we were not successful in doing it. Taking this snap and putting it through the things. He said, why your robot is doing this? Oh no, it's useless for me. Because your kinematics is not well designed like the human. So in fact, the expectations in manufacturing and in domotics for such kind of robot is extremely high. And the robots are not ready, okay, until now. There is no robot, even what you see in YouTube, Unitary, dancing, this robot cannot go to industry. They have not, none of the robot can actually now, Tesla, Unitary can be deployed in industry. There is a huge gap between what the robot can do in YouTube and what you can do in manufacturing.
Can I ask you a connected question in this?
Of course.
You said, anyway, you all are saying humanoid robot, and you said that the person said this is just a robot. So if you think in future, instead of building just a robot, to build a humanoid robot with emotions, with empathy, what are the milestones you are thinking and how to proceed? Like given that AI or ChatGPTs and all, which can show some kind of empathy, do you think it can be a humanoid robot? In a sense, human can think it's not just a robot.
The fact of having a humanoid robot with respect to the AI, it's very simply, it can have one single justification. You have data. Because we have gathered thousands of data. So to train this robot, we have our own data. If the robot is shaped differently, you need to generate the data, okay? You need to put the robot which is different, you put it in an environment and simulate. But if it's a humanoid robot, then you have the data as readily available because we generate them for ourselves. Okay, so this is the key point of people believing that humanoid robot could be deployed easily. But in fact, I have a project now with Michelin. This project is very simple because the needs of industries are not what we see sometimes here. It's said, okay, I want you simply to program my robot, but I don't need to hire an engineer for that. Okay? But I don't want a black box to implement on my robot. Okay, I don't want a black box. So our research now is focused on using AI not to generate neural networks to be implemented, but using AI to take all the knowledge of robotics, which is certifiable, which has a model, and combine it together to, at the end, generate understandable code. Okay, and because the time is not allowed, I have a video where in Michelin, where you see people doing some task. There is the camera recording, and then behind, there is AI, etc. But at the end, what is generated is the code that this robot understands. There is zero intervention of the human. The robot is just watching, and then he will do the task. Okay, it is automatically programmed using AI. But AI doesn't generate a neural network, a non-understandable black box. It generates code that any person can certify. And I think it's the same problem for humanoids.
Yes. Thank you, sir.
Thank you so much, sir.
Thank you.
This is Anand Kumar.
There is another question? Oh, okay, sorry.
Thank you, sir. This is Anand Kumar.
So, we are getting late. Anand, we can have questions later.
Just a second.
So, in the interest of time, we have to go forward. We are getting
Small,
late.
small one, sir.
Small one.
Yes.
Okay.
This is Anand Kumar from IIT Roorkee, India AI Fellow, working under Professor Tarun Kumar Reddy. Recently, Google has launched their media pipeline libraries for the gesture-based recognition systems. When you are seeing in this kind of robotic interaction systems, that's using the gesture-based to design and interact with the different libraries. In your work, you have mentioned the gestures. So which library and which thing you have used there? Can you explain?
Yeah, we have used many of the on-the-shelf boxes, on-the-shelf software, deep motion, foundation pose, and many things to track the person. It's that your question, right? Tracking person.
Yes,
yeah, none of them is working when it is deployed on the robot, and none of them is robust enough. Sometimes we lose the tracking of the person because this has been trained. This AI for tracking of a person has been trained by a camera where they are fixed, the person is moving, and then it tracks the person dancing. Sometimes you have even ground truth. The ground truth is that the image that is generated on 3D superposed on the camera, okay? And they said this is used for a robot, okay? First of all, sometimes the person moves, but sometimes the person for assisting it is sitting, okay, or inside the bed, covered. So this tracking system doesn't work, okay? And then when you go closer to the person, you lose, okay, the whole picture of the person, unless you use a fisheye camera. But there is no software available now for fish eyes. People are trying to do it, okay, to get like the whole picture of a person. So the tracking of a person is important for the robot to operate in closed loop, and they need to be robust. Okay, you cannot say, I'm doing a controller, and sometimes the frame is here, the person is here, and in the next iteration it's here, but the controller has generated a command for this error. Okay, and then you need to add. I'm not saying that you shouldn't add it, but you should prepare your controllers that the perception you are having is not robust. Okay, so this is the most important point.
Okay, sir. Thank you so much.
Okay. So thank you, sir.
You're welcome.
For giving such a nice talk. So we can have a big round of applause for him. So next in the line, we have talk by Professor Santanu Chaudhary. So I'll be reading his brief bio. So Professor Santanu Chaudhary is the first dean of the Vachani School of Advanced Computing at Ashoka University. He has earlier been director IIT Jodhpur and director CSIR Central Electronics Engineering Research Institute. He was also Dean Undergraduate Studies at IIT Delhi and has held a number of chair professor positions at IIT Delhi. He was awarded the INSA Medal for Young Scientists in 1993. He is a fellow of the Indian National Academy of Engineers, the National Academy of Sciences, and the International Association of Pattern Recognition. He is also a recipient of the Distinguished Alumni Award of IIT Kharagpur. His areas of interest are computer vision, artificial intelligence, AI applications, digital heritage, AR, VR, and multisensory media. He has led several national initiatives across the field of robotics, medical imaging, cyber physical systems, document image understanding, and so on. So we welcome Professor Santanu Chaudhary for his talk.
Don't have any other comfortable. Okay. Am I audible? Okay. So I've chosen the topic in the context of the theme of this conference, Industry 5.0 and physical AI. In fact, whatever has been talked about in just the previous talk is actually implementation of the physical AI in the real life. And that's where the things are moving when we talk in terms of AI moving from a conversational virtual world to a real world and making impact in the real world. And this really is a convergence of human-centric problem solving and production process with that of an embodied intelligence. So human, so therefore I'm just trying to generalize the whole context of human in the loop or human on the loop. I'm looking at human as a partner in the loop. And in fact, this is how possibly the future intelligent systems needs to be defined for an engineering world. And my talk is more of an research agenda than really the research results. So therefore, if you look at physical AI, I've tried to use a more general definition of physical AI here. So what I've emphasized is that physical interaction, perception, learning, and autonomy as interconnected principles that enable systems to act meaningfully with the real world. So it generalizes the core definition of AI into the situation where the physical world is interfaced with the AI in every way. And embodied intelligence is important because physical embodiment can only give rise to what we call the closed loop perception action cycles. In fact, this is exactly where the multimodal AI is really moving to. And this is why we need to have multimodal AI. So if you look at perception action cycle, essentially means that I am acquiring information about the external world about using a variety of sensors. And these sensors are actually synchronized data. It's not asynchronous data. I think this is something which actually gets missed out in most of the AI formulations. But this synchronous data is what is to be interpreted and to be put into for real world tasks. And that essentially what is your perceptual AI. And I think if we look at the entire story of what we are talking about is represented in a sense in this diagram. In fact, if you look at physical AI, what are the fundamentals? Primarily, we are dealing with information, energy control, and context feedback flows. Because without energy, energy is a fundamental component. In fact, if you look into it today, we talk in terms of learning. We have to also talk in terms of learning systems, which minimizes the energy. That whatever it is earning, it's not just meeting my target accuracy requirement, but we should also have secondary performance parameters like energy and reliability. And today's major problem with these current robo systems as well as AI systems is that these fundamental parameters are not optimized when you're looking at the learning problem. So the open space for new generation researchers are to look at the learning system possibly in terms of these lenses. And if you see the physical embodiment where the energy interface is a must, then sensory perception, the motor competence, learning capability, because the point is that what you learn and how you learn. Because you have to learn also on your own. Learning also means reasoning. We reason to learn. But today the entire AI is actually, if you look at it, is associative decision making, associative learning. Associative learning, in a sense, is a shallow learning. Therefore, the whole point is that when we are talking about physical AI and we are trying to define our agenda, I think we need to reposition that AI altogether with reference to the external physical world. So this leads to the picture where you say that actually a human being, it's a hypothetical picture created. If you see a human being with an eye, I think such meta glasses are today available in the market. is collaborating with a robo and doing work together. The point is, therefore, how do you design and learn to design this kind of collaborative human AI system? Because we had thought about at one point of time, in fact, what Debashish was also looking at, the future, that future is that human agency gets removed away, and we are talking about automation by reducing human agency. But possibly this is a time when we need to think and need to consider that AI is to empower human agency and not replace human agency. And that protocol or the theory of such systems today is not there, although we talked about cybernetics. In fact, if you look at today, that if you look at these, that human centricity of the whole technology brings in the sustainability and resilience, because you are not throwing away human being. So human being as an element is part of the whole technology loop, and that makes it resilient, and also it refines the human labor. I think the fundamental point of the production system, how we exploit human labor, but today we are in a position, we are talking about refining human labor and make use of the human labor in a more intelligent way, and using AI to use human labor in an intelligent way and equitable way, and not in a exploitative way. This is something very, very important, because then only we can talk in terms of augmenting human capabilities, because then human is producing more surplus values, and hence the economy is changing because of the human-robo collaboration and not replacing human inefficiency. So now if you see that in this context, if you look at the cyber-physical system, so now the cyber-physical systems actually has to be human-centric cyber-physical system. So when you talk in terms of physical AI or Industrial 5.0, effectively, we are talking about the central block. All of these will be essentially consequence and control. This is something like CPU of the overall cyber-physical system. And this is here we have this loop, and if you look into it, what are the different roles? Obviously, human is the operator, and we have a AI, this is the model, human-AI collaboration, and possibly verification of hypotheses where AR comes in a big way. And we have not been able to exploit AR sufficiently to have this kind of simulated verification before we actually apply in the physical world. So now Kobo is a collaborative robo, and which is a consequence of human-AI collaboration and not just being controlled by human being as such. So the whole hypothesis is that we should really look at Kobo in a more general way. So therefore, I have this human centricity, I have sustainability and resilience, which I pointed out earlier. All of these get satisfied if we really look in terms of this model of cyber-physical system. So the robo is actually getting replaced by Kobo. In fact, that's possibly the next generation of looking at the whole automation system. And hence, if you see, all of these can be done through these, because assembly, dexterous manipulation, inspection, preventive maintenance, collaboration and material handling, logistics. Why I have picked up these three is, these three are the major areas, okay, other than the drone, the aerial part of it, major industrial areas which are generating revenue. And that revenue is actually, if I have to provide more, then that has to be more efficient. And if you look at these, now, therefore, the design principles, that what we are talking about today in terms of algorithms, in terms of the philosophy with which you design, somewhere we miss out the human-centric design. Although we talk about today, the design has become very, very important and critical, but design departments or design philosophies at one end, and engineers work at one end, and we talk to each other, but we do not really always integrate together. But if we really want to have a human as in the loop, then my design of the systems also has to be human-centric design. So the whole philosophy-wise, therefore, if you see, that ergonomics and safety today is safety with reference to robo, so should have fail-safe interactions and collaborative motion planning. Collaborative motion planning can ensure a productive, safe production system. And similarly, therefore, there are multiple other ways things would change. So these actually changes, in fact, if you look into it, this possibly would change also the skilling programs in any country, and these ethical and social considerations, which is not really the focus of many of our educational issues right now, is a point to be considered and looked at. And with that comes that safety, security, and compliance, because compliance is a valid protocol and it's all the levels it comes in. So I'm just indicating as a core concerns, and I shall look at therefore now, let's look at the core learning problem. Now, we human beings, if you look at, today we are looking at LLMs, we are looking at visual language model, we are looking at action models, but predominantly, if we see that there are all kinds of data which are to be used. Today we say that I am doing a collection of data. It's good that we expect to make our own collections. We also talk in terms of one of the digital public initiatives as building Indian data or Indian data collections. But you cannot, I think this is something which is very, very important to look at, that we cannot go on exhaustively collecting data. We need data. I'm not telling that we don't need data. We are actually in the age of data-driven technology development. Data-driven technology development requires that you need to have a very large volume of data, and which very clearly shows that why today we have the major problem with AI is the drift, because the distributions which naturally drift is as the conditions change. The conditions which is true in Mandi may not be true in Delhi. So therefore, an AI problem learned about in the ecosystem of Mandi may not work in Delhi, because this is a very major problem if you look at, talk to defense complains about. So therefore the question is, data, we need to also possibly also look at the data generation process. Obviously generative AI providing the generative handle to deal with data generated and use the generated data in the ML scenario. But what is the challenge over there? We do not talk about using generative AI to train systems simply because generative AI does not guarantee the correct data. Since it doesn't guarantee the correct data, the major problem over here is that your physics of the data is actually lacking. Now, if you now generate synthetic data where you build in the physics itself, and what you do in that case, you use the physical model to generate the data, and you add noise to it, and the noise actually can take care of unmodeled uncertainties, but physics actually can give rise to variety of scenarios through controlled generation. You may not be able to go and correct data in a factory or any other scenario, that you are getting a coverage of all possible working parameter conditions, because different variations of parameters can give rise to different data. My synthetic model may be incomplete, and that's why I need to get the real data. That's why I need to use ML to generate the complete model. But synthetic data has a role to play because it can model parameters which are actually missing in your data collection. If you actually structure the data collection in terms of what are the variabilities you have accounted for when the data you have collected, you can then also identify those variables which have not been accounted for, and now can you bring in physics with your data to account for those missing components, and therefore I have got the logical basis for the remaining data, and can we merge it together, and we can possibly get a better representation of the distributions of many of the scenarios where limited sampling does not really present the full picture. So therefore, there can be a variety of things. If you see, we are using all kinds of data, and it can be individual data, individual and social media data, all the things together. So the learning essentially is multimodal. And multimodal is not just video and audio. Multimodal is also via a variety of sensors. And so if I'm using a video, and with that there are vibrations there, and what is the nature of vibration? If a vibration sensor picks up, and that gets integrated with the video while learning the properties of the video to model the physical situation for making decisions, then video with the vibration sensor actually together synchronized data representation and learning is a must. Now from there, which if you look into it, then we need to move what we are talking about today, action models. Action models actually will generate the scripts, what my previous speaker was talking about, and which is really the thing is that it's not the interpretation. What you require is actually to have a robot interfaced is actually generation of the instruction for the robot, which is actually the programming language. And this is not, and if you see that robot to be programmed and the real-time stringing of the instruction is actually the action. And the action that is getting encoded through a video or any other dynamics is to be interpreted. That's exactly the ML. Because we know that this is the recognition of an action. Action has these steps involved, which may come from earlier knowledge. So I generate what? I generate essentially a sequence of instructions, which can be even by using a chatbot you can generate. But then the planning process comes in, which will really combine these sequence of codes to generate a procedure for a robot to act. So for example, if a drone has to really follow a cylinder in an adaptive way, then possibly we need to generate that instruction sequence which has to take action under different conditions. It needs to plan. The planning code can get generated once we do these kind of large action models. But the biggest problem with large action models is that, this is an example which I picked up because actually, if you see in many cases, these business are actually come from these customer behaviors. If you look at your agentic AI, the most common example is a customer behavior. But the interesting part is what is included here is that this whole story actually looks into it, the different possibilities and different interactions. These interactions really we do not take into account when we classically formulate a learning problem. But action is a conditional learning. So the conditional learning is also conditional learning under conditional situations. And that's exactly this kind of large action models really targeting. But what is the difficulty with the large action model targeting? See, all of these fundamentally are associative learning. Fundamentally associative learning. The problem of the associative learning is you do not know whether a nonsensical combination can come up. Because these actually is learning is what? It's in a distribution space. Finally, it's a random associative combination, which is in terms of autoregressive probability is a most probable combination. But most probable combination is not also the logical and correct combination. And that's exactly the most difficult part of actually action learning, and what I'm talking about from story actually to build an action and use it for the kind of a cyber-physical system that I showed earlier. So this is the process pipeline I have already shown. I did not elaborate further on it. So now, therefore, look into it, so how the whole thing, therefore, gets into it. I have these multimodal applications. I have image observations. I can have language. This is the language instruction. The robot can be in different states. And this is the state I was talking about, that the state part, in many cases, we do not take into account when we formulate a learning problem. And this is now increasingly happening, and people are trying to take in. if you see Pi 0.5 model, where vision language action models, this is exactly the way the Pi 0.5 learning happens. So it is, if you see what is happening here, this is what is your standard LLM kind of a learning. And this is the diffusion transformer, which is synthesizing one of these actions on the basis of the states it would go to for a particular action to be done. So that is being done by the diffusion transformer. Now, in this diffusion transformer, in this whole pathway, what is missing is it mechanistically always valid? Can you guarantee that diffusion transformer, the combination that is generating, is mechanically valid for the robo or not? The way the robo and the degrees of freedom which are there and the control it can do need not be always valid, because unless what the diffusion transformer is generating, you are constraining by your mechanistic construction of the robo. And the construction rules that mechanical model or the dynamical model that robo is supposed to follow. So therefore, instruction generation for the robo and the machine can be actually, the question I asked also, can be, and there are enough examples we have seen also in some of these small experiments, that which are not correct. They may be majorly correct, but in between there are combinations which really does not give you the correct sequence. And that is the most dangerous part of this language, multimodal reasoning, multimodal action. Although the multimodal action can be the new generation of cyber-physical and human system, but that system has to be guaranteed to work, has to be there a safeguard so that it works correctly. That safeguard is what is currently missing. If you see to it, this is actually from NVIDIA GRUD architecture that they do and give these similar models, but there are also, see, some of the components are pre-trained and frozen. Why frozen? See, there are pre-trained and frozen components. Why frozen? Because you want instance to be done, fixed, so that there are no major error occurs, major calamity occurs. So those are actually verified and fixed, and so when your diffusion transformer or any of the generative model are generating a new action sequence, some of these are invariant component of this action sequence. So therefore, there won't be any kind of a catastrophic action on their part. Now, how to bring that in? This is really the challenge. See, whatever I have talked about so far, I think in various talks, that aspect has been dealt with. I have just trying to putting it in a contextual flow so that that can also define an agenda of what is to be built for future. But now if you look into this, this is where we need to bring in causality in large action models. So we are actually, if you look at fundamentally, we reason with a cause, okay, in a cause-effect way. In fact, that's a basic fundamental way to do it. And I think many of us are exposed to logic. If you look at a very basic propositional calculus, A implies B. Given A, you can conclude B. But given B, you cannot conclude A. But when we do associative probability calculations, that is autoregressive probabilities, these are essentially A associated with B. A associated with B can have a high probability, but given B, A may not be always true. And if you analyze this is essentially the reason why our LLMs do kind of a hallucination. Our decisions also at times which are wrong. I'm talking about in a very simple way. This is not the complete picture. The picture is much more complex, but if you look at it in a very simple way, we do not even satisfy the basic propositional calculus in terms of LLM-based reasoning, which we did long back when you did a prologue-based programming. And back chaining and forward chaining, all of these followed this logical basis. Today, autoregressive is actually giving results because it's actually exploiting your combinatorics in a very interesting way. It can generate lots of things, and in fact, diffusion model gives me, and others give me, a way to pick up a new example from a distribution. Discriminative learning have enabled me to learn the distribution, but now I can pick up an example from the distribution. But that example, whether it's causally valid or not, the distribution doesn't guarantee. And that's exactly the core problem of, and that problem gets amplified when you talk in terms of an action being synthesized. Because action will work in the physical world, and there can be therefore a real loss in that point. So if you see, therefore, what is important is possibly to bring in a causal graph in the whole reasoning model. And what is the causal graph we are talking about? If you see, I've just given a graph like a belief network. If you're familiar with belief network, you can recognize the structure. We need to deal with world knowledge. We need to deal with cause. This is a cause. This comes from the world knowledge. This is the effect. And T is a natural language. What is a natural language? It's actually the program sequence that should come. So the model is that once I have the world, I cannot do anything, therefore, this T is no longer valid until unless we have C. And actually, you have seen that some of the cases when you talk in terms of using knowledge graph, actually you're going back to the world of expert systems. When we talked in terms of knowledge representations, now we're talking in terms of a knowledge graph, ontology. We are bringing ontology with retrieval augmented generation, trying to put in causality implicitly via knowledge. And which is very, very important is therefore to have this graph in place when you look into a model-based design. So if you see that embodying, this is a standard part. The causal question, if you see, is a very simple causal reasoner which you can put in place. And it's actually happening. And we need to look into it. There are lots of interesting things can happen in this place, that what is the result of surge of interest in artificial in terms of media coverage? So this is a simple question, and if you look into it, the question gets interpreted from large language model. Then I go to the knowledge. This is the knowledge base, which is actually a domain knowledge. And that gets represented through an embedding model, and I have a vector database through which I can retrieve the answer. In fact, if you see this way, if I want to design, say, possibly any even electronic circuit, today, electronic circuits, I can also design using this kind of a methodology, but whether it would work or not has to be verified with respect to the basic laws of electronic design, which can really be encoded through a knowledge. So therefore, the knowledge today starts playing a major role. So AI engineers, so another point is very important to look at. AI will not be the everything. AI has to be with actually the core engineering principles integrated together. And so only the engineering part cannot work alone, or AI cannot work alone. The causality that we are talking about in terms of viable actions being generated has to be domain specific, and with domain specific knowledge being integrated in. And today what we are talking about is these designs are giving actions for what? Actions to realize the intent. So again, it's a kind of a thought experiment model that if I have multimodal demand inputs, I've just illustrated with respect to real life example, but most of the engineering systems have got now multimodal demands. So if you look at a drone example, drone has to follow the volume, but it also has to be optimized in terms of the time taken. It also has to avoid collisions, and there can be multiple demands which is on the system that we are designing. So that design is actually therefore to target the human intent, not to satisfy the specific objective. So what I'm trying to say that I'm generalizing the problem in terms of we expect that I'm designing by AI, I'm designing a solution which exactly follows a path. Okay? But what I'm telling is it will get possibly ability to generate a set of alternatives which satisfies the intent. So the whole generation process is with an embedding space, a kind of a context multi-word generative AI model, which can satisfy the intent. I have example illustrated the whole thing in a consumer world. That is a very easy, tangible way to look at it. But intent is what we are really trying to target. Not an objective to be satisfied. So it goes beyond objective to intent, and that's exactly what I'm looking at. And all of these have to be ethical. Now, if you look at ethical, in fact, I'm going back with what Lakshmi had talked about in terms of consciousness. I'm talking about sentience because AI has to have sentient values. Why? Because the subjective experience has an implication. If I say today the pain-wise, how you look at the subjective experience. Can I have a model of subjective experience? The questions are, challenges are, if you look at, even if you solve that problem, the open issues and which are interesting to look at is, can we design interface of an electronic system which is sentient and can establish emotional connect with end users? There are applications. In fact, if you look at the issue of your an autistic child, a robot need to have the ability to sense that emotion. And how do you model that emotion? We don't know. These are the gaps. We don't know because without that sensitivity, even healthcare for an elderly, healthcare or an autistic, a robot for an autistic child, or a human interface to an autistic child is not possible. And this compassion, this is the emerging future of AI-mediated interfaces will feel almost self-aware in their response to user needs. AI doesn't have self-awareness. It doesn't have what is called an agency per se, although we are talking about agent-based system, but if you look at from a philosophical perspective, it's extremely important to agency to have the awareness. I think we shall not go further into it because this is something very important and interesting to look at, because qualia, the content of consciousness, human consciousness, and is a container of which qualia is experienced. So subjective first-person experience of perception, like what it is like to see red or feel pain, is discussed in several nuanced ways in philosophy, and the illumination of mental content by awareness, and therefore, what is red, or what is bad, good, there has to be some sense into it if we want to talk about ethical, responsible AI. And we are talking about ethical, responsible, and trustworthy AI, where these issues and how you actually create an artificial sentient system is a challenge. Not only looking into it, because this is how possibly we can design what we say will predict internal state of the model and not just the output. So now you think in terms of it's not a single objective optimization. It's a multi-objective optimization which is becoming your learning. Learning has multiple parameters. We have classically thought about learning as a single objective optimization problem. But there are these parameters, and when we talk about ethical AI, I think it has to be a multi-objective learning. And that's exactly the agenda, that's what we are talking about. So therefore, human in the center AI requires deeper investigations in the approach. I've tried to highlight some of the issues in this direction, because it's not human in the loop or human on the loop, but human-centric. I think that's a key point to be looked at, because AI-human partnership is what the world would require for future. And it's inevitable. We cannot ignore and avoid that. And human-like reasoning to take ethical action can lead to human-AI collaborative production systems. So therefore, this is a plethora of set of problems to work on. And I think this is also an appeal to many of the younger students who are sitting here. Please define your problems with this kind of perspectives. This will position you possibly in a slightly different way from where the mainstream AI is going. And mainstream AI is very, very competitive. And if you have to have a distinctive mark in that space, we here need to think in a different way. And in the necessity of thinking in different way is also to make use of our softer, visionary, philosophical ideas. And how do you bring it into a kind of a technology which would exist coexist with human being in future time to come. Thank you. Any questions?
Thank you, Professor, such an insightful talk. So I have a few contradictory points. So as you said, one of the very good point like that AI doesn't have decision-making capability. When it
No, AI has a decision-making capability. I have not stated
okay,
it doesn't have.
Kind of, you can say.
Certain limitations. I've tried to highlight some certain limitations.
Okay. So now suppose if I say in certain ethical point of view and all those decision-making capabilities, yes, there are some shortcomings, but even if you say human also make mistake, but it's some kind of logical analysis, reasoning through graph neural networks or some kind of graphical analysis, we may also be optimistic about the fact that AI may also come up with some kind of logics which can
So AI won't come up with logic. The whole point is try to look into it, that we have to come up with logic.
Yes.
AI will not come up with logic. The whole point is that my whole stress has been that we need to rethink our problem-solving approach.
Right, right.
Okay, we are going in one direction. That direction will flow, that direction has a potential, it has established a technology, but with reference to that also, we need to think differently. And that AI will not do. You have to do it. And what you have to do is that, see, if you look at it, it becomes also a different kind of a statement, that AI is becoming a monopoly of few. If it has to be democratized, then you have to bring in these other values into it, and that would also give a diversity of AI.
AI governance or ethics, you were saying.
All of these issues. So ethics is, do not consider ethics is simply something we shall think about after AI system is built. The point I was trying to make is a multi-objective optimization is learning just not for performance, but also the ethicality and other issues which are related and has to be brought in not as a secondary issue, but as a core optimization itself. So that's why I said that AI learning or AI system design, finally it's solving an optimization problem.
Exactly.
But it's solving optimization with a single optimization function. And it's not being also treated with a multi-objective optimization.
Right, yeah.
So I'm not treating, everything is being treated as a single objective function. But if there are multi-objective optimization means there'll be a set of comparable solutions.
Exactly.
Okay, then as a human being, you may choose the one which you feel that ethically or logically it's correct for you. That alternative is something which AI design should throw.
Yes, so in the second point that you mentioned about the consciousness, again I have a point.
See, I have not gone into consciousness.
No,
I have talked about simply sentience. Sentience is what? See, you are intelligent, okay? If you look at an animal, say dog also has a sense of pain. It is not as intelligent as mine. It has a sense of pain, sense of happiness.
Right.
Now, AI doesn't have a sense of a pain. Are you getting my point?
Right.
AI as a medical AI can say that you will die 3 days later. Fine? It will not matter to say that you will die 3 days later or you will have life for 20 years. There is no sense of the AI system in delivering this message. So when the doctors say, we give bad news in a very moderated way, AI health doesn't know that. So therefore, AI health has to have an assessment of what is the other person would feel about it. Therefore, a model of a recipient. So AI is not isolated. It has to be in a loop in terms of with which it's reacting. So that could be one way to bringing in a concept of sentience. Consciousness is very far off. I do not talk about consciousness.
You are saying that the empathy, how to generate the
Empathy, exactly.
even though the robot cannot feel it. Yeah, that's what you were saying. Sometimes in certain scenarios, it is not necessary to feel. Say, for example, we can quantify the emotions. We can, like machine can do it, but it can respond. Sometimes
maybe we can discuss later on, but it's not that It's not that always it is required. I did not say always it's required, but the moment it makes it into multi-objective, so those designs actually can look into these of the issues as a definite parameters to look at. Because see, I gave an example which is very, very objective experiment. This is not with this sentience. I talked about energy. Today, when AI systems are designed, nowhere energy comes up as a parameter to optimize.
Exactly. Yes. Thank you, sir. Thank you.
Thank you, sir.
Hello,
Thank you for your wonderful. So we'll not take question right now. It's already getting a little late. So sir is here. We can discuss with him and ask questions later. So we are up for next talk by Dr. Amit Kumar Pandey. So Dr. Amit Kumar Pandey, PhD in robotics and AI, is a globally recognized robotics and AI scientist and innovator with a deep commitment to advancing social innovation through technologies for humanity. He is the president of Socience AI and Robotics, France. Dr. Pandey has held prominent leadership roles, including CTO Robotics and AI at the Roviel Space France, and President Chief Science Officer and CTO at Hanson Robotics, the company that created one of the world's most expensive social humanoid robots, Sophia. So there is a long list, but I will not read that. So I welcome Dr. Amit Kumar Pandey for his talk. नहीं आप कॉलर माइक लगाएंगे वो लगा देंगे कॉलर माइक
और ये स्लाइड्स आ गया और इससे हो जाएगा Okay, so good afternoon everyone, and I think this talk and between food there is one more talk, so I am not responsible for delay on your food at least. So I will try to give a perspective which will try to balance the industry side, R&D side, and how we can start or think about some collaboration. What are the real practical challenges which we have to solve, and do we need to collaborate between continents, and why? So this will be a balanced perspective. Hopefully I will have enough time for that, but as I am coming from industrial background and also working a lot on R&D collaboration, so we will see that there are some of the challenges which we have been solving at R&D level, but still it needs more advancement to go to a product level. So I will try to again give a spectrum and the idea, especially people who are sitting or behind at the back and who has lots of questions about how they can contribute in this revolution, which is about robotics and AI. So I will again try to answer some of those questions in slides, but we can have further interaction on that. So with this, let me show this slide, which is about a spectrum of robots. As you can see, some robots are having human-like hand, some are having gripper, some are having legs, some are having wheels. And even there are robots which are having human-like face. So these are some of the robots with whom I have worked, or I should use which like they have worked with me in one situation that we have been trying to make them intelligent, interactive, or improving even their hardware, software, or capabilities. But they have been also working in a real-world scenario in lots of application domain. So what is key here is, I don't know, okay. So we have to figure out what kind of role we are thinking about these robots. And those roles are somehow shaping the needs in terms of how these robots should be And then they are shaping the capabilities, which kind of capabilities we have to bring in the robot, and then that how shaped the design. So yet I think we don't have a universal robot which can do everything for all the scenario, for all the tasks. So it is still important to figure out what is the boundary, what are the design conditions for these robots, where they are going to be deployed, how they are going to be working, what is the autonomy level, and lots of other factors. And that's why I wanted to show that this is really a spectrum, and we have to be grounded instead of too much inspired by science fiction movies as well. But something which is already happening, and I think in the talk which has been already discussed, is that scenario is changing. In the past, robots have been working mostly in an isolated environment in the industry or whatever setup we can think about, where they have been designed, the environment or the task have been designed for robots. But the shift is, it is now becoming part of our environment. So these robots are becoming intelligent enough, the robots are becoming capable enough, and they are also being able to be companion for us or even collaborative, even in industrial setup. So what it changes? It changes the way robots should be behaving. It changes the way robots should be perceiving the environment, perceiving the human, perceiving their capabilities. And that's where lots of new R&D challenges which can be emerging, which we have to solve, and we have to solve together, because the next frontier is very interesting, and even we don't know what kind of solutions can come in the future once these robots are really capable enough and working with us. It was the case with smartphones. We could not have imagined all these applications which are with a smartphone now. So this is going to be the same scenario with robots. And that's why I wanted to highlight this article where I was invited to write in the CEO magazine about giving a global view about what is happening when we are talking about robots, when we are talking about AI, and especially when we are talking about physical AI. We have been working in humanoid robots for decades, but we did not know we will call it at physical AI in one time, but things have been changing a lot. So the interesting point is that in the past, we have been talking about automation. And with AI being part of robots and sensors being capable enough to have real-time data and AI being capable enough to process them, we are integrating everything together. And that's how it is becoming a shift from automation to autonomy. And when that part is there, human and robot, they will start to collaborate, they will start to work together, and that's what they are doing. They are sharing the task, and they are thinking who can do what, so that the whole goal can be achieved or task can be achieved in a more meaningful way. So if we see this as something which can be an enabling technology, it will be really disrupting all the sectors. And it is already happening. So there will be lots of applications which will be coming, and it will be also good in the sense that it will boost competitiveness, it will boost the ecosystem, it will create a new kind of ecosystem. And it is already starting to happen, is that perhaps companies might not be buying the robots, but they will be using robot as a service. So this is the opportunity where you can also contribute in this ecosystem and enhance the robot, their capabilities, and make them the part of the service ecosystem. So we have reached to a point, but it was not that easy, as you have seen from the talks from the past and from all the prominent researchers in the community. There have been lots of research which have been happening in the past. And some of those have been very interesting, and it took decades to come out to the real commercial application. So these are some early works where I was also involved. Understanding human, that is very important. Robots are no more isolated. So how they will understanding the human, their capabilities, understand, to reason from their perspective and consider that in performing task. Like in these videos, you can see in the first video, the robot is able to understand that for the person, it has to hold the object somewhere from where it can see. So it is also seeing things from the person perspective. So it is changing the perspective to understand the environment from others' perspective. And this is also happening in all the different kind of scenarios and videos. So we try to create one unified framework which can be useful for different scenario, task, and robots. And it continued, like here, how a task of cleaning a table can be achieved in a collaborative manner. So one interesting part is the robot is able to create human-robot shared cooperative plan. And on the right top, you can see at one point, it is even thinking that one human can take an object and give it to the second human, and second human can put it in the trash bin. So in this way, it is optimizing the time to perform a task, it is optimizing the energy, and perhaps it is also utilizing all the agents who are in the part of the ecosystem. So that's where we are trying to figure out that how robots and a human can be part of the same mission to be achieved in a more efficient and more purposeful manner. And as I told, it was not easy. So you have already seen lots of control, perception, planning, contribution, and many blocks should be working together. For example, if I have to drink this glass of water, I should not take this like this. I have to really plan in advance and hold it like this. So this is one of the constraints, that how a robot should be intelligent enough to understand how to perform a task and what others can do, how I can interact with the object in the way it will facilitate the performance of the task. So there are lots of scientific knowledge which have been serving as the backbone of this. I cannot go in all the details, but I simply wanted to give some idea that there is really science behind what we are seeing today, robot working in the real world environment. And that's why from the capabilities development of robot, let us see some practical applications. And this is already happening. Robots are becoming the part of the education ecosystem. They are being deployed in healthcare facility. They are also becoming part of service sector, and they are also being deployed for entertainment and many other kind of industries. Again, these robots are at least able to understand the human and the human environment. So let us start seeing them as tools, as enablers, which are helping us to do things in a more efficient, in a safe manner, or why not to enhance our life and way of living. And that's where one of the applications which have been very close to me is the healthcare and elderly care, where I think we already talked in our past talks, so I will not show videos and all the results. But the idea is that how they can really help to fight with loneliness, or to maintain the dignity, or to boost the cognitive health, or to help in walking. So there are lots of applications which we can see, starting from memory, like boosting the memory, or having cognitive health, or to physical support or walking assistance. And we have been also engaged in a trans-cultural nursing project, where these robots have been trying to gain the cultural intelligence, so that they will be taking care of the people, or being part of their lifestyle in a more integrated and in a more engaging manner, instead of trying to impose a particular solution or particular way of interaction on people from different cultural background. And I think teleoperation is getting momentum again. Everyone was talking about that, and during COVID, we have also done this type of experiment, which was very interesting. I simply wanted to highlight this. So on the right, the person is controlling the robot as the avatar, and in that sense, a nurse is transported through a robot body to interact with a patient who is staying remotely, and perhaps because of COVID also in a social distancing manner. And then the person is not only communicating verbally, but also through facial expression. So again, depending on the kind of robot, you can transport different kind of capabilities, different kind of mode of communication, and also performing the task remotely. And it has lots of application. And people used to complain that robots are going to take jobs, but there are really applications where this kind of technologies are enabling people to perform tasks remotely for people who might be differently able and might not be able to do a particular task or job. And I think in Japan this is already happening. So this is the enabling phase of the technology, when we are trying to integrate a technology, a set of solutions at the right place just to bridge the gap. And we, being creative, can think about lots of applications. We have been already talking about autism, and with Petra, with Professor Kedar, and with the rest of the community, we have been deploying these kind of social robots for education, for special education, for autism. And there have been very interesting feedbacks and how we should be shaping the advancement of this technology for this type of therapy was already given back to us by the community who have been directly using of technology. So that is also very important, to think about co-development and co-creation of the solution by deploying it in the real world environment. So with robots, let us have just one slide on AI Studio. So this is also one of the products we are working on. And here you can see all these videos contents are generated by AI. So this ad is completely generated by AI. This part of the movie clip is generated by AI. And this news article and this even the clothes and the fashion industry, they are using AI. So this is one of the places where AI is contributing a lot without even getting a body of the robots. And this is some of the products which we are also pushing, and we will be also happy to collaborate and contribute in this direction. So it can be very effective way of storytelling, engaging people or engaging kids in a more dynamic and more attractive content creation. Okay, so and you can see on the left there are lots of kind of tools which are part of this studio, but I will not go in detail about that, because we have already talked about capabilities, we have talked about applications. Now let us talk about impact, and that will be the point where I wanted to highlight that there is still lots of collaboration opportunities which we should be thinking about to create the right kind of impact by bringing the technology back to society. So once upon a time, I think you can see a few people there who you are able to identify. Someone with hat, yeah. So somehow I am looking younger there, just 5-6 years ago, I don't know why. And there is Professor Behra as well, who is happy as usual in this event as well. So this is something I wanted to highlight, because this is the first time I was appointed as the general chair of this conference, and I insisted to bring it to India. So this is the first time we try to bring IEEE Roman conference to India, which is one of the oldest conference. And we discussed with Professor Behra and our colleagues from TCS and other places, and they told that yes, we will support it, let us do it here. International community was asking me, why you don't do it in Paris? You live in Paris, there will be more audience, more people coming there. But we insisted, no, let us do it in India, and even if I am in France, we will have good local community to support there, and we will make a history in the conference history also, but we will also create a community which is very much needed. And that's how it started. That was, I think, in the inauguration session, and the theme was responsible robotics and AI for the real world. At that time, it was not that much part of the real world environment, but we thought and we imagined that it will be. And that's how we have started to shape the theme and the content of the conference. And then when the conference started, we prepared a message as usual for the delegates. And in the message, it was very interesting to see. Obviously, we told it is first time in the Indian subcontinent where we are organizing this. And the idea was that we coined the term robotically developing regions, where we have been working in robotics a lot, but it was not that advanced at that time compared to other parts of the world, and we wanted to bridge this gap and to make it more engaging and more developing contents about robotics. That's why we wanted to bridge community, and we obviously thought about it has to be benefit for society and to the world. And at that point, we even thought that robots and AI are really coming together. So we even put that they have to work together, and that will create new kind of application. And that's where we have to bring communities from robotics and AI together. And I am very happy that we have been very successful in achieving the objectives. And I think that was the conference in which from India we got largest number of submissions, high quality submissions for the first time in IEEE Roman, and big number of papers were accepted that, and that's where we got the confidence also that we are really doing international level of research, and we are able to publish in good venues, and obviously we are able to get contributions from 30 plus countries at that time, and it was very good for us to continue, and that's how we thought that let us continue to collaborate. Because in that conference also we brought industry, academics, stakeholder, decision makers all together. And those were the pillars we are still trying to bring together so that we can have very useful robots, which are not prototype, which are not research, which are not only marketing or business, which is combination of everything, and making them useful for long-term perspective. And these are some of the pillars. Obviously, interdisciplinary collaboration is very important to bring something useful. Then stakeholder collaboration, serious technology and knowledge transfer. It is not necessarily that it has to be from only one direction. Knowledge is everywhere. So how we can share and transfer that knowledge and that technology to create something more impactful. And obviously, human-centered approach is very important. But all this without a purpose will be directionless. So we have to really figure out why we are designing something and what it will be used for and what impact it will be creating. So obviously we have to do that together, and that's why we are exploring different collaboration possibilities, and we will be also exploring collaboration with HiVe Robotics. We have representative from board of directors of HiVe Robotics, Petra, with us, which is largest European community. We are also exploring some collaboration with one of the biggest events we are organizing in Paris, which is Global Indian Organization. And since this year is India-France Innovation Year, we have a special session on robotics and AI and competition, and we invite you all to be part of that. And we are also in the process of making a new India-EU synergy in robotics and AI. The objectives are 3 C's: community building, conferences and events, and also commercialization opportunities of whatever we are doing, whatever you are doing, whatever the European community is doing, how to bring them together, and how to even open market, how to create joint lab, how to create joint R&D projects, all will be under this umbrella. And this form is very important. Please scan this and then fill up with your interest, with your engagement level, or what you want this community to do. We are capturing this thing. If you scan this and if you are getting a website address, just copy that website address in the browser and you will get the access to the form. Okay, and these are the people who are in this event. Petra, Ambika, and obviously Professor Khatib is everywhere in US, in Europe, so you can reach out to him. Professor Kedar, and then Nicola, who just landed here. They are coming from different backgrounds. Some of them are coming from academics, some of them are coming from applied side of robotics, some of them are a decision maker, some of them are interdisciplinary expertise like language and literature, and how we can bring a model for robotics and AI on that. So we have really a multidisciplinary set of people who are around this. So let us find them, collaborate with them, ask the questions if you have anything, and then they will be happy to guide and assist. And today morning we already have an initial meeting on this. And obviously I think Dr. Amit is the happiest to find this collaboration and we will be having more happy faces once we will be launching this very soon. And we will really need all your engagement to be part of this initiative. But I must warn you that there should be a way to make the collaboration impactful. And this slide is that warning slide. So let us assume that we want to make a water tap which is able to regulate cold and hot water and then give the right level of water which we want. This can be our initial objective and idea. But what wrong can happen? Can you guess what is behind that blue box? Okay. We can make something like this also, where we are still able to achieve, in one sense, the objective that we are able to regulate hot and cold water, but perhaps it is not the sustainable solution, or perhaps it is not the long-term impact-making solution. And that's why we have to be really very careful that how we will define, how we will execute our collaboration, and the right strategy, right starting point, right skill, right interface, and the right policy is also very important to push in this direction. And if we are able to do that in the right way, including academics and industrial collaboration, everyone will be able to contribute. You don't have to be coming from technical background, scientific background always. We need people from all different disciplines. There are jobs and positions for different kind of levels, different kind of expertise at managerial level, at technical level, at non-technical level. And obviously, if you want to make startups, this is the right time. So you can be part of the ecosystem with the right kind of solutions and offering. And that's where the community which we are building will support startups and be part of the Indo-European ecosystem. And sometime I used to get lots of queries from students that how to jump in this domain, how to get a job. My one advice is just have at least 2 skills, so that 1 + 1 is always greater than 2, and then you will be ahead in the curve. Like if you have some idea about AI and robotics, you can go in autonomous robot engineering kind of job. If you bring psychology, social science, and robotics deployment together, you can go in a different kind of social robotics job. So there are lots of fields and opportunities which you can contribute, but always remember, at least you should have 2 kind of skill set. Sometimes they are confused, should I go to industry, should I go to academics, or where should I hang? And that's where I will encourage all of you to understand this concept of technology readiness level, which is TRL. And that gives that where you want to position yourself. If you want to position yourself in invention and discoveries, working at TRL 1 and 3, if you want to go on solution and validation, but not directly on the product development, this mid-level is very good for you, depending on your interest. And if you want to contribute in product and deployment and real life application, you can think that, okay, let me find a position where they are working in this high level of TRL. When I say low level TRL, high level TRL, it is just the naming which has been given. It does not mean low level job or high level job. So don't be confused about that as well. And it translates into fundamental research at that place, development in the middle, and deployment on the higher level. So depending on where you have interest or which kind of nature of work you want to do, you can go in that direction. And then that will define you where you can work or where you want to work. Like in public or academic research lab or public-private joint lab, industry or innovation lab, even big companies, they have their product department, but they have their innovation department as well, which we have also in past where we have been working. And then obviously, if you want to go on the direct product or real life facilities, and that is the place to explore. So this is basically a summary slide for all the young minds to understand what is their interest, where they want to place themselves or see themselves contributing, and where they should look for job or opportunities or collaboration. Sometimes you spend time but not at the right place or not at the right location, and that's where you get more frustrated about everything. And that's where this Indo-European collaboration can help you to anchor at the right place with the right kind of ecosystem and cluster. And this slide is, again, I will not go in detail, but it is a summary slide of some of the still unsolved or partially solved problem of a industry or practical deployment point of view, as well as the gap in skill set which is needed by the industry. So this is something for you to understand, that there are lots of R&D collaboration possibilities, but at the same time there are lots of places where you can self-improve, or community or even universities like this can fill in the gap by creating the right kind of skills programs, which is very much needed, including automation and manufacturing, or mechatronics, or system integration or prototype designing. We have been lacking a lot in this, and this is time to really move forward in that direction. And operational environment is very important as well, because it gives another kind of challenges to be solved. For example, we have been working also on robots for a space application, and there you can see we have created a multi-limb robot from scratch. But the same problem of control and perception changes dramatically there, because of the environmental conditions are different, gravity is different, and you have to create a new kind of constraint to solve those traditional problems which we have been doing in the past. So this is another example that perhaps a particular kind of task or challenge might have been solved for a particular deployment environment, but once you go underwater, which we have been whole day yesterday, and then once you go to a space, there are different problems to be solved. And when talking about impact, I should again come back to IIT Mandi. I was invited for a TEDx talk in Bangalore, Indian School of Business, I think. And I was talking with Professor Vera. I wanted to show something from within India, what we can show. And we have been getting so many interesting projects from IIT Mandi that I decided at least a couple of those can be shown there, because what was interesting is that we were able to live demonstrate some of the solutions which were driven by scientific advancement, R&D, and integrated in the real life system and the solution. I don't know if we have team here, they can stand up. Yeah, please stand up and clap for them, because they have been really doing interesting work. And now this talk is online, so you can watch and make it widely publicized so that we can show that we are really doing impactful work. And that is also some of the things which we are pushing to see how we can commercialize in the future. And that is underway. And we are already making community around. We have been making community since 2 decades, and it is time to make the community stronger And there have been also one book chapter which has recently published on social robots. Why I am highlighting this is that once you will go inside, you will understand that it is really cross-disciplinary and multidisciplinary thing. And everyone should be contributing instead of being worried that, okay, if my background is part of that or not. So let us do that, and this is really my last slide with a vision for India. So when there was IT wave, we have been riding that wave. We have been creating services. We have been contributing in that wave, and that shaped even the strategy for India, that shaped how we have been seen globally as Indian IT industry service provider. That was very good for us. Then AI wave started. And what we have been doing now is that instead of only riding the wave, we are now strengthening the AI wave. We are contributing very significantly to shape the wave and to make it more impactful. What next can come? Why don't we create the next wave from within India? Instead of riding or shaping, let us make something which will define the next global wave and for the entire community and for the entire world for a good purpose. And why not robotics and manufacturing can be that wave which we create from within India. And personally, I am very much interested, motivated, engaged, and dedicated and dying to create this next wave with all your help and support together. But to create that kind of wave, we have to think differently. What differently? We have been already talking about skilling up. We have to go beyond. Don't just skill up, skill right. That is very important. Which kind of skill set you need to have. We have been talking about startups. I think we don't have to just do startups by following the wave. We have to start right. What we should be doing. That is very important. That is change in the mindset. Take some risk, start something right, instead of following the startup waves that what others are doing. And don't just build up, build solutions. Identify problem which is not solved, which is not touched, which has been not thought about, and then build solutions. And that's where we will be really able to create something which will be beyond the fashion, because now everyone is talking about AI, robots, perhaps because it is a trend or fashion. Go deeper and do something which is for a purpose, and use all these things, think about meaningful tools to solve societal problems. And that's where we will be able to really create something impactful and interesting. With this, I will stop here. Thank you very much, and we are here to communicate and talk more and see how we can create something together, better and bigger. Thanks a lot. Okay. Okay.
Thank you, sir. Thank you for such a wonderful talk. We can take one question. It's already late. If anyone has a question.
I think she
No.
left.
We just had in the morning meeting for EU-India strategic partnership, and we are going to take, so kindly, where is Narendra? Narendra, can you share this code, barcode, and people fill in? Yes. I think that will be very helpful. And it's lunch time. I think people have disappeared.
They are already at the lunch. They are already at the lunch.
They are already at the lunch. But I think it should be promoted so that we can support Amit Pandey for his effort. Thank you.
And supporting your vision also for India. Yeah. Okay, thanks.
So thank you. Before we end, we are felicitating our speakers. So I will ask our director sir to come onto the stage. So please, Professor Khedda, can you come onto the stage? Sir, Professor Santanu Chaudhary, please come onto the dais.
तो अनाउंस करो अभी लंच कितना बजे 2:30 बजे 2:30 so that will be delayed half an hour, right? Okay.
So we stop here. Our next session will start. So the time actually is 2:30 p.m. We will start. So we will break for lunch now.
We have a very interesting panel discussion on human AI interaction. Will be moderated by Professor Santanu Chaudhary, and it will be 5 o'clock, right? 5:20 p.m. 5:20 p.m. So all of you will enjoy that session. Thank you.
Hope you all had good lunch, and I want you to be attentive for our next session. Our next session is by Professor Bigyan Bandyopadhyay, and the title of his expert talk is Event-Triggered Sliding Mode Control, Fundamentals to Recent Advances. Professor Bandyopadhyay is an esteemed academician specializing in systems and control engineering. He dedicated 35 years of his career to IIT Bombay, where he rose to the position of Institute Chair Professor and currently serves as Distinguished Professor at IIT Mandi and Visiting Professor at IIT Jodhpur. His research interest lies in discrete time, multi-rate, output feedback slide mode control. Professor Bandyopadhyay is a life fellow of IEEE and a fellow of multiple premium Indian academies, including INAE, NASI, INSA, and Indian Academy of Sciences. Please welcome him with huge round of applause.
It has come in here. So
good afternoon to you all. I'm very happy to be here today for this talk. But at the outset, I thank Professor L.D. Behera for inviting me to serve this institute. And also I thank Dr. Narendra, who is coordinating this event with his colleagues and friends. I will talk on today a very important, modern, and very active area of research topic, the event-triggered sliding mode control. Event-triggered sliding mode control, the fundamentals to recent activities. When it has started, what is it? I'll try to, and our new results on this topic in the context of sliding mode, I will be discussing. The event-triggered, this first started several years ago, I think, few years ago. And this event-triggered control, event-triggered control is a very active area, and what we have shown that it is very much important in the context of network control system. When you have to send the data through a network, you have to share the network. You don't need to send the control, this idea, the basic idea of this, of this topic, the basic theme of this, that you don't have to send the data always. Unlike the traditional control, the feedback control system is a closed loop system, continuous feeding the data, or in a discrete manner. But here it is not. So the less resource will be utilized, as well as the network can be shared for many other purposes. So with this idea was developed by Tabuda, and then every day there are dozens of, half a dozen papers are coming in the top control journal on this topic. So my purpose is here, the first time, this idea, in the context of sliding mode, because I have a rich body of sliding mode control when I was in a research group at IIT Bombay, then I will discuss with this thing, how event-triggered in view of sliding mode, in the context of sliding mode, what is the meaning of this? What are the new results? What are the advantages? Which I will touch some of the important points. So what is event-triggered? I mean, in this order I will cover this lecture, talk, event-triggered sliding mode, global event-triggered, and conclusions. So basically it is like that, where the plant, actuator, sensor are located apart, not in one location. So this technique is more suitable, because you sense the data, the sensor or observer maybe in some other location, sense the data and send through a network, and then it has to come to the actuator site, and the plant is somewhere else. So in this context, this technique is very typical network control system. The controller, one plant, another plant, multitasking the network has to do. The several data are to be sent from several plants. So all the time, if the network is busy, then you cannot do that. Sharing network, cost effective, all these things. So with this idea, this idea came out. I think this is the Tabuda paper. I was seeing only is a huge, highly cited paper. The closed loop is distributed over a geographical region. Communication through network is fundamental of a network control system. So there are two ways the control, as I discussed, the periodic and aperiodic. The periodic is easy to, any continuous control you implement in a discrete manner. Continuous, that era has gone, analog controller, digital computer, digital card, disk space card, signal processing card. So you discretize, discrete sample instant, the data are taken and that is sent to the controller. So this periodic, that is called periodic control system, periodic implementation, easy to implement, simple techniques are available to analyze the stability of the system. Aperiodic minimizes the resource utilization, analyzing the stability is a challenging task. That is the most important. Because aperiodic, you are not sending the data. When there is an event is violated, that time you send the data. And then it has to be challenges that with this condition, one has to show the system is stable. So this is the thing, the analyzing the stability is a challenging task. Event triggering is an aperiodic strategy. that applies control on demand. When you need the control, you apply. You don't apply control all the time. So this particular idea, I will come, this is the periodic control system, like there is a clock, and inefficient resource utilization, open loop sampling. As you know that one sample value is sent to the actuator side, and then there is no sampling. After some duration, in fixed time, another sample is done. So between the two samples, the system is an open loop system. So intersampling behavior, open loop sampling clock is reset again once the time h is elapsed, irrespective of the state evolution. We do not know how the state is. It is not unstable. There are sampling, time, Nyquist criteria are there. It will be overall closed loop system will be stable. Stable system can be, but certain sampling time, it can be unstable. More importantly, the intersampling behavior, it is not in your hand. It may not respect the actuator. It may be very high. So those are the burning problem, the good problem, burning problem or the actual problems in discrete implementation. More control, no suitable parallel tasks. Intersampling may be difficult to analyze. And the event triggered is, there is the event, not the clock. And when the event is violated, control is updated in aperiodic manner. Triggering rule governs the control update. There is a triggering rule. And when the rule violates, then you apply the control. So event generator has a closed loop sampling mechanism, but it's a continuous monitoring of the state. Unlike the discrete sample data system. Continuous monitoring, so it's a closed loop system, always. And when the event is violated, that time you apply the control. Control is not applied all the time. So this is the fundamental of event triggered control. Resource can be utilized optimally and highly desired in a network control application. So this particular, I will just come up to this, that how it is in a very briefly what Tabuda has shown, that asymptotically stable system, that ISS stable, input state stable concept has been used here. It is the linear system, and this is the, let's say there is a continuous function such that the closed loop is like this, and this is the control. That this is the, that U of t is kappa x of ti, which is the control at t event. At that instant, event related, and then that control is applied, and then there is a Lyapunov functions, positive definite, and the derivative v dot, which is dou v dou x into x dot, is less than that. Alpha and gammas are the k infinity functions, and then it can be shown if alpha inverse and the gammas are the Lipschitz, then the condition satisfies. The gamma of p is less than that, and if ti plus 1, the ti there is a control, and the ti plus 1, the next control is applied when the event is violated. E of t is greater than that. Just when it is greater than that, up to before less than that, the control is not, the event is not violated. The same control which is applied at ti, that remains valid. And then the ti plus 1, when that E of t, the error between xt and xti, is more than that, then the control is applied, and then v of is less than 0, the system is asymptotically stable. So this is the first result which is proved in the event triggered, which is existing. So what is our contribution? What I wanted to show here, that the event triggered, how it is in the context of sliding mode the first time in control literature, which is brought my students group at IIT Bombay, and one of the students' PhD thesis, first paper came with his thesis, Dr. Abhishek Behera. He is an associate professor at IIT Roorkee at this moment. So in his thesis, the first time in control literature, how event triggered in the context of sliding mode, what is that? Sliding mode control, actually it's a very, one of the accepted techniques for the robust control design. It has been widely used. Actually, this idea was invented in the then Soviet Union in 1950s by Emelianov and Utkin. These are the two stalwarts. Unfortunately, both of us are not with us at this moment. So they first conceived the idea that using discontinuous control, can you stabilize the system? the people will not be convinced initially why discontinuous control. Most of the engineering systems are continuous, whether it's a power plant, robotics, manipulator, electrical machines, nuclear plant, all continuous differential equation. Why to make it complicated by giving a discontinuous control? So naturally, the people have not initially to understand this concept. So it was confined in Soviet Union, the then Soviet Union, for a long time, until the disintegration of the then Soviet Union, and Utkin shifted to United States as a chair professor in Ohio State University, and he wrote a book in English language. And he first published a paper in English language in control transaction in 1977. And that sparked research interest all over the world. People did not know. It was confined in Soviet Union. What is variable structure control, sliding mode control, a discontinuous control, but still it is useful for stabilize a system, and it has a marvelous property that it can reject the disturbance completely. No other control can, even in theory, can reject the disturbance. So when there is a sliding mode motion, I'll try to discuss some part of it. So that paper has sparked research interest all over the world. Europe it came, United States, of course, and then India, China, South Korea, Japan. Everybody tried to understand what is sliding mode control? What is this discontinuous control? The Filipov gave a very good solution. When there is a discontinuous right-hand side, but the solution is continuous. Of course, there are problems in practice. The aerospace engineer, mechanical engineer, they told that it is not working because actuator is a mechanical device. So when you apply discontinuous control, it chatters, which is not taken care in the mathematics. So of course, there is a result of that, I am coming to that discontinuous control. Then that, due to that paper and book, in his English language book, everybody started to understand, and it was very important technique, several applications, several implementation. Of course, there are certain shortcomings. By taking care, it has been done. And the subject is so important that IEEE Control System Society recognized that there is a technical committee within IEEE Control System Society. And that technical committee is responsible to hold a biennial international workshop on this topic. Fortunately, this year it is going to be held in Leicester, in UK, some university, and fortunately it was held in first time in India at IIT Bombay in 2012. And all the researchers from all over the world, they come, they discuss, they meet, and these ideas, new ideas are evolved from the discussion, and selected topics are further selected and published as a book in Springer Berlich. So this is the history of these things. So I had a very active research group, and with that, we started first how the sliding mode, how the event triggered can be viewed, or in the context of sliding mode, what it can give the benefit. Because sliding mode is a robust technique. Event triggered is not a robust technique. That was the hunting in our mind. And then what it was done, that event triggered sliding mode, because as I told the background of the sliding mode, the robust performance against match disturbance. When the trajectory is sliding along the surface, there is sliding mode. There is a concept, in fact, a full-fledged course I'm teaching here. I got an opportunity to teach here. So this thing, that if there is a matching disturbance, then in theory, exactly it rejects the disturbance. And the closed loop behavior is governed by the sliding surface, which is in the designer's hand. So this is that robust performance against matched disturbance. Switching control can be implemented through relay feedback, so nominal behavior can be recovered in the sliding motion. When it is sliding, it doesn't care whether there is a system parameter variation or where there is an external disturbance, of course bounded, is acting on the system. So this is to achieve robust performance with event-triggered feedback strategy. Why event-triggered? Because event-triggered, if it is combined with this strategy, so obtain the robust event-triggered under switching control action to achieve improved steady-state performance with discrete implementation. So this is I'll quickly go through some of the mathematics part. It is there in our several papers I'll refer later. So what is that? That we have given a concept, a new concept, perhaps the first time in the event-triggered sliding mode. In sliding mode, there is an exact sliding mode in continuous. In discrete, it doesn't exactly slide, even in the theory, because due to the sampling. So it crosses the line, and there is a about the sliding surface. And that is called quasi-sliding mode. That paper is also highly cited paper. And the event-triggered, neither it slides, nor it slides about the surface. It's the practical sliding mode. So I will show how does that practical sliding mode occurs in the event-triggered sliding mode control. So this is the linear system. Of course, this theory is extended to nonlinear system. This is the control. And digital implementation, as I told, the never S is 0 exactly. Periodic in a steady state depending on the sampling time and the disturbance. Aperiodic means event-triggered in a desired steady state bound. So what is done? There is a definition that exists a delta 1 greater than 0. Given delta 1 greater than 0, there exists a T1 such that the system trajectories reach the region in the vicinity of the sliding manifold at time T1 and remains there for all the time. What is termed as a practical sliding mode? How does it happen? This motion around about the sliding surface is the practical sliding mode. What is the meaning of that? Which is not existing in sliding mode control theory. So UT is this, XTI the control is applied, and this is the sliding surface. Then show that TI is greater than for some this. Then the next triggering is the TI plus 1 when this event condition violates. Then the next control is applied, the TI plus 1. So what is happening here, that this condition, if K is greater than that, then it can be shown with this derivation, the Lyapunov functions and the derivative of the Lyapunov function. What essentially it makes this derivation, the trajectory is coming towards the sliding surface. And the moment it crosses, about to cross or just crosses, then there is no, because the event is not violated. In continuous case, you have a control immediately on the surface. Those who are working on sliding mode, they'll be knowing these ideas. And then you apply another control. The moment it leaves the surface, you apply another control. So it exactly slides in continuous. And that solution is known as the Filipov solutions, discontinuous control system, discontinuous dynamical system. But here what happens, when the trajectory is coming, just crosses the surface, then there is no such control, because event is not violated. It depends on when the event is violated, then the control is applied. Then the moment it crosses, let the trajectory is allowed to cross. And after crossing, after some time, the event may be violated. And then the control is applied. And again, this condition is true, that V dot X, this condition is true. But when it has crossed that XTI, this is the thing, the signum of STI and signum of ST are the same sign when the trajectory is on the same side. But moment it crosses the Lyapunov stability theorem, it violates. So trajectory further proceeds. But the moment the event condition is violated, then again the trajectory goes towards, because the V is less than, this is called the very famous irreducibility condition. The trajectories are attracted towards the sliding surface. So finally what has happened, the trajectory remains bounded in the vicinity of the sliding manifold. STI minus ST is this thing, and let's say that ST, that exactly the event is taking place at STI on the surface, then maximum deviation of the trajectory, which is alpha by norm of A. And it depends on the system, the design parameters alpha. So what we have termed in the first time in the control literature is the practical sliding mode. So this happens in event-triggered sliding mode. It does not exactly slide. It does not introduce a quasi-sliding mode motion. It gives about the sliding surface a different kind of motion, first observed, and this is called the practical sliding mode. And then this ensures the practical in the system. And this is the way it is done. Then the question is that where does x goes? The motion is confined about the sliding surface. So where does the system states? So it will be shown, again, further derivations. I am not going much details. It is everything is there in our monograph. So this is that state is ultimately bounded. Because as it is a practical sliding mode, the x1 doesn't go to 0 exactly. It is not an asymptotically, it is ultimately bounded. So what is that bound? That is a theorem is given. This is the regular form is well. And when it is sliding, then x2, when it is on the surface, about the surface, then this relations, x2 relation, then there is a proposition. Proposition is that if system trajectory is ultimately bounded during practical sliding mode, norm of x1 is less than that in a ball, the trajectory. The near the origin, the x1 is confined. How it is? That these are the different Lyapunov equations, and this is the derivative, the Lyapunov functions for the x1, and then the derivative and all this derivation. It has been shown that if every v1x is greater than that, then the v1 dot x1 is less than that. That means when the trajectory is coming to the ball, when it is more than that, the Lyapunov function, the v1 x1 is more than that, then this condition satisfies. But if it reaches within that thing, then this condition does not satisfy. Trajectory can blow up, it can come out. So this is called ultimately bounded of the trajectory. So this is that with this, so thus the trajectories enters the set, the v1 x1 is less than that in a finite time, then applying the inequality of this, the Rayleigh inequality, this is called, one can conclude that trajectory is ultimately bounded in the set B, which is shown, which is here. This is the set, the norm of x1. And x1 and x2 are algebraic, so x2 is also bounded. So these are the two important results were first proposed. And then the inter-event time. It has to be shown that in some control, the next control I am applying by checking an event condition. Then between these two interval, the inter-event time, that has to be greater than 0. If it is not, then hitting on a single instant several times, and they have researchers have shown in the physics. It's a this kind of phenomena. If it's hitting, then system can be unstable. So one has to show that there is a finite greater than positive inter-event time, Ti. What is also shown by this way, the Ti plus 1 minus Ti is equals to Ti is greater than that, the lower bound. It can be greater than that thing. That means it is bounded by this. It can lower bound is this. So if it is a lower bound, upper bound can more than that. The lower bound, if it is a positive, I have to show, then that construct a gamma, which is this is 0, excluding that origin, then the derivative of the norm of E is these relations. This holds, we have shown in our paper. And then further derivation, it can be shown that the xt is this, after all these substitutions, and here in the last equation, norm of Et, which is less than that, and T minus Ti, so that if we write that triggering instant, the error equals to this when the triggering, at the triggering instant. If it is more than that, then that is violated. If it is less than that, control is not changed. So at the triggering instant, if this is equated, and the T minus Ti, that is Ti plus 1 minus Ti is capital Ti, then it can be rearranging, it can be shown that the Ti is this, is greater or equal to this. So this is the inter-event time, and for a local, or x is not infinity, then this does not hold, because x tends to infinity, this is 0, so log 1 is 0, so Ti is 0. So for the global event ticket, another proposal, if it is local in some area, in some region, then for a finite xti, then this equation it shows, which is derived here, that this is a Ti is greater than 0. So on rearrangement, the bounds for Ti, lower bound for Ti, it is seen that for any bounded region that exists state tau, and the Ti is greater than small tau. So this shows that inter-event time is finite, it is greater than 0 for local event ticket, for in a bounded region. Of course, unbounded region, the Ti will be 0 from this expression, then there is a modification further has been done. So alpha must be selected to incorporate practical constraints. If tau minimum represents the minimum time for control execution, then alpha should correspond to Ti minimum. That some time is there for control execution. So that inter-event time must be greater than the tau minimum and demands a continuous state. Then there is a further byproduct, you can say self-triggered sliding mode control. Event triggered is continuous measurement of state is needed. The states are large, of course output is another solution. Then you have to continuously measure the state. So self-triggered is that you don't measure the state. What you do, it is just simply that idea. Only thing is that does not require hardware circuitry to evaluate the triggering condition. Triggering instant is determined from the previous sampling instant. So it is more feasible, and the self-triggered, once it is triggered, and then the Ti plus 1 is obtained from the earlier instant by this formula. So self-triggered always guarantees positive lower bound. Only advantage is that is the lower bound is the less, it is less than the actual event triggered, but you don't have to measure the state. So one has to trade off between these two conflicting characteristics. Then one example, of course, are the practical sliding mode and the state evolution. What is the difference in this, the last graph? Inter-event time versus time. In a discrete system, the y-axis is a flat, constant, because the sampling time is constant. Sampling time I'm not changing in discrete implementation. In event triggered, so that's why this can be anywhere. The inter-event time is the y-axis, x-axis is the time, then this is the plot of the inter-event time. It can take place immediately, it can violate the triggering condition, apply some control, and next it may be after some time. So that plot is somewhere in that plane. So that's why this is the plot of the inter-event time, and this is different from a discrete, the routine discrete implementation of the control, what is normally done in most of the Indian applications in the missile lab, in the DRDO, in all kind of system, discrete implementation. Then the global event triggered, that event triggered, as I told you, that Ti, the global, that is, if it is for entire state space, the Ti is greater than that. And then is a semi-global is that there is a subspace, subset within that Rn, if there it is true. And the local is that there is the X belongs to D and the union that kappa, and kappa belongs to D, D is a subset or, some subset of Rn. So there are global event triggered, semi-global, and then the local event triggered. So here it is that further we have changed, this is we see the triggering mechanism is this, and the event mechanism can be designed the globally robustly stable. Because here at x tends to infinity, this is 0, the second term within the log. So log of 1 is 0, so Ti is 0. So this particular ideas, the event condition, what has been proposed for the local event triggered will not work for the global event triggered. So this is, that event condition is like that, it's a function of state also. And the ut is this, and this is the controller. The k of xti, there is a constant part, and there is a proportional part, and with all this condition. Then this condition and the rest of the derivations are the same, the Lyapunov functions and the derivative of the Lyapunov functions, and all this derivation, again, that when it is on the same side, then trajectory approaches towards the surface. When it crosses, the either reachability condition does not hold, trajectory crosses, and then it gives a. There is an important thing to notice here. Once the trajectory reaches it may cross it, it may not cross it as the control is not updated, but the trajectory remains bounded due to the triggering mechanism. And this, if the triggering happens exactly at Ti on the surface, then the St is function of x of Ti. It is not only a constant practical sliding mode. This sliding mode, the sliding motion can be obtained, xti is 0. So this is the Ti is greater than that. And in this case, you see if it extends to infinity, the global, then this part is that sigma. This it can be shown that is a finite, even x goes to 0. Due to this triggering rule we have changed. Due to that, this ti is a finite time, and the rho tx, this kappa is this. And here also ti is greater than that, then this can be shown the inter-event time, the similar calculations, and then that it is also confined in when it goes to a practical sliding mode, then the state also bounded within this set, the norm of x1. This proof is similar to the earlier case, only the motion is within a cone. It goes to infinity as t goes to infinity, that x goes to 0, because due to that term. It doesn't remain in a practical sliding mode. Initially enters, and then depending on the condition, it takes place above the sliding surface, and at t tends to infinity, it goes to 0. So this is the difference in the global event-triggered sliding mode control. So this is the inter-event time in this particular case, which is also shown by some example. So this is the conclusion, that in event-triggered, the steady state bound can be designed as far as the desired value, which is not there in event-triggered original proposal, robust system performance. The strategy can be extended to nonlinear system, which is done. In fact, global stability is also obtained by designing different triggered rule. So it can be viewed, just I was examining, it is an open problem, the human-robot interaction, that it can be viewed. There is a plant, there is a robot, environment, physical interaction, social interaction, all this feedback can go. A supervisory level of control human is watching within a feedback control system. And then what is happening, event-triggered framework allows execution of control on demand. And human-robot interactive system, the information flow is aperiodic in nature, so due to human behavior. So it is a most a good candidate, the event-triggered, when human-robot interacting system. Because human behavior, it is supervising the whole control system, the robot, human, controller. So that condition, when it will be violated, it may not happen in a periodic manner. So the event-triggered control system is a good candidate for this kind of application. It's an open research area. It has not been done much. So with this, I will conclude. Of course, I am not alone. There is a small international research group on this particular topic, not the event-triggered sliding mode. That is myself, my student, of course, Abhishek Behera, Dr. Abhishek Behera. He is a faculty at IIT Roorkee, associate professor. With his PhD thesis, this idea first we tried in 2017, I think. He's a PhD. So now he's working there. They are my collaborators. Seeing you is a chair, distinguished professor at RMIT, Australia. He was past IEEE IES president. We have a recent paper in the next month in automatic control, event-triggered, 2 degrees of freedom idea. You can have a look in the April issue. Then Zohan, he's my old friend, host when I go to Germany in Humboldt Fellowship. So he is a chair professor at Ilmenau at Germany. And Abhishek is my former PhD student. And she is also did after Abhishek a PhD on event. He is a faculty at Indian Institute of Science. And this is the first paper, came in the control literature. The 18 is the monograph, and 16, this is the first paper came on this topic. And then every day, every week, the papers are coming. As you know, you propose anything, Chinese people are ready to extend those ideas. So if you open any control journal, you will find dozens of papers in a week on event-triggered sliding mode. So, and these are some key, there are many papers you can find from my homepage. So with this, thank you very much. This is a monograph published also, I think, in the 18 in Springer Verlag. So with this, I close my talk. It is good if some questions are.
Thank you, Professor Bandyopadhyay, for this interesting talk. May I request Professor Shubhajit Roy Chaudhary to kindly come on stage and felicitate Professor Bandyopadhyay.
I will expect few questions, and particularly those who are working on sliding mode control. I'm sure some researchers have come from other IITs who are working on this, certainly from my former PhD students, because there are 7 or 8 IIT faculty and also guiding. And one of the most notable is Dr. Shyam Kamal. He is guiding, I understand, 15 PhDs at IIT BHU. So some of the students might have come from his group and his IIT. If any question, then yeah. Yeah. Yes.
Hello, sir. My name is Ashutosh. I am a student of Dr. Abhishek Behra.
Yeah.
So I want to ask that how this event code control can be implemented in a multi-agent systems. How there is a possibility.
Yes, it can be done.
And
There are multi-agent system, some work is going on. Multi-agent system is a different, there are many agents, so synchronization. So if the event condition, you have to set up a event condition, you have to propose an event condition so that the formation control, multi-agent system, leader follower, all these system, this kind of system, the event guard ideas can be applied. Event guard is a concept, is a theoretical ideas. So this can be useful for any practical and in particular multi-agent system. So you can look into the papers, you will find.
Thank
you. Okay. Thank you. I understand. I'm seeing. Yeah. No, it is a pleasure for me. Okay, thank you. Okay, thank you.
Thank you very much, sir.
Yeah. Thank you.
The next session is on multimodal AI, and the session chair is Professor Arnab Bhavsar. Professor Bhavsar, over to you.
So good afternoon. After a very, technically rigorous talk, I think, we have equally interesting talks by several of our, industry representatives, and these are, I look at the list here, and these talks are, in a very wide, they span a very wide scope. So basically we have, applications of or perspectives of multimodal AI in driving an ADAS system. We have in aircraft systems, as well as a very interesting perspective on banking, right? So stay tuned for the 4 talks in this session. So I first welcome Mr. Amit Tadkod, and the title of his talk is also very interesting. Is AI making us more human? Right? That's a very, very interesting title. So I'll briefly introduce him. As a chief expert for human machine intelligence, Amit brings over 17 years of deep expertise in automotive embedded product development. He's result-driven technical leader who has successfully navigated the complexities of working with multinational teams to deliver cutting-edge solutions. And in fact, when you think of modern driving experience, from in-vehicle infotainment and instrumentation clusters to passenger displays and ADAS features, which we all experience, I'm sure, when we are driving these days. Amit has been an architect behind the scenes, spanning these systems, right? His mastery spans the entire software stack, from foundational drivers to high-level HMI applications across platforms like AutoSAR, Linux, and QNX. Today, he joins us in the auditorium to pose a fascinating question: is AI making us more human? Mr. Amit Tadkod from Bosch. Thank you.
Thank you.
Thank you, Dr. Arnav. Good afternoon, everyone. So today I will just try to touch upon how this human-centered AI, the shift from human-computer interaction towards human-centered AI, how this multimodal AI is affecting human, right? So I would like to focus on this. And the question is AI making us more human, right? Because most of the things what we as a human are doing today, AI is going to do. Then what is left for us? So let's see a different perspective for this. So to see how the relationship between technology and human has evolved over the period of time, I'd like to take an example from automotive because I've been working in this industry for last 21 years. And whatever I have seen, I would like to just quote upon here. So when we go back to 1980s, right, how the vehicles looked like, they were full of switches, the rotary knobs, every control we wanted to do, we just added one switch. So it became a complete cockpit, kind of what we see in the aircrafts today, multiple switches and all. What it meant for human, we had to learn the machine. We had to understand how to operate these machines, right? And over the period of time, we became like machines. We started giving the commands exactly what has to be done because machines were not much intelligent. When we look at it today, how it is, everything has gone. All these controls have been fused together. Everything is working together and we see a smart cockpit. Now, how this exactly has changed or how this has happened? So when the technology was evolving over the period of time, we started developing the systems which are unimodal. We started adding each and every modality one by one. And we created the system. Let's take an example of vehicle. When we wanted to see what is near me, we started adding the ultrasonic sensors, right? When we wanted to see which we cannot see it from the human eyes, we started using radars. We added lidars. We added cameras. We added, again, the microphones outside, what is happening around me, what is happening inside my vehicle, how the parts are behaving. Then we added the auditory system, haptical feedbacks and all those things. But all those things when we started adding, all were working in unimodal. They were not combined, collective intelligence was not available for this. So slowly we moved towards the multimodal thing. So when we looked at the multimodal thing, we started fusing multiple informations coming from multiple sensors. So one of the examples from this is again from the Bosch radar systems, wherein we have ECU which takes ultrasonics, radar, lidar, as well as camera together, and it creates a perception about what is there around a vehicle. When we look at it, the information coming from a camera, maybe which looking at maybe 120 degree or 130 degree angle is giving me something, one camera. There are, if we look at the today's vehicles, there are around 29 cameras mounted around a car to understand holistically what is happening. That is what Google has done. Radar, lidar, during night vision. With this particular combination, we can see what is happening up to 300 meters, which as a human being, I may not be able to see, detect. Similarly, the auditory feedback. When we are, the glasses are closed, everything is, I cannot hear what is happening outside, but somewhere the ambulance rings far behind, the system can detect. System can detect this from the audio as well as it can detect the signals coming from various sensors and help me to take the quick decisions. That is how multimodal AI is helping us. Now, in what fashion multimodal AI is helping us? I would call multimodal AI is offering us superhuman capabilities, which other way may not be possible. Just to take certain examples, we can see only when there is a light, right? But the combination of cameras, radar plus lidar, the vehicle can see in any condition, whether there is a light, no light, obstacles in and around, it can go beyond the obstacles. I can hear only the normal range. The auditory signals only things I can hear. But what if there is something beyond that? Let's say, for example, my bearings in the vehicle are deteriorating. They are making some sound. With the normal ears, I cannot hear. But when I put the ultrasonic sensors, they are able to detect that there is some problem in those sensors. When I have to collect the information and do certain reaction, minimally I will take 200 milliseconds. But with the multimodal AI, when I get information for multiple things, I fuse it together and system is able to respond within 50 milliseconds, right? As a human being, I always go for some schedule. Let's take an example of my vehicle. I have to change the oil. I always keep in mind, okay, I have to change the oil after 5,000 kilometers or after 6 months or 1 year. I have to go give my vehicle for the servicing, right? Again, it's a scheduled part. But what is AI helping me? The multimodal AI, when I have the ultrasonic sensors, when I have the vibrations I'm measuring, when I have the thermal part, I'm fusing it together. It is helping me to figure out when exactly something is getting deteriorated. And I can react on top of it, right? The brake pads, with the help of multimodal AI, we are able to develop the algorithms which are able to detect the brake pad wear live. It can tell me after how many kilometers I should change my brake pads. Also the tire wear, I can detect exactly when I need to change the tires. I don't have to even look at from the visual inspection perspective. So according to me, the multimodal AI is helping us to become superhuman. Yeah. So I would like to show certain examples, which again, I quoted from Google. So the Waymo car, which is mounted with 29 cameras, lidars, and radars, it is able to see everything around 360. And below you can see the camera feed, and on top you have what exactly it is seeing. As a normal human being, other way around, it is not possible for me to look at all the angles, keep and all, and still keep driving. Take another examples. This is again in a low light scenario. Scooterist suddenly drops. If I'm not alert, definitely I will make an accident. So fusion of this technology together and making the quick reactions, helping to avoid certain accidents as well. So what is the real offering of this multimodal AI, or in general the AI to the humans? It is offering me a safer environment, because as a human I cannot see everything. It is giving me more elements to look at it, right? So it is offering me a safer environment. It is helping me to reduce the cognitive load. I don't have to look here, there, and then the cognitive load keeps on increasing. So it helps me to reduce my stress level as well. I can interact with this multimodal AI with my natural language. No longer I need not have to learn how this particular machine is going to operate. I need not have to learn the commands what I need to say, right? So I can just talk freely. I can use the gestures. I can use my gaze, because that is all possible today. It is giving me an enhanced awareness about the surrounding, what is there around me. It is getting personalized. So not only the vehicle, you take any machine which is there, it can personalize as per your need, because over the period of time, it is learning you. The olden times, we were learning the machines. Nowadays, machines are learning us. They are getting personalized for us. It is offering us a super sensorium. So what we call it as a sixth sense. So the multimodal AI, if we use it rightly, it can act as a sixth sense for us. If AI is going to do everything, if AI is going to drive for us, if AI is going to do multiple things. So again, not sticking to automotive is just an example. If you take even, I think morning we were just discussing with Professor Arnav and others, that coding part and all, AI is going to take everything. What is left for us? So AI can take care of how to execute it. So it can act as an executor. So we are left with a director, right? So we can still give the intent, we can set the goals, what is required, why it is required. On what basis we can set these goals? Because we have the wisdom. Some decisions we cannot quantify only based on the data. Some decisions we take based on our beliefs, based on our past experiences. That is, then we have some ethical boundaries. We have our own belief system. Each one of us has grown up in different belief system. We follow different paths. We have our own experiences. Based on our own experiences, we take certain decisions. We put these boundary conditions, right? So that is still human. And the last part is the curiosity, the innovation. That is where we can focus. If we use this multimodal AI in the right way, use it as a sixth sense, we can still leverage all these parts which only humans can do. And that is still left for us. When in case of the current scenario, driving on all these hilly roads and all is difficult, right? So it is stressful activity for us. When a car is fitted with all these cameras, lidars, it can take up to level 3 or level 4 driving. It can take over, let's say, 80% of the driving task. At that time, we can look at we can utilize that time to really see what additionally we can do. So AI, if we look at this, it will help us to do an inward revolution. So we will get freed up from doing the things rather than we return to being ourselves. So that's the thought I would like to keep and end my talk. Is AI going to make us real human instead of becoming machines, which we have been following from over the years? Are we going to come back to being humans and start looking what we can do? Thank you.
Thank you so much, Amit, for sharing your take. Well, some will agree with you and some will disagree. Okay, thank you. I understand you have a flight to catch, but quickly I will invite Somjit Amritsar on stage to felicitate Amit.
Meanwhile, if there are one or two quick questions.
Any questions?
I think it was a wonderful perspective and really, quenched a lot of anxieties because Amit very, to me at least it seemed like he very nicely kind of demarcated what is AI meant for and what are we meant for. So thank you for that lovely perspective.
Thank you.
And if there are any more questions, Yeah, so I invite Mr. Somjit ji to felicitate.
The biggest curiosity came when you made the title as whatever it was. We were thinking because the typography could have improved in the wrong.
I can talk.
PPT, is it loaded?
So from one ubiquitous domain, like driving, right, we move on to another domain which really none of us can do without, and that is banking, right? And to share the perspectives from the banking, side, we have among us Mr. Hitesh Sachdev, who is the head Startup Engagement and Innovation Investment, ICICI. Hitesh Sachdev is a veteran banker with ICICI Bank. He has spent more than 22 years at ICICI, building and leading diverse verticals including innovation, fintech investments, private equity, investment banking, and SME businesses. He currently heads the Startup Engagement and Investment team at ICICI Bank. He has played an instrumental role in setting up the innovation team and executing cutting-edge technology projects for ICICI Bank in collaboration with startups. He manages the startup investment for ICICI Bank with the core principle of collaboratively working with startups and assisting them in creating significant value. He has made 26 investments into startup, including Car Dekho, Open Refine, Credit B, FingPay, Arteria Technologies, EQL Fintech, and Credgenics. He mentors founders on domain including payments, digital lending, SaaS, API banking, banking applications of emerging technologies such as Gen AI, blockchain, digital public infrastructure, and space tech. So clearly, he's here to convince us that banking is much more than just banking, and with this, I invite.
Thank you for your kind words, and good afternoon, everyone. Let me start, by the time presentation comes up, let me start with one question. How many of you believe that AI will be the CEO of your company? We will have companies which are run by AI as the CEO. Nobody believes that? Not at the CEO level? So we will have some of the companies which would be run by AI as the CEO, and primarily the job of a CEO is to take decisions, right, and manage people. And if in your avatar, we can train that avatar with a lot of the intelligence and a lot of data about the behavior of humans, AI can be the CEO of the company, and in soon we will see some of the companies being managed by AI as the CEO. AI journey, I would divide this into three parts, and the fundamental part is about large language models, which we call foundational models. So which companies in India or which startups in India are building LLMs or foundational models? Any idea? We'll make it interactive, right? It's afternoon time, so. Bharat Gen, yeah. Bharat Gen is a Section 8 company founded by IIT Bombay, and a lot of other IITs also joined them. Basini, yes. Sarvam. Sarvam is another one which is building foundational models for India, and they are building these models on Indian data sets. Whatever models we are using, ChatGPT, Gemini, Grok, Llama, all of them have been trained on Western data sets, while Bharat Gen, Sarvam, they are building the models using Indian data sets. So it will be more relevant to India, and we have multiple languages, dialects, right? So it will be more suitable to Indian context. Second layer, when we talk about AI journey, is obviously, so to build foundational models, you need a lot of data centers and high-end GPUs. Which are the companies which are providing GPU services in India? High-end GPU services, for IOTA, SIFI, yes. By the way, which is the company which is manufacturing these high-end GPUs? I'm getting all the answers from this side, This side seems to be more active. I want answers from the middle and this side. What is the market cap of NVIDIA? Sorry? No. Any other guess? Yeah, you are near, very near, yeah. Close to 4.55 trillion, almost equivalent to the India GDP, right? That one company which has the market cap which is equivalent to Indian GDP. So that's the AI revolution and the kind of wealth creation which it is doing for people who have embraced it. And the second part about the entire, so first part is your GPUs, chips on which you will run your models. We talked about models. So India, nobody is manufacturing GPUs. You all are importing it, right? Second, models, I told you, 2 Indian companies are building the models. Now third layer, which is application layer. That's where we have, as Indians, we will do really well, and we have started doing really well. We have so many applications which are now getting built on these models, and we'll see a lot of vertical domain expertise kind of applications coming out of this. So while models are being built by, chips are manufactured by mostly US companies, AMD and NVIDIA. Again, models are also built by mostly Western world, and we also China, which is kind of trying to build models which can run on low compute, right? Which is, you would have heard about DeepSeek, Kimi K1, Kimi K2, right? All these models, they are kind of running on low compute, so you don't require so many high-end GPUs. So, and per se, India also, people are trying to build models which can run on low compute. Now, when it comes to applications, that's where it is completely democratized. I mean, you don't need any, everything is open source. You have models which are open source models available. You have GPU services which are being made available by the companies like IOTA, right? So to build applications, there are no constraints. And you can actually train or fine tune a model depending on the domain. So for example, healthcare, some models will work better in healthcare, some models will work better in financial services. So the way to go is about building the models or fine tuning the models basis the domain. That's the next race which will start. Today we have models which are generic models. We don't have domain specific models, but going forward you will see that there are models which are either fine tuned or are made completely in relevance to a particular domain, right? So let me get into what we at ICICI Bank are doing. I manage startup investments and innovation at ICICI Bank. We are one of the most tech-savvy bank, and to remain ahead in the technology, we thought there are two approaches. One approach is to build a lot of applications, a lot of platforms within the bank, but that requires a huge technology team. Second approach is working with startups and using their innovations to solve some of our problems, right? So while we have a large tech team within the bank which does in-house development, I manage the startup partnerships and startup innovation. And we have, clearly defined areas where we want to innovate. So as a bank, we want to focus on lending, payments, wealth management, risk management, right? And these partnerships or innovations are not just for the sake of partnership or innovation. These are purely defined, we have 4 defined objectives that this partnership should either result us in some incremental revenue to us, or it should help us reduce the cost in our operations and bring in efficiency using the technology solution of a startup, or in risk management, or it can help us to improve the experience of our customers on our digital properties. We have our iMobile, which is our flagship mobile app. We have our internet banking. We have Instabase, a lot of other digital properties we have. And we continuously ensure that the experience of the customers on this digital property is better and better. Working with startup also helps us to build the culture of innovation. It helps us to do rapid prototyping, faster experimentation. And this is not working. Yeah. And let me talk about some of the partnerships with startups and the kind of results which it has yielded us, right? So IIT Technologies is focused on supply chain solutions. They help large corporates to ensure the entire dealer and vendor management in a very seamless manner. We have built a financing layer on top of it, and we are financing those dealers and distributors on Arteria's platform. Advarisk is another startup which has built an AI intelligence layer on top of the land records. So today, if you want to, let's say, buy a property, and you will do a title search of that property, right? And anyone who has bought property in this room, apart from this side, middle side, or when you buy a property, what do? Registration. But before registration, check the property. Okay. So one check is the valuation of the property, and the second check is the title of the property, right? So Advarisk has built a encumbrance, title check. So Advarisk has built an intelligent layer. In 16 states in India, the land records are digitized. But even though they are digitized, they are in a form that it's very difficult to consume those land records directly. You need a layer which will build an intelligence on those data which is coming out of those digitized land records, and then give you a title search report. So Advarisk does a title search for us and the property management for us. When we give loans, we take properties as collaterals, and Advarisk helps us to monitor all those properties, that there are no other encumbrances created after we have given loan, right? Then we have Anumati. How many of you know about account aggregation framework? What is account aggregation framework? Anybody? So it's a consent framework and architecture where financial institutions can share the data amongst themselves by taking the consent of the customer. So if you have an account with bank A, but you are applying for a loan with bank B, you need not go to bank A and take your bank statement and give it to bank B. Bank B will directly fetch that data from bank A using your consent, using account aggregation framework. So it's a consent architecture. So we work with Anumati for we built an entire consent architecture and account aggregation framework usage with Anumati. Car Dekho is one of the largest online car selling platform. We work with them wherein we provide car loans on their platform and other banking products on their platform. Property Pistol is again one of the largest residential broking company in the country. We have embedded our home loan APIs in their product. So whenever there is a transaction of property purchase or a property sale is happening, the customers can be given the loan offers directly at that point in time. FinPay has helped us to provide banking and financial services in rural areas, tier 3, tier 2 towns, using the AEPS Aadhaar enabled payment ecosystem, payment system. So in India, we have multiple payment systems. Which are the payment systems you are using? Any UPI, okay, then NEFT, then IMPS, then credit cards, then sorry, which is kind of, let's say, UPI. You have RTGS, right? And you have AEPS. AEPS Aadhaar enabled payment system, where with your biometrics you can enable the payments. So FinPay is helping us to do that in rural areas. These are some of the other examples of the partnerships. ShatSure, this is an interesting startup. They help us in our agri business, wherein we don't take any data from the farmers. We just take the let long and perimeter of the land, and basis the satellite images, ShatSure is able to help us estimate the income of the farmer. And also, while we are doing collections for the loans given to the farmers, we are able to map the routes of our collection managers using the route map provided by ShatSure. They do analytics on the harvest, in which area harvest is happening, basis that we route our collection agents and collection employees. So that's where our cost of collection has reduced significantly. Fable FinTech is powering our remittance business. We as a bank, we are one of the largest player when it comes to the remittances. The entire back-end platforms are powered by Fable FinTech. CreditGenix helps us in doing our collections digitally. When we give loans, we have built algorithms, and we know before a customer becomes defaulter. Before a customer goes bad, we know which customer will default. And that's where CreditGenix comes into play. Before delinquency, they use nudges to those customers and ensure that they pay in time. And if at all, if the customer doesn't pay, after the default, they help us in the recovery. SwirePay is a US-based startup where they have built a recon solutions. We handle multiple kinds of payments, and we need to do recon instantly. It cannot wait, because there are thousands of crores of rupees kind of gets transacted every minute. So SwirePay has built a recon platform for us. MyClassboard provides ERP to schools. They have 4,000 schools on their platform. Then through their ERP, schools are managing teacher salary, payroll, the online coaching for the students, logistics in terms of bus trekking, and everything happens on their platform. We have created a financing layer on MyClassboard, wherein the banking products can be available to teachers, parents, schools, and kids. Equal FinTech is one of the largest compliance company in India. They incorporate more than 10% of the companies in India. They help more than 100,000 small businesses to file their GST returns, IT returns, and a lot more other services like patent, trademark, copyright filing. Yeah. And there's a couple of, like, Skid.ai powers our entire phone banking vertical, wherein when you talk to us, you feel you are talking to a human. You're not talking to a human, you are talking to a voice bot. But the experience is kind of you are talking to a human. So they manage more than 80 to 90,000 calls using Skid.ai. We have ImpactSure, which is processing all our bank guarantees online. No human required. 60% of our bank guarantees are processed completely online without any human intervention. Then we have Sama, which has helped us to resolve conflicts and disputes with our borrowers. Court processes are very cumbersome. So they have online dispute resolution platform. We are using them, and that has helped us to resolve our disputes with our default customers. Yeah. These are a couple of other examples. You use On Finance, Signsy, and a lot of other. Sorry. This is. Can you take it back? Take it back to this. Yeah, so these are a couple of other examples like Devanagari. They help us translate all our documents. We can't rely on Google translation. They provide enterprise grade translation. We have bureau which helps us in fraud checks. When you onboard a customer, we need to be sure that we are not onboarding any fraudulent customer. ViewNet provides observability on our various platforms. So when you do a transaction on any of our platform, if it fails, we need to know where it failed. Because on the back end, there are multiple applications through which a transaction gets processed. So we need to exactly know where it failed and why it failed. Yeah. We have an innovation lab in Mumbai where we incubate startups. So every 6 months, we onboard 8 to 10 startups in our lab. We work with them, create solutions which are in alignment with our digital roadmap. We give them problem statements to startups, and we work with them, create products with them. So this is the second cohort of our startups. Go back to earlier. I know. Yeah, these are the startups operating out of our lab, and we work closely with them to create products with them. Yeah, I can go to next. We have, as a bank, created branches which are focused on startups. So you see the look and feel of the branch. The startups can operate from our branches. Our team will support them, help them resolve their problems. So its environment is also kind of conducive for the startups. And we do a lot of programs and events in partnership with a lot of other players, right? These are thematic events on different topics and different agendas. It's more of about building community, and most of the events we have startup founders, investors, and corporates attending these events. These are a couple of other accelerator programs which we run in partnership with industry partners. So RBI Innovation Hub, International Startup Fest, Gift City IFSCA. We've been running a lot of programs in partnership with them. We need a robust digital public infrastructure to do all the innovations which we see today. Whatever you see in terms of digital payments or digital public infrastructure, that is because we have a strong backbone in terms of digital public infrastructure. And we as a bank, we are a strong believer of supporting any digital infrastructure project in the country. So we have been working very closely with ONDC. What is ONDC? Anybody heard about ONDC? What is the role of ONDC? Okay, let me ask you. If you want to book a cab, what are the options? Sorry? Ola, Uber? Rapido, okay. 3 options. You want to order food, what are the options? Swiggy, Zomato. So, ONDC has been established to democratize the digital commerce. Why a small shopkeeper cannot participate in this digital revolution? Why there are only 2 platforms? It creates an oligopoly, right? There are only a duopoly. And duopoly is not good, right? It creates kind of a situation where you may end up paying more, or there will be other form of charges you end up paying. So ONDC is Open Network for Digital Commerce, established with the purpose to democratize the digital commerce. So we work very closely with ONDC to support this initiative. Go back. Yeah. And then we have IBDIC, which is building the digital, the entire Bharat trade network. So today, if you see, the trade is very cumbersome, multiple parties, and with Bharat trade network, it will ease out the entire trade problems. Sahamati is promoting the account aggregation framework in the country. And we also invest into startups. So these are all portfolio companies, and all rockstar founders, very proud of our portfolio companies. They've been doing really well. So yeah, that's about us, and happy to answer any questions. We are done. Any questions, please feel free. I don't know if you have time.
Yeah, no, I think we are very much well in time. So yeah, I think this is amazing. I mean, I at least personally don't know that AI literally penetrates so many aspects of, the banking sector. Thanks a lot, Nitish. Now the floor is welcome for questions.
So, you know, as a bank, we are looked upon by people as an organization where a lot of trust is involved. So, lot of AI applications which we are using, we have still not exposed it to the customers because these models hallucinate. They have gender biasness. That's why we have not exposed it to the customer. To give you an example, one of the company's management gave a mandate to, you know, the board gave a mandate to the management team that build a chatbot which is a very customer friendly chatbot. It should help the customers. It should resolve all the queries of the customers and it should be dynamic. So the team built that chatbot. One of the irritated customers, you know, while he was interacting with the chatbot, said that I am really frustrated with the services of your company and I want to file a low legal case against your company. Chatbot replied, no worries sir, we'll help you find good lawyers. Right? So in a regulated industry, we need to test the models. We need to ensure that they are not biased. They are, it should not distort the communication. So while we are using a lot of these technologies, but we are very carefully also putting it in front of customers. But going forward, I don't feel there will be any websites. Websites will be the day. I mean, there's no need for website. There will be a bot where you go and ask your query. That's it. Because websites are very cumbersome. You click. Nobody likes that. So in next maybe few, I don't know what time, but maybe 12 months, 2 years, 5 years, you will not have websites. You will have only bots, which would be able to answer all your queries. But thank you for the suggestion, ma'am. Thank you. Thank you.
Thank you, Mr.
So I
Sachdev.
request Mr. Somjit ji to kindly felicitate Mr. Hitesh. Where are you? Oh, sure. Yeah. So now for the third talk, again we have very commonly experienced flights, and we know that flights are one of the safest modes of transport, and airlines go to a lot of extent to, of course, make our lives safe and comfortable. And to share, interesting perspectives on that, we have with us Mr. Lennon Dhanraj, Senior Engineer Manager, Mission Systems, Collins Aerospace, India. He will be talking on synthetic data generation and behavioral simulation. So I'll quickly read out about Mr. Lennon. He's a seasoned technical leader from Collins Aerospace with over 2 decades of experience in the aerospace industry. Lennon is a specialist in flight critical systems and advanced simulations. He has been at forefront of developing high fidelity modeling environments that bridge the gap between virtual testing and real world performance. His expertise is particularly vital in today's landscape of rapid AI integration, where safety and reliability are paramount. Today he will be sharing his insights on a cornerstone of modern AI development, synthetic data generation and behavioral simulation.
Good afternoon everyone. Thank you, Professor. I was speaking with a lot of the dignitaries today and the students, and one thing I realized is that not many know about Collins Aerospace or RTX or what we do. So I just have a quick videos, I think small videos, 1 minute, 2 minute videos that helps us understand the magnitude of what we are and how we contribute. So let's start off with one quick video.
Progress. It is not automatic. It is not inevitable. It is initiated by tirelessly asking the hard questions and finding answers. Excellence is developed. It is produced. Our commitment to excellence defines the future, and it defines us. Because the progress we make matters. It matters in safe and sustainable flight. It matters in the defense of the allied nations. And it matters because what we deliver protects and connects the world. A relentless pursuit of high performance drives us forward. Today and every day, we are committed to excellence in our technology, product design, and operations, and in our program execution. It allows us to see what's ahead and what's over the horizon. Collins Aerospace, Pratt & Whitney, Raytheon. We are RTX, and we are committed to excellence.
So this is a very good, I would say, introduction to our company. RTX is a combination of 3 companies, that is Collins Aerospace. We have Pratt & Whitney and Raytheon. From Collins Aerospace perspective, we'll be talking more about it, but just to give a little bit more from Pratt, I think Pratt, everybody knows, it's one of the main engine suppliers for most of the aircrafts. And then we have Raytheon, which does a lot of missiles and defense work related. And I think I got one more video here. I'll just quickly talk about the companies together. I think we have a very large company located all over the world, about 185,000 employees, 80 billion in net sales for 2023. And I think the numbers kind of tell you what we are. Why is this number very important? This gives you a magnitude in terms of what we do. I was just telling this morning, and I'm going to repeat that again. Almost 50% of the thing that you touch in an aircraft, in a commercial aircraft, is built with Collins Aerospace, or it is Collins Aerospace product that is used in it. So this is a small video on what we do.
We are defined by the questions we ask and the challenges we take on. When will sustainable be the standard? Will data be the difference? Can materials be lighter? Can they handle 5,000 degrees? How can travel be transformed? How will we make the world safer? Decisions faster? Are seamless communications the key? Can what's up there help us down here? Is human ingenuity limitless? Is our true potential endless? At RTX, we take on the big challenges. We ask the big questions, and we find answers. We are RTX.
So, in my speech, I'm going to be kind of distributing it into 3 parts. I'm going to spend a few minutes on the introduction of the company, and then the second half, I'm going to talk about the journey of our synthetic data generation. And the last one is like how we evolved into behavioral study. So I'll quickly be running through this. These are basically how is Collins Aerospace so big? So I'll just give you one example out of all these parallels. So we have Arthur Collins, who started off the Rockwell Collins entity within Collins Aerospace. Everybody knows who landed first on the moon. That's Neil Armstrong, right? But do you know what he told when he landed on the moon? I think everybody knows that a small step for man is a giant leap for mankind. But did anybody think of what radio did he use to kind of communicate from the moon to the earth? That was Collins' radio. So that's kind of a heritage of all of them. So we've got Hamilton, Goodrich. So these are all like different heritage that we kind of brought in together and formed as one company called as Collins. So what do we do in an aircraft? So we power it, we start it. I'm not talking about the engines because the engines are part of Pratt, but we do have the starting, we do the complete ventilation in the aircraft. We do the power and controls of the aircraft. We connect it, we guide it, we monitor it, we protect it, and we land it. So this is complete like what we do. So this is a very old slide, but it gives a complete picture of everything that we do. And in India, I think we work primarily on both engineering and in operations. And we've covered almost all the portfolios of what you see here on the screen here, starting from avionics to landing gears to cabin to, I think, ejection seat. So I think, and including the evacuation slide, I think, which is all manufactured and engineered here in India. So I'll skip a few of these slides. This is more focused on like what we do here in India. We are about 6,500 employees, both in engineering and in operations. And we are located in 3 cities. Hyderabad and Bangalore is where we have the engineering engineering where it happens. And in New Delhi is where we have the business and sales. In Bangalore, we also do have operations center, a new one which is opened in the SEZ park. Now, why is that very important, or why am I like picking that one out? That's because the evacuation slide, in case if the aircraft lands in an emergency, for almost all the Airbus and Boeing aircrafts is manufactured here in Bangalore. So I do not want any emergency to happen, but if in case it does happen, don't worry, you're in a safe hand. You will be able to exit the aircraft easily. To give you one other example, the team that I run is called Mission Systems. We do a lot of military work, and the ejection seats, which are there in the F-16 aircrafts, that is majorly engineered or supported by our team, either here in India or in Puerto Rico. And these ejection seats, the SS-5 ejection seat, I think during the recent war, there were 5 crashes and all 5 of them were successful and saved the pilot. So I think this is the criticality of what we kind of contribute within this aerospace domain. So this small video kind of gives you a quick overview of our Bangalore office.
Welcome to Collins Aerospace Northgate Campus, an integrated workspace sparking innovation and transforming the future. The state-of-the-art lab facilities gives a truly hands-on experience, enabling conceptualization and validation of innovative designs. Secured spaces and smart facilities help to foster collaboration, nurture ideas, and build future designs with cutting-edge technologies.
This is a world-class facility that nurtures creativity and collaboration.
Flexible work areas are designed to support hybrid work culture, providing perfect work-life balance. From the smallest details to the highest pursuits, adherence to highest quality standards at college.
Yep. So I just skipped the video a little. So now I go to the phase in terms of our development cycle, in terms of our synthetic data generation and like how we move towards behavioral design. Before I go there, I just do want to explain that this is the journey of my team. It does not include the entire, I would say, Collins Aerospace journey in terms of AI or in terms of machine learning or in terms of data handling. It's not comprising all that. It's more focused on one problem statement. We need machine or we need data to train machines. And how are we going to get that data? And aerospace domain is a very sensitive domain. You cannot have videos or you cannot take videos extracted from an aircraft and given or to train a machine learning algorithm. So how do we tackle that situation? How do we address that problem? That's where our team kind of comes in. To go further into that, we need to understand what one of my team does. So we talked a lot about Collins products and we talked a lot about aircrafts, but one of the supporting products that we also have is the simulation products. What is simulation products? These are basically image generators that helps us create visuals. These are visuals that support how we look at it, but in the end of the day, these are level D flight simulators that helps trainee pilots to train on ground level simulation before they start flying an actual aircraft. So our team does the visuals for them, our team does the software, and we also do a lot of the content which goes around it. Among all these products, there was one product which will be of interest for IIT here, is we've got this something called as the Spectra View. This is very similar to what is being developed in the Mira lab. But what is happening there is that like you are focused on a camera system that will be monitoring or understanding the behavior of the subjects inside. This is the reverse of that. This is a projection system. So it's a 360-degree, this is a 270-degree projection system, which is mainly used for rotary wing simulation. So you have an aircraft which wants to fly, and you want to kind of train a pilot in that. And so this is a solution that helps to go over there. There's a lot of possibilities if you can combine these two. We can explore more about that, but this is something I want to leave it with you so you can explore with it and see what solutions is there and then reach out back to us and we can see how we can collaborate as we move forward. So flight simulation. Flight simulation, as we understand, right, like is basically pilots before they go and fly an actual aircraft, they actually have to spend about a mandatory 200 or 250 hours worth in a level D certifiable flight simulators before they get eligible to go and sit in an actual cockpit. So naturally, a lot of the content that goes out of the window, the visual content, is developed by our 3D engineers. And one of the biggest complaints that we get from our customers is that like the out of the window content looks a lot like a 3D content, but whereas the games are improving and you have massive improvements in games where you have like water, reflection, you have like very real life kind of content simulation over there. So that's what we try to incorporate into our data as well, trying to make sure it looks as realistic as it can. And while we are doing that, we kind of, we were like exploring other opportunities. And that kind of helps us to kind of create content which is like more and more realistic, and we try to push our systems and our creative ability to the next level. While we were doing that, 2020 COVID came in. As I was telling, right, like I'm just talking about this one journey of how this team evolved in terms of creating data. So that time we had from the University of Michigan 2 professors who reached out to us and who asked us to kind of help them create data so that they can train their machine learning algorithms. So we had two approaches. We had actually technically only one approach, the traditional animation, that is create 3D models, follow a timeline, and then create animation, which is what you see here at the right side. What is this animation? This is like, if you want to do facial expression, it is like moving each one of these objects, like your mouth, your nose, your eyes, and like it's a very time-consuming process. So, and while we are doing that, if you look at the animation that we have created, you will notice that like they're very rigid, because we have got very tight deadlines. We want to just understand the concept, whether can we use a synthetic data to train a machine learning algorithm or not. Will that be possible? Will that be feasible? And if you look at them, right, like they all walk like robots, and if you look at the pilot, right, like he doesn't even blink. He's just like staring and moving objects, there's nothing reacting. So I think this was our first kind of stab at trying to see how we can create synthetic data for this. So while we were exploring that, these are all parallel lines or parallel timelines. I'm talking about character and character animation, and then I'll go into the automation aspect of it. So if you look at it, right, like we started exploring and seeing what can we do and how we can speed in the process. So one among them is trying to find external tools, if we can use them to create 3D characters. And if you see, right, like we started using our engineers to kind of create, and this is one of the characters that they've done. Back then in 2020, 2021, I was about 75 kgs, a little bit overweight. So the guys who created me started hinting that I need to exercise a little by making me exercise in the digital world. And I think that is also kind of there in the character expression as well. So we got something over here, right-hand side. We call it as the ideal state. If a person is standing and doing nothing, he doesn't just stay frozen. He does move a little. He does circulate his blood a little. So we try to kind of regenerate that one. When a person is talking, he does move his eyes, he does move his head, he does move his face. So we are trying to like, explore and see how we can kind of do more in that region. Then we started creating a different pipeline for animation. We started taking characters, we created the animation, and then we decided not to go into a rendering approach, that is create a render output, but we rather took him into a game engine and started using the game engine as our physics supplier. So we had two options. We had Unreal and Unity, which are the two main game engines that were there outside. We explored both of them, and in the end we chose Unreal as one of the game engines. Parallelly, while we are working on the modeling aspect of it, we also started looking at something called as the MUHB verse, machine understanding of human behavior. So MUHB is a machine understanding. This is where we've got our 3 patents and 2 trade secrets in this area. But what is this? This is basically trying to feed in data into the machine learning. And over here on the right-hand side, you see something very, if you've used an Unreal game engine, you will be aware of it. It's just a 3D character who's like going into a closed object. And basically we are like trying to trigger and see if it can trigger lights switching on, switching off. This is basically just an exploration to kind of understand what will later become our framework of our work. On the left-hand side, you'll see the technology that we use for like, to create the same content. If you notice now, we've created a series of videos, and it's easy for us to kind of get the output from the Unreal Engine. We also do have capabilities where Unreal supports giving us data as output, not just visual data, but also technical data. This is where we kind of teach the machine learning algorithm in terms of how we annotate. We use a real world annotation file versus a synthetic world annotation file, and then try to understand and see what's the accuracy that we can get from it. So I think this was one, and this is the last part of my speech, where we are talking about what we kind of worked on. So in the end of the day, we created a framework which has got a library of characters, a library of actions, and a library of environment. Now this is all synthetic or 3D characters and 3D library. Then we started having a library of, I would say, actions or inputs that we can give to this. This series is basically something like the pilot is starting off from Bangalore to Delhi. He needs to start feeding the data into the avionics. We just give this verbal input to it. So it knows exactly what it has to do, which controls it has to go, and then create an animation pipeline, pulling out information from the library. And lastly is to create the output of it. The output can be of different resolution, it can be of different camera angles, it can be of different, I would say, exposure. But end of the day, these videos that is created, it's all automated, it's all done in the background. And we take that data and then feed it into the machine learning algorithm so that it can help understand different aspects of it. This is a very good example. This is basically for touchless lavatory. So within the aircraft, we were looking at options on how we can create touchless lavatory. What does it, why was that? Again, it was driven from the COVID time. So we wanted like people to kind of use the lavatory but not get exposed to any of the germs. So while we were doing that, we noticed that every time we move a sensor, we've got a 24 hours delay to get the output. Because the sensor is moved, testing physically has to be done, and then we have to look at the data and then understand how it is. So what we tried to do was we started creating the same content but in a virtual world. So we get the same sensor output, we started programming the same way, but we use the sensor output to kind of get the exact X, Y, and Z coordinates as an Excel output that we can put it into the machine learning algorithms and understand whether this is the right position of a particular sensor or not. And this is all automated using the same framework that I showed before. With this automation, what we got was that like we can do different permutations and combinations of different sensors, and then in the end understand how or which is the best location for a particular sensor or not. So this is one of the I would say well acclaimed idea that we had within our team. This also gave us a little flexibility in terms of our characters. What if a child wants to use the lavatory? Will the sensor react in the same way or not? What if a person wearing shiny clothes goes into the lavatory? Will the sensor understand that, or will it bounce back the lights in the same way or not? So I think that was the final idea. I did oversimplify the library aspect of it because I can spend a lot of time on it, but the whole idea was that to explain that data is one of the crucial information that is required for most of it. And I think that is where we have a biggest challenge. And we are all looking out for, if you look at the speeches that we had yesterday and today, they're all focused on different aspects. But one thing which is common is, where are we going to get the data? Is it going to be an Indian data or not? Is it going to be, is it something that we can adopt? Can we train it? How do we train it? And I think that is the only focus of what I wanted to get in through this presentation, in terms of, yes, data can be created. We just have to find out a way of doing it. With that, I'll stop. So thank you again. Thank you for this opportunity.
Thank you, Lennon. Yeah, very interesting talk to, it shows what really goes on behind, in terms of the tech, behind the aircraft. So the floor is open for questions.
First of all, Lennon, thanks a lot for your wonderful talk. I was just wondering that when you were presenting about the creation of this artificial human beings using various kinds of fusion softwares, so that kind of things work well where you'd like to simulate specific situations, like inside an aircraft or inside an auditorium, something like that. But do you think that we can create such kinds of 3D fusion structures to understand the physiology of human beings? Because nowadays, I heard that in my generation, people had to dissect human bodies when they used to study medicine. Nowadays, I heard that simulation is used as an alternative to studying the dissection of human body, and that's how anatomy is being trained. So how well do you think anatomy can be trained like that?
So within the simulation universe, I think there's another field that we have not talked about. Again, Collins is not part of that, is the medical simulation. And that is a different domain all by itself. And the answer to your question was in your question itself. Yes, it is possible. And there are a lot of work happening there. There's a lot of exposure that has been
Your mic, maybe closer to that.
sorry. And there's a lot of work happening in that area as well in terms of medical simulation. Sorry. So yes, there's a lot of work happening there, but it's a field that is completely different, and it's got a different set of expertise. And in terms of simulation in that area, there's a lot of work happening, more focused on critical illness, like, and or in terms of more precise work, like might be in neuroscience. And so I think there's a lot of work happening in those areas.
In Air Force, we check the physiological aspects of the pilot when he's pulling G. That means when he is pulling the aircraft very high, so the G is acting, so 18G or so there, how his response, how his physiological thing will go. So there is an Institute of Aviation Medicine, IM, and there is aerospace medical officers, say they do, and that has not with the this purely in military domain, where on also for the astronauts who go. So if you go in 0G condition, how you will behave, how your muscle will act and react. So ISRO does give something If you remember, ISRO had taken this thing, and also this also. So it is beyond this thing, Collins. Okay. But yes, these are being done. There are institutes available especially for this.
Any other questions? Yeah. So I have a question. Sorry.
It is very interesting that you showed at the steps for synthetic data generation. So when the human intent management, I did not see in your presentation. The point is you are taking what the human being is doing, but what he is about to do or what is his intent of doing. Is there any study on that? Like you showed that in the restroom, he's trying to find out where the soap dispenser
Correct.
is. So, and then you have created the synthetic data around that. So whether it is he's trying to find soap or he's trying to find a tumbler, so that intent management is, how is it covered? Would you like to throw some light on that?
Sure. So part of our work also includes behavioral simulation. So I do have some additional slides which kind of supports that, but the idea of that is understanding the behavior of it. So I'll give you an example. Again, for the University of Michigan, that was their ask. They gave us 3 scenarios. We have a person, a mother who's taking her child, and going to the lavatory with the bag, but spends about 10 minutes and comes out. Then we have got a similar situation where an elder gentleman goes to the lavatory, spends 10 minutes and comes out with the bag. And then we've got, I would say, a middle-aged or kind of suspicious person who goes to the lavatory with the bag, spends 10 minutes. And we had to kind of simulate those different contents or those different behaviors and teach the machine, like, okay, this is what it is. This is, when you look at a person, like a mother going in, you can look out for other information. Is it something important? Is it something that we need to support? Does the air stewardess needs to go and try to assist the mother? Is the mother in some kind of crisis? And similarly, right, different rules are added to different scenarios. So I think this is what we call as data generation, and it is not the exact example what you told, but like it's very similar in terms of a behavior. We also do a very similar calculation for pilot behavior also, which kind of covers with macro animations or with macro behaviors, eye movements, rapid eye movements, drowsiness, calculation of those. But I think that is, we are still very far from that. We still have to teach the machines to understand full behavior before we actually go and expect them to understand macro behaviors. So I think we are still in that journey, is what I would like to say.
Okay, no more questions? Okay. Thank you, Mr. Dhanraj. May I request Mr. K.B. Rajendran to come on stage and felicitate Mr. Dhanraj? Thank you. Thank you, sir. Well, there will be a break now, and we'll again assemble here at auditorium for a panel discussion on future of human-AI collaboration. Yeah. Yes, sir. Panel discussion starts at 5 p.m. and now we'll be evaluating the poster presentation at Village Square. So there's a break in between. So kindly assemble at 5 p.m. here for the panel discussion.
KioScan is a Indian-European collaboration Google form. So everybody is requested to scan this code and fill up the form.
Yeah, so as discussed in the morning, so we are planning a big collaboration between India and Europe, starting from community building to conference to commercialization, creating R&D opportunities, job opportunities. So this is a QR code which will help to capture your interest and how you can contribute or part of this at different levels. So please try to access this code. You might get a URL through this. Just open the URL and fill in the form, and then we will make some solid collaboration very soon with all your help and interest. Thanks.
Thank you, sir. Yeah. Okay. Okay, so the final program for today is the second panel discussion of HiVe 3.0 that will be is on future of human AI collaborations. It is going to be moderated by Professor Santanu Chaudhary with the panel members. We will wait 5 more minutes because they are still coming. Let me brief about their Okay, we will wait for their arrival.
I just want to quickly check if the panel members are in the audience. If not, we'll wait for them for another 5-10 minutes. Professor Aditya Nigam, is he around? No. Dr. Tiwari, Vijay N. Tiwari from Samsung. Okay. We'll just make quick calls and invite them. The panel members are here. So we'll be starting with the panel discussion. The title of the panel discussion is Future of Human AI Collaboration. The panel will be moderated by Professor Shantanu Chaudhary. The panel members are Professor Partha Pratham Chakrabarti, Professor Aditya Nigam, Dr. Vijay N. Tiwari, and Ms. Petra. May I please welcome you all on the stage for the panel discussion.
Good afternoon. Let me welcome all of you to this panel discussion where we are supposed to talk and we shall discuss, and at some point of time we would like also the audience to react to, is about the future of robotics and human collaboration. In fact, that question, human and AI with robo, I'm just coming to that. I stated with robo and human collaboration. Why? I shall come to it in the sense that today, as we are accessing AI being accessed to through some devices. ChatGPT is not the thing which will actually determine, or ChatGPT-like softwares will not determine our access to AI. AI is becoming omnipresent, and if it is omnipresent, then it will become accessible through devices. So access to AI would be through robo. So when you look at AI and human being, AI with human being as a partner, we need to also look at robo as well as a partner, because robo is embodiment of AI in the sense of its usage and interface with human being. Now, if we look at this point, the questions which really comes to us and we need to really address is, where are we moving? The challenge is, will AI become a companion for us, for our daily life? If it becomes companion, in what footprint will it have? If you look at AI, it's transformative. That means it would change today's social environment, ecosystem, production methods, industry. It will impact economy. How it will happen in our lifetime and in your lifetime. I'm talking about your lifetime, maybe another, for many of you it would be 60 years, for many of us maybe here another 20, 25 years. So therefore your time span is huge. And the last part, I think, which is very important and critical for us to address, where will the ethics of human as a race, what will be the responsibility of human as a race, what will be the responsibility of human as species in the face of AI, and AI becoming omnipresent? I think we primarily decided to address these three questions with the audience and your input. And we have actually, if you see that, we have got one of our panelists, Petra, with the robo itself on the panel, which really shows that how AI and robo is getting into all parts of our life and where the future is moving. So with this, I think, let me start from that end itself with Petra, because she can talk about the robo to start with. And the question is that AI and human being, how it is getting closer and coming together, maybe as a companion. The question is, in future, will AI be a true companion of a human life? Petra, please.
Thank you very much.
That's
Oh, okay. I have it. I got it. Can you hear me? Yeah, thank you. Can you hear me? Yes. Perfect. Thank you, and thank you for invitation. I'm very happy to contribute to this panel. Indeed, so I would like to present you now, which is a humanoid robot, which is a companion and assistant robot. And I think that today, well, everyone speaks about AI, and indeed, we are at a point of convergence. AI has made significant progress lately, and robotics did as well. And today, these two technologies meet each other, and I think it's very important because AI itself, it is not enough for the AI to have an impact in the real physical world. The robots can be seen as the, the hardware of choice in order to have the impact in the physical world. And so we do not do robots for production or for the constructions work, but we do robots for people. Robots that are used today mainly for research, education, in healthcare as well. We can speak also about the special education for autistic children, children having cognitive difficulties, for example. And now can be of a great help because in these applications, it doesn't judge. It is always like kind. And there are many people, we are working with the end users, professors, and we know their real needs and we try to answer it in the best way we manage to meet their needs.
I think, so with reference to these, as continuing further, I may now go to Vijay. Vinay. Vijay. I think I had noted Vijay, I think I'm correct. So Vijay, because he comes from a consumer electronics background, and so if you see robo becomes a companion, then AI through other consumer electronics can also become a close neighbor of ours. Will footprint of those, our electronics, daily use electronics, will the footprint become closer to robo to become more AI enabled?
Yes. So, first of all, thank you for inviting me to this panel. Now it is okay? Yeah. So, first of all, thank you for inviting me in this panel. As Hello, yeah. As Professor Santanu mentioned, that human AI collaboration is going step by step. So when it comes to interaction of AI with humans, robot play a very important role, just like our mobile device. So to define human actions or human AI collaborations, 4 pillars are very, very important. So first pillar is that we need to understand the intent of the human. The AI has to understand the intent of the human. Second aspect is the contextual understanding, whether it is social context or whether it is the physical context. And third aspect is obviously the physical AI, which is the first stage of human-robot interactions. Once we combine all 4 paradigms of AI, I think that will be the optimal collaboration of human and AI. Because if there is only one-way traffic, it becomes very asymmetric and sometimes dangerous as well. So this, in my opinion, should be the direction. So obviously we are starting from factory robots, then moving on to social robot, and then becoming a true companion of a human with all the cognitive abilities just like a human brain. So that is the ultimate goal. Thank you.
Adit, am I audible? Yeah. So say, for example, if it becomes a companion, there is also a question of privacy. So when you interact with AI, the question of your privacy, your private data, and we are not looking at a mass level, but looking at an individual level. So what do you think that the challenge that comes in when AI becomes your companion in terms of your privacy, your security, your individuality?
Yes, thank you very much, sir. So when it comes about these new challenges, so whenever I say that I need a companion, we started to make a new friend. So we started to trust onto him. And trust is going to be coming via mutual understanding. So now, as a professor who used to teach deep learning, I need to look for all the companions which are being there, and I'm using maybe Claude, maybe GenSpark, maybe ChatGPT, and every client. And they know everything about me. But while interacting, what I find that I don't know anything about them. The other thing is that as soon as I started to interact with them, whenever I get some time, I try to see that if I interact with them in a particular way, what they react. And what we have felt is that they very specific way, they just move from their personal discussion and say that let's talk about deep learning or certain things in your courses. So as soon as sir has very clearly said, what I feel is that the area into which we need to think about more and work, the challenges are like how to understand the interpretability gap which is being there. So whenever I communicate, I should be aware of that what this guy is also thinking. When I interact to some person in person, we used to have some facial expressions and all. In the same way, if I say that when I use Claude, whenever I interact, I just touch the tabs are being there and it's actually an interpretable engine. So it actually tries to tell that what this guy is interested and what this guy is doing, but very less information that we used to get. So because of this privacy, if I say that, our personal data, we are honestly giving it, but as soon as they started to, interact with us, if we are not very sure, at some point of time, our relationship started to become very scary. But the other good thing about is that because of these hallucinations effects which are being there, it's actually my personal experience that I have seen that I used to talk very personal things. Most of the personal things are our research papers which are not being yet published. And if I talk to this guy and say that please don't tell it to anyone, this is my unpublished work, and he will say that okay, that's the thing. But with this hallucination and new direction, several times they actually come up with several random direction, and I used to say them as useful way of hallucinations. And I was trying to solve a problem, I gave it to this system, and he said that instead of doing that, why don't you do these 2, 3, 4 things? And certain useful hallucinations I found, and we started to work, and it's actually saturated. So the idea was actually, I have got it from this machine. So that was the pros of, all these things are going to be grow and grow. But what I felt is that at this particular time, we all are so much fascinated about using AI as a companion. Still we are not in a position to very clearly verify as well as understand the vulnerabilities. So that's my current view, sir.
Okay, so I think this is a very basic question, that how do we measure or assess that AI is trustworthy or not? And can there be a measurable way to define that? I think this is a question I'm posing to BBC.
Yeah, thank you, Professor Behra, for inviting me and everybody here for this panel. Before I address that question, I want to share with you a perspective of the future. The AI that we are just discussing up to here is, in a sense, assistive AI, and my relationship with AI is a subject-object. It is another entity. It is not me. It is another entity. Let us understand it a little differently. My hand and AI, whether they are same or not, that is number one. So now AI is assistive, and that is where we need to measure how good its recommendations are, its decisions are, etc. The next step, when AI starts getting embedded in us, from wearing glasses which are AI enabled, to having neural implants, to having your heart replaced, to having your kidney replaced by an AI enabled entity, we are going to have AI which is part of us and which is involuntarily taking decisions for us. So that is the next step of AI, where AI slowly starts understanding the decision-making process, and over a period of time, it is just a toddler now, starts understanding and behaving with me. The third step that will happen is when AI will stop becoming electronics. All information will become biological, and yet it will be AI, which means that all your biology and everything else will start becoming part of AI. Today we think of AI as electronic software, and as we were just discussing, as Professor Shantanu mentioned, that today we see it as a robot, but think of it as a robot embedded in us, completely embedded, taking involuntary decisions like peristalsis happens for us. Beyond that is the more philosophical question, before I come to this measurement concept. Beyond that is the more deeper philosophical question. The deepest philosophical question is that, am I my eye or is I my sensor? If I change my eye to an electron microscope, will we see each other this way? We will not. Therefore, AI, whether our human body is also a form of quote-unquote evolutionary biological AI, and when it completely overpowers ourselves, then what will be recognized as ourselves is the fundamental philosophical question. And that is the general trend that we have to do. So as we see it across these points, at each of these points, it is the human being which has now faced an entity which it wanted to do its bulwark, hard work, and everything else, and it has started doing the work which we value most: creativity, thinking, solving problems, etc., etc. So at this point in time, if we are unable to understand and measure what AI is doing, and the way AI is constructed, its architecture is such that the measurement problem at its crispness is undecidable. You cannot really measure. So we have to come up with mechanisms of understanding AI in such a way that when AI evolves to this stage, so today's measurements are all veering around from accuracy to safety to responsibility, but we still do not know exactly why AI is saying what it is saying. The only comparison that we have about the uncertainty of AI is our wives. Nobody understands your wife, right? So that way, so my feeling is that the whole of AI-human collaboration hinges on the way we are able to evaluate the performance of AI. Because when it starts getting internalized and we fail to see the subject-object relationship, whether AI is another entity or AI is me, that is when we will end up with the most difficult questions of measurement of AI, because this separation of self with the AI will become the most interesting and intricate question. And that is when human beings have to go back and work with biology to start measuring and separating AI from yourself. So today's measurement of AI and tomorrow's measurement of AI, first to recognize that this is AI and this is not me. That is going to be the most critical thing. I want to start with this and then we can evolve to a future question.
I think, okay, next question to you is that let's change the track a bit and then get into the space where actually AI can make your entertainment better. AI as a companion, when you want to relax as a human being, when you're relaxing, relaxation actually brings in a different experience. How can that experience be better and personalized with AI as a companion?
Thank you for that question. So the current entertainment experience is highly localized and confined to sort of spaces with speakers and screens and so on. But now imagine you have your own mobile entertainment center that can render spatial audio, that can project anywhere you are. It can project a large high-def screen. It can even do physical dances or entertainment moves for you. It can so all these different possibilities which do not exist at the moment will start to exist, and robotics will offer an avenue for entertainment that will allow for new forms of user-generated content, that will allow for new form on social media, on new ways of creating creating art, creating sort of music, creating videos with mobile cameras, with multiple sensors. So, I mean, the possibilities are immense, and it's hard to even predict at this point how things are going to proliferate, just as it was very hard to predict how social media would proliferate and how content on social media would proliferate. So as AI evolves and into the physical realm, you can expect to see advancements in entertainment, in the creative process itself. So filmmakers today spend enormous amounts of money doing things like hiring makeup artists to age. If you've seen Benjamin Button, you've seen Brad Pitt being aged and de-aged in that movie, right? And that took an enormous amount of money and resources to make that happen. Imagine now you can just do that with Gen AI. So it democratizes the process, the creative process, just as social media democratized content creation. This is going to democratize, the next step in the revolution is to be able to democratize the entire creative process, so that anyone can be a Universal Studios, or anyone can be, a great music studio as well. Thank you.
Thank you. I think we have understood that if you look at it, that our panelists, the way they have described AI as a human companion, and that companion being modeled through a robo and robo undergoing transformation, this is possibly the direction in which future is moving. And at the same time, the indications have been put across that AI can go from silicon to biology. So therefore, then also the perspectives would be completely different. Before going that far, possibly we need to look at things in a slightly different way. Because the discussion so far has been with human being with AI as an individual. So human being, if you look at it, it's not just individual, but it is also a collective being. There is society, there is a nation, there is universe, and humanity as a species. Now, if you look at from that context, there are lots of challenges today in terms of, and broadly those challenges are related to sustainability, and sustainability is something very fundamental for human existence. Now, my next question is, therefore, will AI have a role, and AI as a new technology, what role it can play and what role you can make it play, so that it ensures sustainability of human race before even going any further into its other implications. Think AI as a technology. And if AI is a technology, robotics as a technology, can this be used and how this be used as a sustainability engine which would enhance the quality of our life? I think with this question, let me start from this side. I think then we can move in that other direction.
Sure, thank you. So we've already seen examples of sustainable applications of robotics in this in this conference, where we've seen a robot that is able to dive to depths that would be impossible for humans to dive to, and actually inspect underwater infrastructure for oil companies and so forth. And just imagine the value of these things, being able to prevent catastrophic oil spills, or to be able to detect marine health, coral reefs, and so on. So this is an example of robots doing things that were very, very hard for humans to do because of the hazardous nature of the environment that one needs to operate in. And there are a number of examples, and waste management is another great application area where we have a lot of landfills in India, a lot of electronic waste, which has actually a great amount of value within it, with rare earth, metal, minerals, etc., that can be mined using robotic help. Very hard to do for humans, but with an appropriate supply chain, robotics can really help there. So that's one. Another area would be maintenance of renewable energy sources, such as windmills and solar farms, which require constant cleaning and constant sort of upgradation to make sure that energy production is optimal. So these are just some examples. I'm sure the other members would have their own take on this.
So PPC, let me just put the question slightly in a different way. See, today it is claimed that AI itself is most unsustainable technology. Okay? And if it is so, and as you have looked at that, looking at biology as an alternative, so what is the pathway to that? Because we want AI, but we also want sustainable AI.
See, the power of all technology has moved. Every time we have seen civilizational change, we have seen one major change, one major new aspect which has brought civilizational change. That is energy. After we got fire, if you look at anthropological studies, you will see human brain grew, everything else happened. After fire, when we discovered electricity, there was enormous change. Till then, there was huge amount of labor in doing things before even the steam engine came. Then electricity came. Then nuclear power came. AI has sorted out three challenges. It has made computation free. On our phones, we have computation that is almost free at whatever pace we want. It has made storage free. We have so much of storage. It has made communication free. We are talking about things on people on video. The only crux and problem we have is energy. It is because of this energy that AI has become unsustainable. So unless humanity either moves on AI into a biological realm, it is not going to continue in the electronics realm with this unsustainable nature of its kind. Or human beings have to find and discover another source of energy. Only when we discover another source of energy which can be tapped and put into place, only then we will have to do this. Otherwise, the power of computing that we need, everybody is making a nuclear power plant for running their AI business. And therefore, AI is truly, truly unsustainable. It has consumed 30, 40, 60% of the total energy it is going to consume. So I believe that we should move into finding newer ways of tapping. See, AI is one fundamental question AI tries to answer, other than everything else. How intelligent can matter be made? How can we extract intelligence from matter? So using, human inputs. So the next realm is biology, and unless we are able to integrate it with biology, we will neither be able to create sustainable sources of energy, nor will we be able to create sustainable sources of new technology. For example, today, our human brain has got about 10 billion or 100 billion connections, 100 billion neurons and 100 trillion connections. Today, all the computers in the world together have not reached 1/4 of it, which means that we are not in the right model. And that model is coming up slowly, slowly. People are creating artificial life, intelligent life elements, and green shoots on that are there. And I believe AI will have to move in that direction.
Yeah, Aditya, let me just pose the question slightly differently. Because, PPC has talked about the solution in the biology space. But today, if you see, there are also increasing interest in small models, not large models. So, what is your opinion about that? And if the future of AI technology, is it through small models and not really large models? What is your opinion?
Yeah, so as initially is being posed as a sustainability, so I just wanted to place one point that I can also see this sustainability as a AI companion even for the doctors, because there are, as very clearly said by sir, that the budgeting of energy has to be done, and if we wanted to do that budgeting, we need to think about energy and its prioritization of the energy. So one can see there are so many areas into which we can apply AI, but what we usually observe is that most of the time where we can sell, we can have a product which can come up with a revenue like maybe creativity or movie making or songs and all. So we used to prioritize those areas and apply AI over there. What I feel is that medical is one area, because such a big population and with very handful of experts, we need to come up with more AI agents which can help our doctors to come up with the situations which are going to be there. Whole world is essentially at war. Things are happening at a very rapid pace. So prioritization of area is one thing that I was thinking. And now coming on to your SLM, yes, the point that what I understood is that if you can train a very big model, so when I started to teach this deep learning, I usually say that, okay, now it become a democratization because of now everyone can use AI. After some time, what I felt is specifically now, that we can't train big models. Everything is now with these big companies, they have thousands of GPUs, and on that they have huge amount of data. And because of which, we started to say that, okay, we can't train big models. So what I felt is that several tasks which are really do not require that high level of expertise, they can actually be filtered out. They can actually be applied using, solved using SLM models. But in the case of even those SLM models, we have seen that now new small inferential devices are coming, which will say that you train your model. So training is one-time process, but if you wanted to run it on some systems where it has to take decision on real times. So what I feel is that these new upcoming models, which are inferential models, which are very less power consuming, by the way, far lesser than the bigger models, I feel that those models are going to be much more interesting, and SLMs can actually be utilized for several tasks for which we do not need that much amount of, bigger models. So that's the future. I will say that huge amount of companies are working on to that.
In fact, that could be the intermediate solution before we go biological completely. I think I'm going to Vijay with the question that what is your opinion about the change in technology, that semiconductor technology, architecture, how that and even AI can be used for designing those? How can these be addressed more to address sustainability question for future?
Yes, so absolutely. So I feel that this question of sustainability is coming because we are seeing AI as a replacement tool. But I think we have to move towards augmentation, which we are currently doing to some extent. And finally, to creativity to such an extent, or to create such an impact which is far, far more than the compute or the energy which is required by these AI models or the AI techniques. So that is the future. I think we have to go towards that. And as one of the important use case, you said that if we can design architecture or a chipset itself using AI, which is having a 100x impact in the industry, that itself will be very, very sustainable. So one of the example which I will give for sustainability of AI is in the medical field, where robotic surgery has become a norm. So if you want to perform a complex surgery in a very constrained environment like brain, or blood vessel cutting, or aneurysm surgery, and all those complicated surgeries, human will take maybe 10x more time, and with lesser precision it will execute that task. But currently now it is so seamless that robotic surgery has taken that particular element of medical field, and it is no longer feeling like, we don't feel that it is a extra task which we have given to the robot. So it has become very, very sustainable, and in coming future, I think it will become even more seamless and natural. So this is the way to think. Thank you.
Okay, maybe with reference to robotics, what is your opinion in terms of sustainability? Because the robotics also will bring in the challenge in terms of waste materials, because the robots have a limited lifespan, and with that it will add to the wastage. So we don't really have a concept of reusable robo. Okay? So can you think of a sustainable model of robotics becoming an integral part of human life?
Yeah, I think that, well, sustainability is absolutely crucial for the robot. Indeed, there are many challenges that we make while making these. The energy is one, and indeed using ChatGPT or other generative AI is very consuming. So we look with much hope to other alternative models and algorithms that are being developed today. And also what is the recirculation, because indeed you have many motors, you have batteries, you have the plastic. And I think it's very important we really try to take those into account while we're designing these robots. And there's the eco-conception, which is very important. And I must say today, unfortunately, we do not have all the answers and all the good solutions. So it's really a challenge.
Just maybe to start also the discussion, again from that side, is that today if you see that human body, the way the muscles work, is energy-wise very efficient. Much more efficient than the way that robotic arms and the joints and the way they are controlled and the energy consumption happens for controlling them. So is there a biology can, again, just like biology can be a motivation for the AI problem solving, but biology can also be motivation for making the AI companion, where robots are really making AI delivery. So biology can be the motivation for designing robots. And that can be also sustainable in various ways. Any comment on that?
I would like to say that actually, yeah, we had really a bio-inspired approach. We worked very much interdisciplinary. We worked with biologists, with carpenters, designers, people from animation, with actors, and so on and so on, to conceive the robot. Actually, the original design comes from two very talented students from a design school from Paris. Then we took it and we developed it and worked on it really a lot. Yeah, we studied really a lot the biology, anatomy, and many other disciplines. And this is also the result of bio-inspired approach that we had.
Okay, maybe next we can come to Vijay. Yeah. So if we look into it, that today there are very open space in terms of where AI can take us. Now today so far, we have looked into problems and questions which are concerning us right now. But if you expand the time horizon to another 10 years down the line, and if this panel discussion is say happening at IIT Mandi 10 years down the line, what would be possibly the most critical issue that you'd like to discuss? And in fact, this will be a question that we pose to all the panelists now.
Yes. So I personally feel that this processing of multimodal information in real time is a major challenge at this point of time. So possibly AI or a robot, it cannot match the human capabilities, because the way we process the senses or the sensory information in real time and do multitasking, that is very, very difficult for a robot to develop those kind of cognitive abilities or multitasking abilities in real time. So 10 years down the line, I think this is the area like multimodal AI or the multimodal context understanding, whether it is social context, whether it is environmental context, whether it is a physical context, that is absolutely the key area. And obviously many researchers are working in these areas, and that is the ultimate goal of human AI true collaboration, because collaboration can happen only if it is complementary in nature. If we see that it is skewed towards a certain direction, then it is not a true collaboration in my opinion. So I think multimodal context understanding is the holy grail, and maybe that is where we have to solve and go towards that. Thank you.
Comment on this issue.
Okay, so so very recently I've gone to this AI summit, and there I met Yashua Benjio. I got a good time to have a discussion, and I was very curious that what is going to be, the new challenges onto which these pioneers and legends are working on. And he was very clearly said, with a very big gentry behind him, talking about AI and its applications. What he was saying is that the direction which is going to be very important right now is the safe AI. You need to build a system that you know what this system is actually doing. So if you really do not know too much about the system, then you are creating, you may end up creating an hazard. And he was very clear without any if and buts. I was sitting with three, four other faculty members. So what I felt is that the vulnerabilities and the security aspects are must have to take, by the way, the center stage. World is having war, and I'm 100% sure that in the upcoming time, these systems are going to be utilized to utilize in this war. So I feel that security, the indigenous systems, the way we can manage it in such a way so that they cannot be taken by some other, adversity is one thing into which one think about. The other thing may or may not be directly, with respect to AI, but what I felt which is very important is that if you project me into that multi-dimensional, multi-model space into which you make another version of Aditya Nigam, which is right now a human, but with augmented so many, skills, now I can do huge amount of work in a given amount of time, and I started to behave like a, better or, superhuman. What I felt is that this started to give less and less time for myself, and slightly what I felt is that I can see so many others who are under the pressure of working too much in this area, consuming our energy so much, utilizing all these AI agents. We can work very fast, we can do too much amount of work, but then mental issues are also going to be there, which I felt is at some point of time, and we can see within our students as well, as that using all these multidimensional aspects, it's just a curse of dimensionality, because of which we started to end up utilizing too much ourselves, got consumed into the work, addicted to the work, and maybe it's going to talk about our mental health. This is my personal thing, with what I have seen, not only to me as well as several other colleagues who are into this AI and it's the research. It is fascinating, it's addictive as well, and because of which we felt is that we are getting more and more into this. So that's my.
So 10 years down the line, we shall talk more about mental health due to AI?
That's what I feel.
Okay, PPC.
So there are two parts which I would like to address. The first part is making AI efficient, like he talked about muscles and things like that. So I think some advancements in the neuromorphic AI domain has come up, where using spiking neural networks and things like that, we are really able to get 100x efficiency in terms of activities. So I think that neuromorphic, see, anytime human being thinks that the human being is the epitome of all intelligence, and a human being has now created something which is far more intelligent than human beings. But still, in order to improve AI, I think one's direction is neuromorphic computing. 10 years down the line. 10 years down the line, the AI will answer JEE questions better than anybody human being. AI will be a better doctor than any human being. AI will have more knowledge on any subject than any human being. The question is, what will we teach students? Will IIT Mandi exist? Why will it exist? What is the purpose? Today, AI is close to a PhD student. In 3 years, it will be better than a postdoc student. Today, Terence Tao and Donald Knuth are using AI to solve problems they could not solve themselves. So, in future, why will we need all this hall audience? For what? Why will we need educational institutions like we have now?
So you're taking my last question.
So everything will completely change. So unless we look and relook at education, relook at a mechanism by which people will gain knowledge and use knowledge and ride this dangerous tiger, as everybody is talking about, which if you do not ride will eat you. We are very clear now. If you do not ride this tiger called AI, then this tiger will eat you. So how are we going to bring about a mechanism by which we are able to use AI for education? That is number one. Knowledge gathering. How are we going to find out better capacity of the human being? These are the questions that we need to answer now, because otherwise somebody will answer it in the wrong way in 10 years.
Yeah.
So I agree with all of the panelists in some sense or the other. Yes, multimodal AI and synchronization, etc., are one of the biggest challenges. A lot of these challenges may manifest, I think the application where they manifest the most are humanoid robotics, which people, I mean, it's one of those things that people have been projecting will be coming every 10 years, but it hasn't seemed to have arrived yet in any sort of practical form. That will probably change in 10 years. You will have humanoid robots running around doing things in the physical world that they're not doing right now. Coming to the point of connection with biology, I mean, what happens when humans start implanting devices on their heads and become much smarter than they are now? It was all science fiction until people started actually doing it. And what if it actually becomes a reality? Will there be pressure on everyone here to compete? And everyone will go around starting implanting, chips in their heads. Where does society go in this sort of rat-raced environment? And the other aspect of safety is, as we outsource more and more of the decision-making to AI, it's already happening, they will cross a threshold from which it will be very difficult to retrace our steps. There's a famous professor in Stanford by the name of Christopher Potts. He has made a very sort of dire prediction about AI, saying that within the next 3 to 5 years, there's going to be a major catastrophic event, global event, caused by AI. And it does seem entirely plausible given the areas that AI is being applied to in defense, in lethal autonomous weapon systems, other areas. So those would be my sort of top concerns 10 years from now. Yeah.
Oh, so this brings us possibly to the last topic to be discussed, is a philosophical question in terms of how do we hedge AI? Why? Because if you look into it, when we are interacting with AI and AI is impacting our life in various ways, and AI is also throwing possibilities which are not only positive but also negative. So therefore, if we look into AI as a technology, just like we had looked at one point of time, nuclear technology as a technology which requires variety of policy level initiatives in terms of hedging, is it that today AI requires that kind of an hedging for humanity to progress? Because things, if you look at it, there is a humongous potential of human being to actually come up with things which are actually emulating itself. But maybe if you go back to the Gödel's argument that human being being human being cannot really finally solve the problem of intelligence because he's sitting inside that. So there is an unsolvable problem. There are questions of unsolvability which really comes up. But on the other side of the story is, how do we handle this challenge? Because moving into 10 years down the line, because today we are talking about future, 10 years down the line, how will we hedge AI, shape AI, so that 10 years down the line, we shall say that some of the questions that we're raising today are at least tackled partially? I think your solution. I think this should be the last round where I think we should come up with something which has a meaningful direction.
I think if we manage to crack this problem of safe AI, which seems uncrackable at this point. I mean, people have been at this from mechanistic interpretability angles. They've been trying to dissect these models from every angle possible, but the scale and the complexity of the problem, especially when you're talking about complicated AI systems, just seems so intractable right now, despite all of Yoshua Bengio's efforts. I would say if we manage to crack that one problem, we've turned a corner.
Throughout existence, humanity, whenever it faced situations where things could go out of hand, people developed regulation. Regulation is developed not because it was absolutely needed then, but because human beings could not handle anything at that time. You cannot handle certain things with your own capacity and strength, therefore you regulate it. Regulation brings in two aspects. One aspect is that it tries to ensure that proliferation of unregulated things do not go into society. But with regulation, innovation is also stymied. So we really have to figure out a more scientific way, a more human way of progressing with AI. And that, I think, is essential to bring about an AI-enabled world order. Otherwise, human beings do not have the capability of controlling AI at the moment.
I think, Aditya, just following up this question, there's also a kind of a philosophical angle to it. That what is the philosophy with which we should look at technologies? Because that aspect is extremely important in terms of when we judge technology. I think it's very, very important for many of the younger people who are excited about technology, that how do you contextualize technology with respect to the human philosophy and human civilization? With reference to that, what are your comments?
So, as very clearly said that philosophically, yes, there are, systems which already, being written in several places, that there are certain oracles that can help you, and they can help you in the best possible way. My security concerns or my vulnerabilities probably divert into in this way that my father doesn't know AI, and the whole world actually started to buzz about it, and he'll say that, okay, AI can't do this and that, but I said that, okay, in 5 years or 8 years it's going to happen, and it started to happen. He every time used to say that it can't write a joke, it can actually not going to make an image or maybe poetry or whatever. Everything is happening right now. So my hedge or the safeguard about that probably is that if you don't know AI, probably don't use it. So my father doesn't have a SBI, he has an SBI account, but he don't use, online SBI or whatever. So what I felt is that right now the intermediate solution, because the things are so rapidly changing, everyone wanted to use different type of chatbots and all, and showing all the possible data, images and everything to these guys. The simple safeguard is that if you don't know what is happening, it is better don't become a complete superhuman and show whatever that you have to these systems, because vulnerabilities are going to be there. And maybe in upcoming time, very clearly, in the initial discussion, Chakrabarti sir has said that this new Gen Z which is going to come, or those who just have, started to see this stuff, they are in a better condition to digest what is coming to them naturally. And maybe those who are not very good into that may avoid it unless it becomes very important or, crucial for them.
Your opinion, as is being pointed out, as a native AI, I think, let me ask Vijay, that if look at the native AI generation which will come up, with reference to that, what are your comments?
Yeah, so I think sensitizing, because most of these ethical problems can happen with any given technology, is either lack of full knowledge to that technology, or deliberately misusing that technology. So I'm pretty sure that the coming generation, who will be native AI generation, they will know that what is good technology and what is bad technology, because the technology can be used for both the purposes. So unless and until we frame some country-specific guidelines and policies related to AI, there will always be a possibility of getting it misused. But that is we have to take it and move forward, because the moment we try to constrain any given technology, I think the ROI may not be to the fullest of our expectations. So I think policies have to be framed, and government has to step in and decide that what are the correct priorities and what are the correct policies in that regard. But the other aspect is to sensitize the whole population about the pros and cons of AI. If that we are able to do successfully, I think the damage will be minimal.
Okay, so this question with reference to the robotics, how do you deal with? See, the question which is coming up is that if we look at robo, and robo becoming part of our life for the next generation of population, then how people would react to that? Would that have a negative impact or would have a positive impact? If I'm growing up with robo as my companion also, it's not that I'm not growing up with human companion, I'm growing up with human companion, but also with robo as a companion, then what will be the impact?
Yeah, I think that for the impact to be positive, there are several conditions to be respected. The robotic companion must be trustworthy. I really need, if I have children, I have a robot at home, I really need to be 100% or 200% sure that everything, they are safe. Safety, by safety I mean the physical safety, of course, and the robots, so that they can be hurt by it. By safety I mean also, the cybersecurity. I do not want the robot to be hacked by any people from external to go to see how the house looks like. So safety, this is really like number one. Trustworthy, I need to understand, I need to know what the robot is capable of. I think that's what was mentioned, the sensibilization also is very important, because even today, it's been a long time that we are talking about robotics, about AI, but there are still many people who do not really know what it is, what it can do, what it cannot do. And I think that another condition is design, really design of the robot, because it's important to make it that way that it enables the interaction. Because if I have the best robot in the world at home and I'm afraid of it, I will not go forward, I will not interact. And so I will not get the benefits of it. So really the acceptability is it's an important aspect. For the robot to be acceptable, you need to treat ethical questions, which today still remain questions. I think it's also the values. This is absolutely fundamental. Then the values, in Europe, we do not maybe the same as US or elsewhere in the world. So there's a lot of work still to be done on it. And in that sense, there's the standardization and regulation which comes into the account. And here I think that, we in Europe, we are very good at regulation, but for AI and robotics, sometimes the regulation is just based on the assumptions, because today we didn't get yet enough experience, enough real world experience on which we can base to make it really adapted to the real needs. But maybe, values, trustworthiness.
Yeah, I think trustworthiness is a key point that you have stated. And in fact, to coming to the conclusion of this panel, I think what came up very clearly is that AI has huge possibilities. AI can impact civilization. AI can impact humanity as a whole in a positive way as well as negative way. I think that's possibly the characteristics of any technology. The one point we have to look at it, why robotics and AI have to be looked at together, because embodiedness, when you have multimodal sensing, that also is an optimization in terms of sensing and interpretation. And this is a fundamental biological property. And the moment we start looking at things properly from a biological point of view, from a new perspective altogether, there would be different layers of AI and robotics which will get unearthed. And today, this question is very clear that human being has actually come through over the years various challenges. AI has both challenge and opportunity. So obviously, it's a question about the creativity, the whole creativity and intelligence, and your approach to life, approach to society, approach to your fellow being, which would dictate and guide how you use AI. I think that's the key point. And until unless we can, and if we can keep that in mind, AI as a technology, as a companion, the future will be positive for human race as a whole, and that's something is very, very important. Thank you. Okay, so I just missed that point. I think, any questions from audience? Yeah, please. I'm sorry, I just missed that.
My question to Professor Chakravarti, PPC. You made a very, in the first round, you made a very philosophically pertinent thing that will we be able to distinguish that subject and object? That's AI has become me or AI is outside agent. Now, in that context, I just want to let you know that the Indian philosophical tradition defines intelligence is the ability to discriminate between body, mind, and consciousness. Ultimately, one sees the consciousness ever expanding and ever embracing an eternal truth. For example, here, AI is giving us all intelligence very simply, and we are thinking that is intelligence. But we know that as an individual, when I solve a problem using my own intelligence, not outside intelligence, that gives me satisfaction. That gives me to look inward and see where is my strength. Where is my potential creativity to that I can resolve? But here AI is bringing all information, not intelligence, at your doorstep. So you become cognitively impaired. What is your opinion on this?
Yeah. So this is the fundamental question. The fundamental question is that when AI starts thinking for you, now you will not, AI will ensure you have enough energy so you don't need to eat. So because you don't need to eat, you don't need to run for eating, you don't need to work. So you will really not need, 20, 30 years from now, AI will provide you all the energy that you need. AI will do all your thinking. And all the things which gave us this happiness by trying to solve a problem, it will go away. So there are only two options left. Either we become AI, that means we become subservient to AI. Like me, I'm subservient to my wife. Whatever she says, I do. So so either you will lose your personality, or you will find out who you really are. Because nothing of your thinking, eating, walking is you. So there are these two possibilities. Either you will become subservient and an automaton, or you will know that infinite capability which you are not caged in this body. Both are possible. Now it will decide whether the human race knows how to. Today human race knows it through certain pathways which are very esoteric. But can we take it through the common scientific pathway? Like AI is democratizing this. Can we bring that concept of knowing who you are through the path of AI is going to be the actual question.
In fact, that's exactly the philosophy I was trying to hint at. There has to be the philosophy with which you should look at AI and interpret AI and decide your actions with AI. And that philosophy is built with embodiedness. Because embodiedness is something very, very important. So you realize you are. And with reference to you are, I think the story should get its beginning. And which actually is aligned with what you're talking about even with Indian philosophy.
And that is exactly what we should do instead of trying to write bigger LLMs. We in India who have this innate nature of understanding this by intuition, by biology, by culture, this is where we must focus our thought processes to bring out anything new. Otherwise, we will follow everybody else and just tweak a few results and write a few papers and die.
Hi, sir. My name is Amit. Thank you so much for this great discussion and the opportunity we had listening all you regarding this particular topic. So we have been working with the compliance AI as infrastructure layer for Indian market, enabling the different compliance and regulatory bodies with a small language model. So we have seen the different language LLM model coming from the Western, say, Silicon Valley. Primarily, those models are probabilistic in nature, and that's where the energy, the consumptions are actually very high. And that's where we try, as Indian market, different companies are also working the different LLM, SLMs, who are actually copying the Western thing that they already have been doing. So my question to all of you that how you see as Indian player to be pioneer in this particular space to build something which is more energy efficient, like what we are trying to do, and what are the different things that we can use while actually creating this particular model, which can basically helps all the different Indian consumers, which are different those of of Western consumers.
Aditya?
So as you said that the efficient AI is going to be a very big topic, and anyways it's the big topic, and everyone wanted to have a bigger and bigger GPUs for training. But the point is that we have seen not only in this era as well as maybe the previous era in which mobiles were there. Initially they were small, then they become big, and then they again become small. I have seen this in deep learning that initially they started with a model and they keep on making bigger and bigger and bigger. And then at some point of time when they virtually hit their GPU limits, silicon GPU limits, they said that now we'll have to compress, and they started to compress it down. And once they started to compress, later GPU power again came, and then they again got a giant which can eat any type of data transformers. They started to take bigger giants, bigger training models, and then they have a supervised learning. What I wanted to say is that currently what I see is this whole research is being driven by specific demands which are being there in the company. Nobody is very seriously thinking that how to make everything so energy efficient. They just right now wanted to get most out of this wave of AI. That's a good time for us to now understand, and as I have said, that prioritization is something that one should have to do. Just think about that, you purchase a new LLM, only few credits are being given. And now you will have to prioritize that what is the thing that you want to give to your LLM. The same thing, if we say that the energy consumption, if everyone started to give certain few credit limits that, okay, this much amount of energy units that you can consume, I'm sure that several other areas into which AI is going to be applied, it actually being stopped, and certain few areas into which it can actually go. So as you have said that certain inferential models are going to be there, certain new SLMs are going to be there, efficiency, as sir has said, the biology, silicon GPU, if you wanted to move towards maybe a biological GPUs or all, it's going to happen, but right now it's not very practical. The other sense that we have seen is that the quantum thing is also going to come. I feel that it's also going to put more thrust into that.
Thank you so much.
So just one comment is that today, as you pointed out, there are also lots of causality-based models are emerging, which are not just associative models, which consumes lots of energy because of the combinatorial, these challenges. But causal models are also emerging. So newer pathways are coming up, and I think we have to be conscious about those pathways and sensitive about those pathways.
Thank you so much.
So I think, I've been trying to ask a question. Professor PPC, you mentioned about the reference of biology was pretty new, which you made a reference, and it was reinforced by Professor Shantanu Chakrabarty about silicon to cell biology.
Shantanu Chaudhuri, not Chakrabarty.
So sorry for that. So my point is, everyone talks about neural networks. This question is to Professor Aditya Nigam, but no one is talking about genetic programming, which is the evolution-based algorithm. And when you're referring to biology, silicon to cell biology and all those things, why are we not having a hybrid system? Will that hybrid system come up? Will be a combination of neural systems and genetic programming? Why is no one talking about that?
So I briefly say, then sir has nodded his head, probably he may add it to more. My only point is that what I have seen is that a very clear way of involvement of certain demands that need to be somehow being solved, and I have seen that systems growing and then being shrinking up with distillation models and all, and then self-supervision and all. What I felt is that there are other ways in which computation can actually be done, but everyone wanted to ride on the wave, as sir has said that if you don't ride, then it's going to kill you, that everyone wanted to ride on the wave. Right now what I feel is that if you diverted yourself slightly from the real action, then it take not only the courage and money as well, but maybe you need to be much more fundamental. I see that huge amount of fundamental research or very specific orthogonal areas into which one can think of is slightly getting down, and most of the everyone is researcher is looking for that 1 or 2% gain, the way sir is saying. But genetic algorithm and other things we have read at some point of time in Lens, and we have seen that the hybrid systems can actually work. But sir can add on to that.
So two approaches, Professor, is coming up. The first approach is that because electronics has moved at such a pace, and ab initio biology, in the sense of artificially made brain, lung, heart, these cells are only progressing, that integration will take more time to happen. But now the other integration that is going to happen, if you have just seen last week, I think they will get Nobel Prize, is that they have put a small strip on the brain, just strip inside the brain, in such a small strip that we cannot even see it properly. It will start getting signals of the brain that is completely new. So these signals, which we are currently getting by very complex means, EEG, ECG, fMRI and all that, direct signals will come. And these direct signals will be much deeper, because the neural networks that we have made are cartoons of the human brain. They are like, if actual human brain is something, they are like Tom and Jerry of the human brain. So once that comes in, that is going to be our first step in 5 years. A large number of human beings will be connected onto the computing system. The human brains will generate new signals, new ideas. Our idea of intuition. Suddenly we get a spike of intelligence. Suddenly we do a connection. We do it so fast, and they take a lot of compute, but they can do certain computes better than us. So this combination in 4 or 5 years is going to come up. The first step will be about human beings being impregnated with this, and that being used to connect and run. While that is going on, in the lab, cells, brain, intelligent biology will start getting produced. And that will take much more time. But this will happen.
But just to add to one thing that what PPC has said, in fact, there is a theory of evolutionary intelligence. So intelligence has also evolved. So the question is not that everything, so therefore there is also a learning. Genetic algorithm is one class, but there are also people are talking about learning, that how the brain has evolved, and based on that, can there be new learning algorithms where the networks dynamically changes. So there are lots of interesting things that are happening. What we call, you have to look for weak signals. We are talking about on the basis of the major dominant signals. But in the horizon, if you search for the weak signals, those weak signals can be actually source of innovative changes and innovations to address many of the problems.
I'll just give you one example of a weak signal. We take our ECG, and when we take our ECG or EEG, then we filter it out, and then we do our signal processing. Now it has been found that if you don't filter, as he's saying, you look at the noise, you get much early signals.
So that's something which is very important for researchers to look for, and not to follow always the main path.
Warwick and his wife, they're the first couple who put a chip and started sending signal to each other. The cyborg was done, I think, 1995 or so. But it has not really worked. I'm just hearing that they have created some strip.
A new strip.
But one of the things, because when Kevin I had interacted with many, I was in UK, he was telling it didn't work because it's an invasive approach. People do not allow something to invade their system. So just a comment.
Is there any other question?
First of all, it was an amazing panel discussion. I was very much engrossed in listening to all of you. You made a very strong comment that AI is going to replace the teachers. And I'm coming from the educational background, and apart from that, I deal with robotics as well. I really want to understand your viewpoint on that. Can you please explain?
AI is the most, AI never gets angry.
No,
I'm telling you. AI will have, today, AI will have more knowledge, more ways of teaching, more knowledge about teachers from the data that it has collected. Everything AI will have. So I will show you, if you want, I can show you a tool which we are going to now take out on the ground, where for class 6 to 12, we are going to make AI teach a student. And I would, so everybody will learn at their own pace, at their own scale, at their own speed, with their own hyper-localized examples. You are not going to listen to my Ramayana and Mahabharata, you will listen to your local examples. Somebody will listen to their local tribal examples. So AI is really going to bring about education. AI is going to connect disciplines. AI is going to connect. Today we have, and I'm going to explain this tomorrow in my talk, today we human beings have divided knowledge into physics, chemistry, biology, biophysics, chemical biophysics, mathematical chemical biophysics, computational mathematical chemical, biochemical physics. Finally, those people know nothing about everything, they know everything about nothing. And that is the source of all optimization affecting. That is why we have destroyed the planet. Because we have optimized. We don't know, human beings don't know. But AI is going to connect disciplines. And that is why it is going to create the next generation in a much, much better way. What it still does not instill into a teacher-student relationship is that AI is not a human being. And a human being has something, the two human beings, when I talk to you, it is not the language. The language contains something else, which somebody inside you hears from somebody inside me, which is different from what a compute element does. That is the role of the teacher.
Yes, I agree with you, because I feel somewhere AI is not gonna help the teachers, because at that time she can pay more attention to the individual needs of the child when the AI is helping them to understand the concept and repeating it again and again. For the weaker students who need to have more information about certain topic. In the meanwhile, she can take a round and look on the students who need more attention. So I feel it's a boom and we should go and learn the technology. For example, the Petra quoted very nicely that I will give my kids the robot once I check it out, everything is safe for them. I remember when I want to learn the internet and this IT revolution was there, I was after my mother to buy me a laptop. She was scared because she was having no knowledge in the millennium time. That's how it's gonna make me distracted from my career.
Yeah,
goal.
actually, it's very important that as a teacher, being involved in teaching, and AI actually facilitates teaching.
Yes, that's what I mean.
So that will definitely will happen and happening also, and AI also enabling personalization of the teaching.
Voilà.
I think it was a very interesting, discussion. I think all of us, I myself, while coordinating, I enjoyed and learned lots of things. I hope all of you must have enjoyed it. I think let's call it a day and let's close
Thank you
this
so
session.
much. It was really engaging and nice
Thank
having
you,
you all.
everyone. And it was a great panel discussion. Thank you. It was lovely hearing all of you. Professor Behra, I would like to invite you on stage to felicitate all our panel members and moderator.
All of you enjoyed? Yes or no? Yes, loud? Yes, so, please give big hands to the panel members, moderated by Professor Santanu Chaudhary. You see, there are two ex-IIT directors in this panel. It's a very royal panel. You were blessed to hear. And I would like to also let you know, tomorrow at 12 o'clock, Professor Partha Pratim Chakravarti, the Professor of Computer Science at IIT Kharagpur, ex-director IIT Kharagpur, he is going to give an institute colloquium here at 12 o'clock noon. Okay. Sir, we have changed that from evening to 12 o'clock. Just because all programs are getting over by lunch.
So please make sure that
and also the reason
they don't get lunch.
No, and then the reason also we wanted you to visit Parasar. So if you can finish this, then you can visit also Parasar.
Oh, so if I don't, no Parasar for me.
This is felicitation.
You have to end the lecture accordingly if you want to go lecture.
We can start with Ms. Petra. Please come forward.
I will go in the morning and come back by 12.
Dr. Vijay, please come forward. Professor Aditya Nigam. Professor Partha Pratham Chakrabarti. Dr. Lavkesh Vig.
Why did you shift from PCS?
Last but not the least, moderator for the panel, Professor Shantanu Chaudhary.
Okay, I'll not give you the cap. So very nicely formulated questions. So I think we're going to
Let's take a group photograph.
Yeah, we'll take.
You wear the cap.
Yeah.
Petra, you can carry your robot also.
Yeah. No, it was, I found the panel discussion is much more meaningful than the long presentation.
Thank you.
Okay.
Thank you, everyone. With this, I'm announcing, sir. Gotipur, you want to? Yeah. Okay.
You see, at 7 o'clock, we have a very wonderful cultural program, and this is from Spikmake, and today's performance is Gotipur dance from Jagannath Puri, and it will be fantastic. It will be a very wonderful cultural evening, and after you enjoy this, there is gala dinner today. I hope you have made a first-class dinner menu. Yes or no? Yes. Okay.
8 to 9 p.m. there's another.
And 7 to 8 is Gotipur dance. And 8 to 9, there is a program that is going to highlight, that will be held outside, highlight the price of water, every drop of water. Because you don't recognize when you are in Himachal, if it doesn't rain, there is no water. Okay? And last 4 years I am here, every year the rainfall is dropping and dropping and dropping. So that will be highlighted through a cultural style that will be held outside. Okay? Yeah. So people have started coming for the cultural program. So there will be and we can have some break, but please come and enjoy the cultural program. Here only. Cultural program will be here.
It's a wrap for the program. Now enjoy the Gotipur dance performance at 7 p.m. at the auditorium. Thank you.
क्या शोर मचा के रखा तुम लोगों ने? और ये कागज किसने गिराया यहाँ पर? उठाओ इसे। गॉड, ये पानी, ये ग्लोब, ये किसने गिराया? अर्जुन, तुमने ये ग्लोब नहीं गिराया, अपनी किस्मत गिराई है। कितनी बार पढ़ाया है पर तुम्हें समझ नहीं आता ना? पानी वेस्ट, माइंडलेस बिहेवियर। और ये जो तुम अभी बाहर करके आए हो ना, देखा है मैंने। और ये फोन क्या कर रहा है तुम्हारे पास? कितनी बार समझाया है कि नो फोन नो फ्लेक्सिंग, पर तुम लोगों को समझ नहीं। मिमिक्री करना, रील्स बनाना, फोन स्नीक करना, तुम्हें तो पता है ना क्लासरूम में फोन अलाउड नहीं है।
मैम, फोन का मुझे आइडिया नहीं था, बट मैम इज ही फेलिंग होमवर्क टेस्ट?
No, no, no. It's not like that. He's not like that. He's not failing. In fact, he is brilliant. Failing. In fact, he is brilliant. Quick learner. But sometimes restless, disconnected. Rules इसके लिए just background noise है. And frankly, he's not alone. इसके जैसे और भी बच्चे हैं.
Actually, ma'am, I have been away for research this past year. We talk online, पर मुझे लगता है वो रियल वाली बात वो शायद रह गई।
अनु, अभी कल की ही बात है। वॉशरूम से बाहर आने के बाद आने वाले वीकेंड में तुम एक प्रोजेक्ट सबमिट करोगे, जिसका टॉपिक होगा वाटर सस्टेनेबिलिटी। ओके? और ये सिर्फ प्रोजेक्ट नहीं होगा, ये तुम्हारी ओके? और ये सिर्फ प्रोजेक्ट नहीं होगा, ये तुम्हारा टेस्ट होगा। फोटोज, ऑब्जर्वेशन, रियल लाइफ केस स्टडीज। अगर तुम्हें फर्स्ट रैंक चाहिए, you'll have to earn with your open eyes, okay?
पर मैम, मुझे तो कुछ नहीं पता। मैं कहाँ जाऊँ, क्या क्लिक करूँ, क्या लिखूँ?
Okay, fine. अनु, तुम इसे ऐसी जगह पर लेकर जाओ जहाँ पर पानी नहीं है, लेकिन फिर भी लोग वहाँ पानी के बिना जीने की कोशिश कर रहे हैं।
Understood.
क्या सच में ऐसी जगह है जहाँ बिल्कुल पानी नहीं है?
देखा तो था तुमने।
पर सच में क्या वहाँ के लोग बिना पानी के रहते हैं?
मैनेज करना पड़ता है।
वर्षा मैम किसी वर्चुअल वाटर के बारे में बात कर रहे थे। What's वर्चुअल वाटर? क्या ये कोई इनविजिबल छिपा हुआ पानी है?
हाँ, छुपा हुई तो है। जैसे वो ड्राउट इनविजिबल था, उतना ही इनविजिबल जितना कि तुम्हारा स्क्रीन टाइम। अर्जुन, ये है रियल वाटर, जिसको तुम पी सकते हो, फील कर सकते हो, देख भी सकते हो। और वर्चुअल वाटर, वो सब पैकेट पे यूज होता है भी सब जगह और दिखता भी नहीं है। प्यास तो लगी होगी ना? यहाँ से चलो।
दी, यहाँ तो इतने सारे ग्लेशियर्स हैं, तो फिर ये नदी सूखी क्यों है?
यही तो क्लाइमेट चेंज है।
वाह, दी, ये कितना सुंदर माउंटेन कैफे है ना?
बहुत सुंदर। अच्छा बैठते हैं।
ये मेरी चाल। हाँ।
अनुदी, चीज।
तुम्हें पता है जो ये जो फ़ोन तुम इस्तेमाल कर रहे हो, उस फ़ोन को बनाने के लिए 12,000 लीटर पानी यूज़ होता है। मतलब 12 टंकियां पानी की।
क्या मजाक कर रहे हो अनुदी?
तुम्हें मेरी बात मजाक में लग रही है? रुको बताती हूँ। देखो, हर चीज को बनाने के लिए बैकएंड में पानी का यूज होता है जो हमें दिखाई नहीं देता, उसे कहते हैं वर्चुअल वाटर। देखो, एक टी शर्ट को बनाने के लिए 2500 लीटर पानी यूज होता है, और जो पिज्जा तुम खाते हो ना उसके लिए 800 लीटर, और जो 1 किलो के हिसाब से तुमने चॉकलेट्स खा के रखी है ना, उस 1 किलो चॉकलेट के लिए भी 17,000 लीटर पानी यूज होता है।
17,000 लीटर पानी?
यस।
आपकी चाय सर।
ये क्या बना दिया भाई?
चाय है सर।
ले जा इसको। चल यार, पैसे नहीं मिलेंगे।
कमाल है सर, क्यों नहीं मिलेंगे? आप चाहे चाय पियो या नाले में फेंको, पैसे तो देने पड़ेंगे सर। कहाँ से पहुंच जाते हैं जैंगो बन के।
ये जो 1 कप चाय का टूरिस्ट ने वेस्ट किया है ना, इसके लिए 30 लीटर पानी यूज हुआ है।
अनु दीदी, ये तो आपने खप कर दी। मैं मान ही नहीं सकता, इतने छोटे से चाय के कप के लिए 30 लीटर पानी लगता है।
जिस तरह से तुम्हारे 150 रुपए के गोवा के चश्मे 20,000 के बन जाते हैं ना, क्योंकि गोवा जाने के लिए टिकट्स यूज होता है, तो सेम वे में चाय बनाने के लिए क्या क्या यूज होता है?
चाय पत्ती, चीनी, थोड़ा सा दूध और पानी, बस।
तो वो यहाँ सब कैसे आता है? उसे यहाँ तक लाने के लिए ट्रांसपोर्ट लगता है, फ्यूल लगता है। इट ऑल एड्स अप।
वर्चुअल वाटर, मेरे तो समझ में ही नहीं आ रहा। मतलब ऐसा पानी जो है भी और नहीं भी है।
हाँ, अब चाय भी ध्यान से पीना, इसमें भी पानी यूज हुआ है।
दी, फ्लड्स और ड्राउट दोनों एक साथ कैसे? This doesn't make any sense.
Because the Earth's balance is breaking, global temperature rises, तो हवा ज़्यादा मॉइस्चर पकड़ लेती है, तो जब बारिश आती है वो नॉर्मल नहीं होती, वो तूफान बन जाती है। और जहाँ बारिश नहीं होती वहाँ सब सूख जाता है, ज़मीन सूख जाती है, इट हार्डन्स, और फिर चाहे पानी अंदर आना भी चाहे वो आ ही नहीं पाता।
पर दी, trees help ना, right? Green spaces and all, they balance it.
They do, they breathe for the planet. पर हमने तो उन्हें छोड़ा ही नहीं है, सब काट दिए हैं, डिफॉरेस्टेशन। एंड इफ आई टॉक अबाउट सिटीज, तो सब जगह कॉन्क्रीट ही है। जमीन पानी अब्सॉर्ब नहीं कर पाती, सब बह जाता है, फ्लड बन जाता है।
पर दी, हिमालयस तो सेफ है ना, राइट? We are far, far away from the cities.
No अर्जुन, हिमालयस आर ब्लीडिंग टू। यहाँ पे भी ग्लेशियर्स सब पिघल रहे हैं, कहीं सूखा है तो कहीं फ्लैश फ्लड्स। और जब पानी गिरता है, ज़मीन उतनी थक चुकी है कि वो उसे संभाल ही नहीं पाती है। इट्स chaos एवरीवेयर।
पर दी, हमें कैसे पता चला इस चेंज के बारे में? Who's keeping the track? क्या किसी ने सच में इस चेंज को देखा है?
है एक मंक जो सालों से साइलेंस को सुन रहे हैं। उन्होंने ग्लेशियर्स को गिरते हुए देखा, रिवर्स को सूखते हुए देखा, यहाँ तक कि इंसानों के रंग बदलते भी। और अब तुम भी देखोगे।
चूल्हे
रिमोजी जी कहाँ है?
मेडिटेशन कर रहे हैं।
अच्छा,
मिलना है आपको?
जी
चलो
ठीक है। माइंडफुलनेस, काम, रेस्टलेसनेस। याद है ना वर्षा मैम ने क्या कहा था?
झूले
तुम पहाड़ों को देख रहे हो अर्जुन? यहाँ कभी ग्लेशियर हुआ करते थे, जमीन से बातें करते थे। आज चुप हो गए हैं। चलो आओ, तुम्हें कुछ और दिखाता हूँ। कैसे लगे तुम्हें पहाड़?
बहुत सुंदर। पर अगर अभी वो ग्लेशियर्स बड़े होते तो वो और भी सुंदर दिखने थे।
ये देखो, ग्लेशियर कहाँ तक हुआ करते थे।
कितना सुंदर है। ये वही मॉनेस्ट्री है जहाँ अभी हम हैं। कितने सुंदर पहाड़ हैं।
देखो, सूखा हो या फ्लड्स, ये सिर्फ डिजास्टर नहीं है अर्जुन, ये सिग्नल्स हैं। नेचर बोल रहा है, मुझे देखो, मुझे समझो। हमारे पूर्वज पानी को देवता मानते थे, उसे संभालते थे, समझते थे। आज के लोग बस कंज्यूम कर रहे हैं, जैसे ये कभी खत्म ही नहीं होगा।
मुझे वर्चुअल वाटर के बारे में भी पता है।
अच्छा?
ऐसा पानी जो कि चीजों को बनाने के पीछे छिपा होता है, पर वो दिखता ही नहीं है।
तब तो तुम सब समझते हो। देखो, दिखते हुए पानी को तो हम बचा लेते हैं, लेकिन छुपा हुआ पानी वही सबसे पहले चला जाता है।
पर मैं बस 13 साल का हूँ, मैं क्या कर सकता हूँ?
देखो, यही तो तुम्हारी स्ट्रेंथ है।
पर कैसे?
तुम्हारे पास क्यूरियोसिटी है और रीच भी। यूज योर फोन, नॉट फॉर डिस्ट्रैक्शन बट फॉर डायरेक्शन। देखो, टेक्नोलॉजी को अगर हम समझ के साथ यूज करें तो वो वेपन नहीं, विजडम बन जाती है।
दीदी, आप 2 मिनट अपना फोन दोगे? एक सेल्फी।
बस स्टोरी अच्छी लिखना।
थैंक यू।
पर ये तभी हो सकता है अगर तुम ग्लेशियर को महसूस करोगे। ठीक है? यहाँ से 15 किलोमीटर दूर है, जाओ वहाँ देखो। वहाँ सिर्फ बर्फ पिघल नहीं रही होती, वहाँ वक्त रो रहा होता है।
कितने सुंदर पहाड़ है।
ये पहाड़ पहले इससे भी खूबसूरत हुआ करते थे।
कितनी सारी बर्फ है यहाँ पे।
तुम्हें पता है, ये जो बर्फ दिखाई दे रही है, ये बर्फ पहले इस नदी तक हुआ करती थी।
वाओ।
लामा जी कहते हैं।
तब तो और भी सुंदर दिखते होंगे ना? क्या हम इनके और करीब जा सकते हैं?
हाँ, तुम्हें जाना है?
हाँ।
Let's go.
दी, ये बस पानी नहीं है, ये तो वक्त है। सेंचुरी से यहाँ था और है। और हमें देखो, हम माइंडलेसली इसे बर्बाद कर रहे हैं, इसे खो रहे हैं।
पर शायद हम इसे बचा भी सकते हैं अगर इसे संभाल के रखें तो।
पहुंच गए। पहुंच ही गए। कितनी सुंदर जगह है ये।
ये लो, ये लो।
Water is not a resource. It is life. It is memory. It is legacy. Ma'am, I found the answers. Not in books. Not in Google search results. But in silence. In people's eyes. In an old monk's pause. In a glacier's breath. I was looking for facts. But I found something bigger. If we, as humans, can temper our hunger, can choose less, we can save water, we can help save life. And now I know I'm not just a student, but I belong to this planet's story. मैं हर बूंद की कद्र करूंगा. Let's conserve to sustain.
Guys, you know the drill. You have to just clap for the whole show. I hope you enjoyed the movie. So it was not just a story about water. It is a story about life itself. And when the water disappears, the story disappears with it. So give it up for this. And I would like to tell you कि हमारे बीच आज जो हमारी इस मूवी की स्टार कास्ट है वो भी हमारे बीच मौजूद है. And first of all, some lessons begin with ignorance. A young mind unaware of the consequences of something as simple as wasting water. Now today with us we have the star cast and the person who played this young man. He is the KBC fame. You have seen him on Sony television in front of Shri Amitabh Bachchan. So everyone please welcome none other than Arunodaya Sharma, everyone.
Good evening, IITians.
use less, we can save water. Let's conserve to sustain. I repeat, let's conserve to sustain. Thank you.
Welcome to the Game of Thrones Season 10. The winter is not coming, the water is coming, guys. Get up for yourselves, everyone. Please give it up for yourselves.
IIT में सिनेमा हॉल है, सारी मूवीज यही लगती है। क्या मतलब अमेरिकन पाई यही देखी थी? गंदे जोक्स भी मार लेता हूँ यार, ऐसी बात नहीं। ओके, सो आई होप यू आर रेडी। यस, वी आर रेडी। जोर तालियां हो जाए आप लोगों के लिए गाइस, क्रेजी हो आप लोग यार। एंड आई एम रियली सॉरी, मैं क्यों माफी मांग रहा हूँ, इंदर देख थोड़ी ना, बट मैं फिर भी माफी मांगना चाहूंगा उनकी तरफ से। कितनी लड़कियां हैं जो मेकअप करके आई है, हाथ खड़ा करें। ये लड़के अलग पागल हो जाते हैं, खुद ये मुंह नहीं धो के आए हैं सुबह से, और ये मेकअप वाली पे हो कर रहे हैं। आइए, लेट्स, वी आर रेडी। चलिए, म्यूजिक, गिव इट अप फॉर देम यार, प्लीज। एक बार जोर तालियां हो जाए इनके लिए प्लीज। इन्होंने बहुत मेहनत की है इन लोगों ने यार, बहुत। ये जो HRTC वाले उस्ताद सीटी बजा रहे हैं बीच में, कॉलेज बस जाने वाली है आखिरी वाली। चलिए, लेट्स प्ले द म्यूजिक, लेट्स गो। We'll be showcasing the culture of Himachal. एक तो आप लोग टेक्नोलॉजी में इतना रह लिए, आपको इंसान दिखाएं तो तालियां ही नहीं बजती हैं आपकी। बताइए, ये क्या उम्मीद कर रहे हैं कि ये स्टेज ही चलने लग जाए आप लोगों की तरफ? ऐसा कुछ नहीं होने वाला है यहाँ पे, मतलब ओवर द बोर्ड कुछ भी नहीं होगा। जो तालियां आप लोग लोग लीजिए, क्रेजी हो आप लोग, कसम से ऐसा बोलना पड़ रहा है मुझे। समझ नहीं हो रहा। जो ताली अपने फिर सुन लीजिए। चलिए, now it's time to hear some music. Are you guys ready? मेरे को 1% आवाज नहीं है। अब आपने क्या करना है ना, इसकी कंसंट्रेशन बढ़ा देनी अपनी तालियों की। जो आपने इतना नॉर्मैलिटी, क्या बातें किसके सामने कर रहे हो। जोर तालियां हो जाए फॉर द फर्स्ट परफॉर्मेंस, एज इन हमारी जो म्यूजिकल परफॉर्मेंस होनी चाहिए। प्लीज गिव इट अप फॉर मनोज मास्टर एंड टीम। गिव इट अप फॉर हिम। प्लीज, ये जो सूखे सूखे लौंडे ऐसा करते हैं, वो करते हैं। मैं आपको बता दूं, आप आईआईटी में तो आ गए, थोड़ा एम्स का भी मैं ज्ञान जेब में लेके आया हूँ। तो एम्स वाले कहते हैं कि जो सूखे सूखे लोग ऐसा करने की कोशिश करते हैं, कई बार फेफड़े बाहर आ जाते हैं। प्लीज अपने फेफड़ों का ध्यान रखना आप लोगों ने, क्योंकि इसके बाद आपको और भी हू करने की जरूरत पड़ेगी। जोर ताली आप लोगों के लिए होनी चाहिए। एवरीवन, यू आर रियली क्रेजी गाइस, बहुत ही क्रेजी हो आप। अच्छा, गिव मी सम चीयर। इस दुनिया में इतनी सारी आवाजें हैं निकालने के लिए, व्हाई हू? आई नो इट्स कॉपीड, बट व्हाई हू? ओके, एक एक्सपेरिमेंट करूं मैं आप लोगों के साथ। ओके एवरीवन, एक एक्सपेरिमेंट करें। इस बार जब मैं बोलूंगा ना गिव मी अ चेयर, तो अलग अलग आवाजें निकाल दिए, हू कोई नहीं करेगा। ठीक है, ठीक है, करें, ट्राई करें। ओके एवरीवन, गिव मी अ चेयर। अभी भी हू ही सुनाई दे रहा है, सिंक्रोनाइज होके हू भी आ रहा है। मैं बता रहा हूं, हू के अलावा कोई भी आवाज, टर टर कुछ भी हू नहीं करेंगे। ठीक है, एक्सेप्टेड, पक्का? ओके एवरीवन, गिव मी अ चीयर। अब मेरे को समझ आया कि हू क्यों करते हैं। बहुत गंदे लग रहे थे आप लोग। तालियां हो जाए आप लोगों ने, क्रेजी हो आप लोग। उफ, मतलब क्या एनर्जी है भाई आईआईटी में, कुछ तो एनर्जी है। एक तो यहाँ पे आते लड़की को छेड़ रहे हैं आप, लड़का होकर। सर, अब लड़का होकर लड़की को छेड़ रहे हैं, कहाँ तक ठीक है ये? चलिए, ओके एवरीवन, लास्ट वर्ड्स, गिव मी अ चीयर।
Chip. Hello everyone, welcome to all this lovely evening. This is Manoj and my back and Nitish. So this is a Himachali folk medley. Shake. Hope you like. Shake.
आजा भाई, आता हूँ।
Guitar.
आजा आजा, क्या बादल रहा है।
थोड़ी सी ऑटिंग
बात करें।
कपिल को भी, कपिल